Hey guys, this is Hemant from EduReka. Today in this session we'll be talking about Amazon Web Services. So without wasting any more time, let's just move ahead and see what is our agenda for today. So we'll be following a top-down approach. We'll start off with what is cloud and then we'll move on to what is AWS. After that we'll be discussing the different domains which are there in AWS, followed by the AWS services. So I'll be briefing you guys up on all the AWS services which are out there. After that, we'll be discussing the AWS pricing options. So we'll be discussing all the key points which are there in AWS pricing. Once we're done with all the learning, I will teach you guys how to migrate your application to the AWS infrastructure. And in the end, we'll be solving a real life problem using the AWS knowledge that we'll be gaining today. So guys, this is our agenda for today. Are we clear with it? All right, I'm getting yeses. Michael says yes. Sandeep says yes. Neil says yes. All right, guys, let's go ahead then. So before starting off with what is cloud, let us see what were the problems that people faced before cloud computing. So before cloud computing, if you had a use case, if you had to host a website, how would you do that? So first of all, you had to buy a lot of servers. Why servers? Because obviously you'll be hosting a website on something, right? So you had to buy a lot of servers. And every website has a peak time. So keeping that peak time in mind, you had to buy some more servers. Thirdly, you have to monitor and maintain these servers. Since these are your own servers, you have to continuously monitor them so that your application doesn't experience any downtime. And once you encounter a problem, you have to maintain them, right? So these are the things that you have to do. Now these things led to problems. Now what are those problems? Let's address them. So first of all, this setup was very expensive since you're buying a lot of servers, and guys, servers are not cheap. They're very expensive, right? So this setup was very expensive. Secondly, since you have to troubleshoot problems, they used to conflict with your business goals because your aim should be making your application better, right? But if you're also thinking about whether your application is or is not facing any downtime, or is your server hardware configuration is up to date or not, you are not investing that much time on your application as you may need to, right? So it used to conflict with your business goals. Thirdly, since your traffic is varying, your servers will be idle most of the time. So what this basically means is, since you bought a minimum number of servers, keeping the peak time in mind. Now, what about the time when the peak time is gone, right? Let's take an example. Say suppose your peak time is between 4 p.m. to 6 p.m. And when I say the peak time, the time when your website is experiencing the most traffic, right? So if your website is experiencing the most traffic between 4 p.m. to 6 p.m. and you place in say 5 servers to handle that kind of traffic, what about the time which is there after 6 p.m.? After 6 p.m. when the traffic goes down, you say you need only 2 servers which can handle that traffic now. What about those extra 3 servers, right? They become a liability on your investment because since you've invested a lot on those servers, but you cannot utilize them now because you don't have the need for them after 6 p.m., right? So it becomes a bad investment, hence it was a problem. So these were all the problems that people faced before cloud computing. Now we had to fix these. So let's see how did we fix them. So we came up with cloud computing. So now in cloud computing, instead of buying servers, you actually rent them, right? So instead of burning a lot of your investment on buying servers, you can actually invest it on some other things, maybe a better idea or maybe hiring more people, right? So first of all, the foremost thing that you are renting servers cuts down your cost into a fraction. Secondly, scalability was a problem. So now with cloud computing, you can scale up or scale down according to your needs. So you don't have to foresee what kind of future your application will have or what kind of future or what kind of traffic will be coming in the future. As and when the traffic comes in, you can scale up or scale down as and when required, right? So scalability was again an issue which has been solved with cloud computing. Thirdly, now you don't have to manage your servers. All of that tension will be done by your cloud providers. You just have to focus on your application. So your cloud provider will manage all the updation which is required, the security patches to ensure that your application is not facing any downtime. The only thing that you have to do is choose the right cloud provider. Because if you choose a new player which is out there in the market, just for saving a few dollars maybe, your application may not become that much successful because new cloud providers are not equipped to handle the kind of problems that you might face, right? So you have to be very careful when you're choosing your cloud provider. So guys, this is how we address the problems that we faced before cloud computing. Now, any questions until now, any questions that you have that should be answered before we move ahead? Alright, I have a question from Michael. So Michael is asking me on which parameter we should decide to choose which cloud provider. Alright Michael, good question. Michael, you have to consider in a lot of things. Say suppose let's talk about AWS. So AWS came in the cloud computing market in 2006, right? And if you compare it with other cloud providers, say suppose Azure. So Azure came in 2010. Right, so compared to Azure, AWS has a more mature model of infrastructure. And if I was you, I would choose AWS on Azure because AWS has seen a lot since it has started. It has become better in terms of handling problems which come up when you're hosting someone else's application. Apart from that, you also take into account what kind of server capacity does a cloud provider have and what kind of companies are associated with the specific cloud provider. So suppose if you talk about AWS, so AWS is hosting application for Netflix, which is a very successful video application. So if Netflix is not facing any downtime, you can be assured that your application is in safe hands as well. Right? So these are all the parameters that you take in mind when you're choosing a cloud provider. So Michael, does that answer your question? All right, Michael says yes. Any other question, guys? Anything related to cloud computing, how cloud computing became important to us, or why cloud computing came into the picture? All right, since it's a yes from all of you, let's move ahead. So now, since now we've understood what was the need that led to cloud computing, let's understand what cloud computing exactly is. So what is cloud computing? So cloud computing is the use of remote servers to store, manage and process data. So you do three things. You store, you manage and you process data. So when I say store, you're storing your files, say on a file system on the cloud. So when I say manage, you're managing your data using databases there on the cloud. You process your data. So you're using computing power on the cloud to process your data. Say suppose you have a huge chunk of file that has to be processed, right? And you don't have that kind of machine in your own infrastructure. So you can always rent a server from AWS with the right kind of configuration. And you can use that machine to process the data or process the file that you want to process, right? And once you're done with that, you can always terminate a machine and you will pay AWS according to the number of hours that you have used it for. And that is the power of cloud computing. You don't have to buy that computer exclusively to process that file. You can rent that server from AWS, use it and pay them according to your usage. Right? So guys, this is what cloud computing is all about. Any questions, any kind of doubts that you have regarding cloud computing now? So Michael is asking me, so is it pay for use? Yes, Michael, you pay according to your usage. Yes, you're bang on. It's this, the pricing model is pay per use. Good to know that you know about cloud computing, Michael. Any more questions, any more suggestions, guys? Any more thing to add which I just told you guys? All right, Michael says no. Sandeep says all good. All right, I'm getting confirmations. All right, guys, let's move ahead then. So we talked about cloud computing and how it is a successful model, right? So it is bound to have competition in the market. So if you want to become a cloud provider, you will have a lot of competition in the market because this concept is huge. It's very advantageous. It's very successful, right? So a lot of people are trying their hands at cloud computing. But it's a fact, there are a lot of cloud players out there. But why are we discussing about AWS? Why are you learning about AWS? Why do you want to become a solution architect for AWS, right? So let's put a light onto that and discuss why AWS. So these are the three parameters that we'll be discussing. So first up, we have AWS Global Cloud Computing Market Share. So AWS has a global cloud computing market share of 31% as compared to its competitors, which have a cloud computing market share of 69%. Now you would say 31% is nothing compared to 69%, right? But then the thing here to understand is that AWS alone has a share of 31% in the global cloud computing market share, and no one, even not even Azure, which is the closest competitor to AWS, has a number even near to 31%. So this number is huge. AWS is leading by a very huge margin. Let's talk about the second parameter, which is the server capacity. So let's consider that all of its competitors combined, when I say it, I mean AWS. So all of AWS's competitors combined, say, have a server capacity of X. AWS alone has a server capacity of 6x, which is 6 times the server capacity of all of its competitors combined, right? So if you have an application which is very successful and you foresee that there's going to be more traffic in the future, your safest bet would be on AWS because they have that kind of infrastructure for your application to grow. And that is why AWS has such a large user base. Let's come on to the third point, which is flexible pricing. Now, any enterprise, big or small, wants flexibility in its pricing, right? They want to cut down their cost. They want value out of their money, right? And that is what flexible pricing is all about. So AWS charges you for the hour, right? So when you use AWS servers, and suppose you use them for 3 hours, you don't have to pay for the whole day or for the whole month. You just pay for 3 hours. And with this kind of flexibility in their pricing, it has attracted a lot of customers, right? So this is the reason that AWS is so successful today in the market, and that is why you guys are learning about AWS today. But that does not mean that the other cloud providers are not performing well. If you look at Azure, which was just launched in 2010, it is the closest competitor to AWS. But if you see the current scenario, if you take in mind the current scene, AWS is still leading, AWS has more job opportunities, and AWS is more successful than any other cloud provider. Maybe 3 years or 4 years down the line, other cloud providers will start coming at par with AWS, or maybe they'll surpass AWS. Like I said, if you see the current scene, AWS is the thing, and that is the reason we are learning about AWS today. That is the reason you are here. That is the reason I'm teaching you guys about AWS today. So guys, are we clear why are we learning about AWS, or why you guys are attending AWS's training rather than some other cloud provider? All right, Michael says yes. Others, Neil, Sandeep, okay, they say all good. So everybody is giving me a yes. So let's go ahead. So since now we have understood the why of AWS, let's understand the what. So what is AWS? So AWS is a secure cloud services platform. So it's a platform on which Amazon offers its cloud services, and it offers its cloud services in compute, database, content delivery, and other domains. So AWS is a secure cloud services platform. So it's a platform on which Amazon offers its cloud services. In what it offers its cloud services? It offers cloud services in compute, it offers cloud services in database, and a host of other domains. So having said that, let's discuss the different domains in which AWS offers its services. But before that, guys, any questions that you have regarding what AWS is about? All right, Neil says no, Sandeep says no, Michael says no. All right, guys, let's move ahead then. So let us now discuss the different domains in AWS. So these are all the different domains in which AWS offers its services. So first up, we have compute. So in compute, there's a service called EC2. So EC2 is Elastic Compute Cloud. So it's just like a raw server. So you can configure the server to be anything. You can use it to host a website. You can use it as a work area environment. It's a clean slate. It's just like a new PC that you buy. So install a fresh operating system on your PC, and then you can configure it to be anything. You can install any software you want, and then it can serve you as you require, right? And that is what EC2 does as well. Right, so this is the compute domain. Next up, we have the migration domain. So migration domain is when you want to transfer your data to the AWS infrastructure, or you want to transfer your data back from AWS infrastructure. Next up, we have the migration service. So this migration service is used to transfer data to and from the AWS infrastructure. So if you have petabyte scale of data in your data warehouse or in your data center, and you want to send it to AWS infrastructure, you would be using services in migration. Now there's a service called Snowball in migration, which is used to physically transfer your data to AWS infrastructure, right? So basically what AWS does is, it sends you a physical device which is just like a hard drive to your premises, and you transfer your data onto it, and then AWS ships it back to the infrastructure. Now this is Snowball. So it offers similar services in the migration services. Now you would ask me, why are we sending our data physically to AWS infrastructure? Why not through the internet? So like I said, if you have petabyte scale of storage in your data center and you have to send it to AWS infrastructure, it is better to send it physically rather than sending it on the internet. You can imagine it just like giving some data to your employees. Would you give it on a hard drive, on an external hard drive if the data is large, or would you send them an email regarding that, right? So just like that, you can imagine this scene. Next up, we have the domain, we have security and identity compliance. So in security and identity compliance, you have services like IAM, which is used to authenticate users and define user rights to them. So say suppose you're running a company and you have a root AWS account. Now you want other employees to work on your AWS account as well, but you want them to have restricted access. Say suppose you want user 1 to maybe just launch instances, and user 2 can only edit instances but not launch instances. Maybe user 3 can only review the instances and not launch or edit these instances, right? So all of these granular permissions can be given to your users using IAM, and that is what security and identity compliance domain is all about. Next up, we have the storage domain. So storage domain would include services like S3, which is simple storage service. So it's a file system. It's an object-based file system in which you can store your files and access them as and when required. Right now, people usually get confused between the storage domain and the database domain because basically they're storing data, right? So why two different domains? So storage, like I said, would include services like S3. So it's a file system. Now, what is the difference between a file system and a database? So a database cannot include your executable files. So say suppose you have an image file. So that image file would not be stored in a database. It's better to store that image file in a file system and hence access that image file using a path which can be stored in the database, right? So this is basically the difference between a file system and a database. So like I said, it includes services like S3. So S3 is an object-based file system in which you have buckets and objects, which we'll be discussing further in our slides. Moving on, we have the networking and the content delivery domain. So it includes services like Route 53. So Route 53 is a domain name system which basically redirects your traffic from the URL that you purchase from, say, a domain selling website like GoDaddy, and redirects it to your instances or your servers which are hosting your web application. Why do we do this? Because you cannot remember the IP addresses, right? You need something solid, you need something simple. And that is what domain system is all about. It translates the simple into the IP address and redirects your traffic to that IP address, right? So this is about Route 53. Next up, we have the messaging domain. So messaging domain is all about services like, say, suppose simple email service. So it is used to send emails in bulk to your customer base, right? So if you have an application where you have to notify your customers about a new update, so rather than sending emails to each and every customer, you can, with a click of a button, you can send it using SES, and you can also handle the replies that customers give, right? So all of that can be managed using SES, which is a simple email service which comes under the messaging domain. Next up, we have the database domain. So database domain would include services like RDS, which is a relational database service. So a relational database service basically manages some databases for you. It's not a database in itself, but it's a managing service which manages databases for you. So it can manage databases like MySQL. It can manage databases like PostgreSQL. And when I say manage, they can automatically update the DB engines, or they can automatically commit to your changes. All of that is managed using a management service in Amazon, which is RDS, which comes under the database domain. Let's move on to our last domain, which are management tools. So management tools are basically tools using which you can manage your AWS resources. So in this domain, you have services like CloudWatch, which is an all-in-one cloud monitoring tool. So you can use this tool and monitor all the AWS resources that you have running in your AWS infrastructure, right? So guys, these are the different domains in AWS. These are the different areas in which AWS offers its services. Any doubt regarding any of the domains that we just discussed? All right, I have a question from Neil. So Neil is asking me, what is content delivery? So good question, Neil. I mentioned content delivery and not explain what content delivery is actually about. So content delivery is basically a caching service. So what it basically does is, if there's a user which is far from a server which is he's trying to access, so data on that server is cached to a location near the user so that the latency becomes low. so that the response time is faster, right? And that is what content delivery is all about. I will be covering content delivery in detail in the coming slides, so just have a little patience. I'll explain everything in detail. Any more question, guys? Anything related to the domains that we just discussed? All right, Neil says all clear. Michael says no. Sandeep says no. All right, guys, let's move ahead then. So since now we've discussed in what areas AWS offers its services, let's discuss the AWS services, right? So the first domain in AWS services is AWS compute domain. So let's discuss the services under compute. So the first service is EC2. So EC2 is the most important service in the whole of the compute domain. So why do I say it's the most important service? Because EC2 is the base, and the other services which are Lambda and Elastic Beanstalk are just advanced version of EC2. How? Let's discuss that. So EC2 is, like I said before, is just like a raw server. Now you can configure this raw server to be anything, right? You can configure it to be a web server, like I said, or a worker tier environment or something else. Now, and this web server can be resized according to your needs. The instances or the servers that you've launched, they can be replicated, as in you can launch multiple servers of the same configuration, or you can also increase the configuration as well, right? So this is the kind of resizability that you get with EC2, and this is what EC2 is all about. So guys, are we clear with what EC2 is? So the first service in the computing domain is EC2. So EC2, like I said, is just like a raw server. You can configure EC2 service to be anything. So it can be configured to become a web server. It can be configured to become a worker tier environment. The softwares that you require can be installed, and the server can be configured in any way required, right? And that is the kind of independence you get that when you're using EC2. But what is the difference? You can resize a server as and when required. It can be resized according to the number of servers that you're using, as in if you're using, say, suppose a particular configuration and you want to deploy the same configuration again, and you want to host or you want to serve your application through these number of servers, you can do that. Or otherwise, you can also increase your configuration on your particular instance. Now, the way to understand this is, say, suppose you're using the i3 configuration right now, and you're using the i3 processor on AWS, and you want to go on to i5. You can do that. You can do that kind of resizability as well. So this is the kind of flexibility you get when you're using EC2. So guys, are we clear with what EC2 is all about now? All right, people are giving me a yes. All right, guys, let's move ahead. So let's move on to our second service now, which is AWS Lambda. So AWS Lambda, like I said, is an advanced version of EC2. So it's based on EC2, but the difference between EC2 and Lambda is Lambda cannot be used to host your application. Lambda can be used only to execute your background tasks. Now, what are your background tasks? Say suppose you have an application, right? And your application is all about images. So when you upload an image, that image is compressed and it is stored on a file system, right? So your image will first be uploaded to the file system, right? So when the image is uploaded, that is performed by our application. Now the tasks which have to be done in the background, like the compression, or maybe you have some more tasks like applying filters and everything, these tasks are background tasks. And these tasks can be executed using AWS Lambda. Now, how does AWS Lambda functions is like this. AWS responds to events. So there are triggers that you set up in AWS Lambda, and in response to these triggers, AWS executes the code, right? So in this case, in our example that we took, that we are uploading a file, right, or uploading an image. So the moment that image gets uploaded to, say, suppose S3, which is the file system for AWS, a trigger is generated, and that trigger is being listened by AWS Lambda. So when that event is listened by AWS Lambda, it responds to that event using the code that you provide. It executes that code and then sits again and waits for another event to happen, right? Now that code would include your code for compression, applying filters, etc. And that is how AWS Lambda functions. So guys, are we clear with how AWS Lambda functions and what AWS Lambda is all about? And what is the difference between EC2 and AWS Lambda? Right? People are saying yes. All right, guys, let's move to our next service now. So our next service is Elastic Beanstalk. Elastic Beanstalk is again an advanced version of EC2. But with this, the difference between Lambda and EC2 and Elastic Beanstalk is that first of all, Elastic Beanstalk is used to host an application. So if you compare it with AWS Lambda, this is the difference. Elastic Beanstalk is used to host an application. Lambda is not used to host an application. So this is the difference between Lambda and Elastic Beanstalk. Now let's talk about EC2 and Elastic Beanstalk. So Elastic Beanstalk is an automated form of your EC2. How? With Elastic Beanstalk, you don't have to configure in all the details, you don't have to set up your environment. Say suppose you have a PHP website that you want to host on EC2. Now for your PHP website to be hosted, you first have to create a PHP environment in your EC2, right? But with Elastic Beanstalk, you don't have to do that. You just have to select what kind of environment you want, and AWS will install all the configuration files required and will give you the environment on which you just have to upload your code, and your application or your website will be deployed. Right? So this is how simple Elastic Beanstalk is. You create your environment and then you upload your code. That is it. Nothing else is required. So as you can see in the diagram, say suppose you have a PHP code. So you create a PHP environment first, launch it. Once that environment is created, you upload the PHP code and your application is deployed. As simple as that. So guys, are we clear what Elastic Beanstalk is all about? All right, people are saying yes. Neil has a question. So Neil is asking me, when would you use EC2 and when would you use Elastic Beanstalk? Very good question, Neil. So Elastic Beanstalk has a limited number of environments, right? So if you have an environment or an application which has to be hosted, and the environment is listed in Elastic Beanstalk, you should go ahead with Elastic Beanstalk. But say suppose your environment is not there in Elastic Beanstalk. Maybe Elastic Beanstalk is not ready to host the environment yet. Maybe your use case is not about hosting an application. In that case, you would be using EC2, right? You'd not be using Elastic Beanstalk. So these are the differences, Neil. Any doubts in what I just explained, or do you need any more further explanation on this? All right, Neil. Any other question, guys, regarding the differences between the EC2, Lambda, and Elastic Beanstalk? Any confusion that you guys have? So Michael is asking me, does this mean that configuration is easy in EC2? No, Michael, I mean it the other way around. With Elastic Beanstalk, the configuration is easy because you just have to select, like I said, right? If you want to host a PHP website on your server using Elastic Beanstalk, you have to select the PHP environment. But if you were to do that in EC2, which was a raw server, you can do the same thing in EC2 as well, but you first have to install the PHP software in EC2. And by PHP software, I mean you have to install the PHP environment in EC2 so that your machine is now ready to understand PHP, right? And you also, since you have to host a website, you have to configure your firewall to be secure. You have to configure your firewall, allow incoming traffic onto your server, right? So all this configuration has to be done in EC2. But with Elastic Beanstalk, you don't have to do all these configurations. Everything is done automatically. You just choose whether you want a worker tier environment or you want to create a server for website hosting. You select website hosting, you choose your environment, and you upload your code. You don't have to deal with the firewalls. Everything is managed automatically. So does that answer your question, Michael? All right, Michael says, is any other question, guys? Any doubts that you have? All right, people are giving me a go. Okay, guys, so let's go ahead. So let's discuss what is Elastic Load Balancer. So Elastic Load Balancer basically is used to distribute your workload among a number of instances, right? Now, the traffic which will be coming on these instances has to be distributed equally among these 5 or 6 instances, right? And this is what Elastic Load Balancer does. Now, why is this important? Say suppose you have 4 or 5 servers running and all your traffic is directed to your first instance, right? So it doesn't make sense because all your other 4 servers are idle. You have the capacity with you, but you have not installed a protocol using which the traffic can be distributed to these 5 instances. And that protocol is Elastic Load Balancer. So Elastic Load Balancer distributes the workload equally among the instances so that the work is done efficiently, and also the work is consistent. As in, if I am using, say suppose, a website which is being hosted on AWS, I should experience the same kind of response time as you are experiencing using the same website, right? Say suppose my request is going to the fifth server, which is less busy, and your request is going to, say, the first server, which is more busy. In that case, your response time and my response time would become different. That is why we use elastic load balancer. So if I am using your website and you are using the same website, you and me will experience the same kind of response time because it's being distributed equally among the instances, and the instances are busy on the same level. So this is what elastic load balancer is all about. Any questions, guys, regarding elastic load balancer? Any kind of doubt that you have regarding the service? All right. Let's move on to our next service, which is auto scaling. So auto scaling is a service which is used to scale up and down automatically without your manual intervention. Now, how do you do that? You set up metrics. Now, say suppose you have a website running and that website is running on 5 servers. Okay, and you configure a metric that whenever combined CPU usage goes beyond 70%, launch a new server, right? So whenever your CPU usage will go beyond 70%, it will launch a new server, and then focus, guys, and then the traffic will be distributed among the 6 instances, right? So I said distributed. So this work is done by elastic load balancer, and that is why auto scaling and elastic load balancer go hand in hand. They have to be used together. So if you're using auto scaling, you have to use load balancer as well, right? And like I said, you can scale up using that metric, and you can also set a metric for scaling down. Say suppose your combined CPU usage goes below 50% or goes below 10%. So you can configure your auto scaling to decommission a server in that case, and hence you can scale down from the number of instances that you're running. And again, your workload will now be distributed to, if you had 5 servers before, it will now be distributed to 4 servers, which again incorporates elastic load balancer. So like I said, auto scaling and elastic load balancer have to be used together. So guys, any question regarding any of the services that we just discussed? All right, Neil says all clear. Sebastian says all clear. Michael says all clear. All right, guys, let's move ahead. Before moving ahead, let's make it interesting. We have studied a lot of theory. Let me deploy a new EC2 instance for you guys. So let's go ahead and deploy a new EC2 instance. So I'll go on to my AWS console and sign in. So this is how your AWS dashboard looks like. These are all your services, right? So since we have to deploy a new EC2 server, we'll be clicking on EC2, which you can find under the compute domain. So let's click on EC2. Now this is the EC2 dashboard. Over here you can monitor your EC2 instances. As you can see, I have 2 running instances as of now, and I have 4 snapshots, 4 volumes, and 51 key pairs. Right, so you can monitor your EC2 services from over here. Since we are launching a new instance, we'll click on Launch Instance. Alright, now you have to choose an AMI. So AMI is nothing but an operating system that you would use to, that you would want on your EC2 server, right? For now, let's launch a Windows server. So let's click on Windows. Now you will be asked for the kind of instance that you have to select. Alright, you don't have to worry about the instances as of now. You can select the t2.micro. And don't worry, because we'll be discussing everything in detail as we move ahead in our journey, and when we come down to the EC2 module, we'll be learning all about these different instances. So for now, just click on t2.micro and click on next. Now it's asking me how many instances do I want. Okay, since it's a demo option, since it's a demo, I'll launch only 1 instance. And then it's asking me the networking settings and everything. Okay guys, don't worry, everything will be discussed in detail in the EC2 module. For now, let's just focus on deploying this instance and click on next. Ignore if you don't understand, I will explain everything to you guys. Alright guys, now we come on to add storage. So with Windows, by default, you have to launch with a minimum of 30 GB. You can also expand it over here as per your requirement. So I'm okay with 30 GB. Let's click on next. So now we have to add tags. So what do you want your instance to be named, right? So you can give your name over here. So the key is name, the value could be a Windows server, right? Let's click on configuring security group. Alright, a security group is basically like a firewall on your instance. It is used to control the inbound and the outbound traffic which comes on your server. So how to do that? We'll do that in the modules that'll be coming in the coming weeks. For now, just understand what security group is all about. So it is used to control the inbound and outbound traffic. If you don't understand that as well, it is okay. We'll just click on review and launch. So we'll review all the settings which we have just done. Everything looks fine to me. Let's click on launch. Alright, this is a very important step. Now the way you get authenticated to your instance is with a private key and a public key configuration. So it's called a key pair. So basically you can create a new key pair as in a new public key and a private key, or you can use an existing one. So the public key is kept with AWS and the private key you can download, and whenever you want to connect to your instance, you'll be using the private key. You'll be uploading a private key to the console that you have for launching your instance, and that private key will be matched against the public key, and you will be given a password, and using that password you can connect to your instance, right? So whenever you're creating a new key pair, you have to keep your private file handy and you have to keep it safe, because once you lose it, you cannot connect to your data is gone, right? So you have to be very careful with your private keys. So for now, let me create a new key pair for you guys. So let's click on create a new key pair and give it a name, say AWS demo, right? So let's download our private file. Alright, it says that AWS demo already exists. Okay, let me give it AWS demo 1 and click on download key pair. Alright, my private file has now been downloaded. Cool. Let's now launch my instance. So my instance is now launching. Meanwhile, let's go back to the EC2 dashboard and check if you can see if our instance is being listed there. So we'll go to EC2. So as you can see, we had 2 running instances before, but now we have 3. So since we have launched a new EC2 server, we can see 3 running instances, right? So let's click on it and it will list you all the services which are running. So we named our instance to be Windows Server, so here it is. The instance type is 32.micro. You can also look at the key pair that we have launched it in. So it's called AWS Demo 1. You can see the timestamp here and you can see the security group here. So once you click on your instance or once you select your instance, you can see all the details attached to your instance. Say suppose the public IP. So this is the IP that you'll be using to connect to your instance. So your instance type, your instance ID, the VPC, subnet, everything can be monitored over here. So the way we'll be connecting with this Windows instance is using a remote desktop connection. So once you open your remote desktop connection, it will ask you for an IP address, right? So that IP address has to be copied from here. So this is your IP address that you'll be copying. So once you copy this IP address, it will ask you for the username and the password. So by default, Windows uses a username called administrator, and for the password, you have to upload your PEM file, which is over here on your launch console, and it will decrypt a password for you by matching the private key with the public key, which is there with AWS, and then using that password, you can connect to your Windows instance. Sounds simple, right? So let's do it. It's still initializing. Let's wait for it to initialize and then we'll start with our demo. Meanwhile, guys, do you have any questions as of now? The services, the EC2 service which I just launched, do you have any doubt in whatever steps I just did? Alright, people are saying no. Alright, guys, let's just wait for instance to be launched then. So our Windows server is now running. We can see that it says green over here and it says running. Alright guys, let's launch or connect to our instance now. So you'll be clicking on actions and you'll be clicking on connect, right? Then you'll be prompted on for the screen and then you'll click on get password. Once you do that, you'll be asked for a key pair path. Let's choose our key pair now. So we'll go to desktop and we'll choose the key pair which is AWS Demo 1. We'll click on open and we'll click on decrypt password. So I can see the password here now and I can see the username, right? Let's now connect to our instance. So let's copy the password to somewhere. So this is our IP address. So like I said, we will copy this IP address and we will launch the remote desktop connection. So it's asking me the IP address. I will paste the IP address over here and click on connect. So it's asking me for my credentials. So since my username is administrator, and then I will copy the password that I decrypted. Let's click on OK. So as you can see, it's now connecting to my server, which I've launched on the AWS infrastructure. And this is it. So this is your desktop, guys. This is the server that you launched on AWS infrastructure. So just like a fresh operating system, you can click on start. You can see the way you would see it on your machine. Now you can install any software over here and you can configure this server to be anything. Pretty cool, right? So guys, this is what EC2 is all about. This is how you connect to your EC2 server once you launch it. Alright guys, let's come back to our slide. So we just learned how to launch an EC2 server on AWS infrastructure. We learned how to connect to a Windows instance on AWS. Alright guys, any kind of doubts that you had in the demo session or any doubts in the services which we just saw? Alright, Michael says no, Neil says no, Sandeep says all okay. Alright guys, let's move on to our second domain, which is AWS storage domain. Alright, so let's discuss the services in the storage domain. So first up, we have these S3, which is simple storage service. So S3 is a file system. So it's an object-oriented file system, which basically means that all your files that you upload on S3 are treated as objects, right? And these objects have to be stored in a bucket. Now, what do you mean by a bucket is you can consider the bucket to be a folder. So the root folder has to be a bucket, right? You cannot just upload files onto S3. You have to first create a bucket. Inside this bucket, the secondary folders are called folders as in the normal lingo. But the first folder, the folder in the root, is called the bucket. Now, once you create a bucket, it's very simple. You can upload your files, and these files in the AWS lingo are objects. Alright, so you can upload your objects and these objects will have a certain path which you can incorporate in your application, and that is how you can access your file from your file system. So this is what S3 is all about, pretty simple. Next, move on to our next service, which is CloudFront. So CloudFront is that content delivery network that I explained to you guys. So it's a caching service, like I said. So as you can see in the diagram, if a user wants to connect to a website which is very far from the user's location, that website can be cached to a location which is near the user, and from that location the user can access that website. Now, why would you do this? Is because the response time becomes less in this case. So say suppose if you were using that website from that far off server, you were getting a latency, say suppose around 0.7 seconds or zero point 0.8 seconds. Now with this caching, you can get the same website for around 0.2 seconds or zero point 0.3 seconds. Now this is very huge when you compare it at a global level. And that is what content delivery networks are all about. So guys, any question in the content delivery network or Amazon CloudFront which we just discussed? Alright, Michael has an interesting question. So Michael is asking me what are edge locations. So someone has done their self-study. Alright, Michael. So this server that we are talking about, the server that's been used to cache your website, that is a web server which is near your location, is called an edge location. Right? So when the user is trying to access the website which is far off, and if they have enabled content delivery network in them, that website is cached to a location which is near the user, and this location is called edge location. So basically this location would comprise a group of servers on which the data is cached, and edge locations are nothing but the name given to these group of servers. So Michael, does that answer your question? Alright, any more questions guys? Alright, everybody is giving me a go. Let's move on to our next service. So our next service is Elastic Block Storage. So Elastic Block Storage is basically like a hard drive to EC2. So when you're using EC2 instances, obviously your operating system or your software is being stored somewhere, right? So EC2 is backed by EBS for that matter. So EBS basically acts as a hard drive for EC2 and it cannot be used independently. It has to be used with EC2 only. Another interesting fact about EBS volumes is that one EC2 instance can be connected to multiple EBS volumes. But the vice versa is not true. One EBS volume cannot be connected to n number of EC2 instances or more than one EC2 instances. Each EBS volume can be connected to only one EC2 instance. And why is that? Is because you can imagine it like this. So if you have one hard drive and at one time that hard drive can be only be connected to one computer or one motherboard, right? You cannot connect that same hard drive to 2 or 3 motherboards, correct? And that is the same case with EBS as well. So it's pretty logical when you think it like that. Any question, guys, regarding EBS? Let's go ahead. Let's move on to our next service, which is Amazon Glacier. So Amazon Glacier is a data archiving service. So basically when you have to back up data from your, say suppose S3 or your EC2 instance, you back it up on Amazon Glacier. So why would you back it up on Amazon Glacier is because they use magnetic tapes and these magnetic tapes are cheap and hence your data storage on Amazon Glacier becomes cheaper, right? Now, why would you store on Amazon Glacier or which data would you store on Amazon Glacier? So you would store data which is not that frequently accessed. Your use case could be something like a hospital wherein you have to store test records of all your patients, right? But what about the test records which are more than 6 months old? Those patients are not returning, right? So you can store that data on Amazon Glacier, and if tomorrow, maybe in some time when that patient returns, it can always be retrieved from Amazon Glacier. Obviously, since it's cheaper, the retrieval time will be more if you compare it with S3 or with EC2, but then it's worth it because it's cheaper. So this is how you would use Amazon Glacier. Any doubts, guys, about what Amazon Glacier is or which data would you store on Amazon Glacier? All right, Michael says no, Sandeep says no, Neil says no. All right, guys, good going. Let's move on to our next service, which is Snowball. So Snowball is a way of transferring your data to the AWS infrastructure or transferring your data back from AWS infrastructure. Now, how do you do it? Is like this. So you have your data in your data center, right? Your Snowball device is connected to your data center and all of your data is transferred to the Snowball device. Now this Snowball device is then shipped back by AWS to its infrastructure and then your data is uploaded. Now when will you use it? When you have a large amount of data or you have petabyte scale of data, which if you're trying to send it across using the internet, it will take a long time. But if you're using Snowball, right? So using Snowball, this data transfer process becomes more fast because you're physically transferring the data and that data is being transferred in bulk, right? And that's where Snowball comes in handy. So guys, this is what AWS Snowball is all about. Any question related to AWS Snowball? All right, people are saying no questions. All clear. All right, guys, let's move ahead then. Okay, Michael says, can you explain me once more? All right, Michael. So our next service is Snowball. So Snowball is basically a physical device which is used to transfer data from your data centers to the AWS infrastructure. Now say suppose you have an application and you decide to make a move to the cloud, right? You're hosting your application on your own for now, but now you have decided, okay, I want my application to be on the AWS infrastructure. Right now your application is already running, it is very successful, it has a huge data set that is being served by your servers on your own data center. Now this data set has to be migrated to the AWS infrastructure, right? Now the way you can do it is in two ways. You can either transfer it online or using the internet. You can do the transfer using a physical device, right? Now this physical device is Snowball. So when will you use Snowball and when not the internet is when you'll have huge amount of files, right? When you have say data at a petabyte scale, in that case you would use Snowball to transfer your data. Right now, how this process happens is like this. AWS, when you have to request for a Snowball device, right? So that Snowball device will come to your premises. You transfer the data onto that Snowball device, and then that Snowball device is shipped back to the AWS infrastructure where the AWS experts will upload your data to their own data centers. right? Now, if you were to use internet for a petabyte scale of transfer, it would take a lot of time. But with Snowball, all of this can happen within 10 days. So you're saving costs on your internet, you're saving your bandwidth, and your process is happening faster. So this is how Snowball comes in handy. Now, any question, guys, regarding what Snowball is? All right, people are saying all clear. Let's move on to our next service, which is Storage Gateway. So Storage Gateway is a service which is used between your data center and your cloud, or it can be used between your data center's resources as well. Now, how is it used is like this. Say suppose you have database servers and you have application servers, right? Now your storage gateway, what will sit in between your database servers and your application servers, and it will keep on taking snapshots of your database and will keep on storing it on S3. Now, if you have, say, suppose 3 or 4 database servers and you have storage gateway installed, and your fourth database server gets corrupted because of some reason. Now, what storage gateway would do is it will recognize that a failure has happened. It will take the related snapshot or the respective snapshot and restore your server in which the snapshot was taken. And that is how storage gateway works. This was about your private resources when you're using your own database server and your application server. The same can be done in AWS infrastructure as well when you're using EC2 and RDS, which is a database service. So storage gateway can sit in between these two services and can serve the same purpose. So this is what storage gateway is all about. Guys, any question related to storage gateway? And also we are ending with the storage services. So any question related to the services which we just discussed? All right, people are saying all clear. All right, guys, let's go ahead then. So let's move on to our next domain, which is the AWS database domain. All right. So the database domain would include all of these services. So the first service in the database domain is RDS, which is a relational database management service. So the thing here to understand is that RDS is not a database, it's a database management service. So it manages databases for you. Now, which database does it manage? It manages relational databases for you, right? So it manages databases like MySQL, it manages data like Oracle, MariaDB, PostgreSQL, Microsoft SQL Server, or Amazon Aurora, right? Now, what are the management tasks that we are talking about? So it updates the DB engines automatically. It installs the security patches automatically. So everything that had to be done manually or will be done manually if you're hosting a database server, it does that automatically for you. And that's why it is called a management service, right? So this is RDS. Now, the difference between RDS and a service that we'll be discussing sometime later, that is DynamoDB, is that they both are management services, but RDS is for relational databases and DynamoDB is a non-relational database. So what we'll see that in detail later. So for now, let's move on to our next segment, which is Amazon Aurora. So Amazon Aurora is a database which has been developed by Amazon itself. So it is included in RDS, that is, it is a relational database which is also managed by RDS. But what is the difference between Amazon Aurora and NEC and the other databases which are already out there? Is this. So Amazon Aurora is actually based on MySQL. It means that the code that you're using with MySQL will work with Amazon Aurora as well. But then Amazon claims that Amazon Aurora is 5 times more faster than MySQL. So if you are using MySQL and you replace your MySQL server with an Amazon Aurora server, you will experience 5 times boost in your performance. And this is what Amazon claims, and that is what Amazon Aurora is all about. So if you're using Amazon Aurora and you were using MySQL before, you don't have to change your code because it will work exactly the same with the code as it was you working with MySQL, because there's no change in the code when you talk about MySQL and Amazon Aurora, but you will get that performance boost when you're using Amazon Aurora. So guys, are we clear with what Amazon Aurora is all about? Okay, so Michael has a question. So first I need to host a database like MySQL and then I can take the RDS service to manage it. No, Michael, it's not like that. I will actually launch an RDS database for you. So just have patience for a while and then everything will be clear to you. All right, Michael. So for now, you can understand that what you should understand is that RDS is a database management service. What all tasks are performed by RDS, that is auto-updating security patches, auto-updating the DB engine, updating, rollback, everything is done automatically by RDS, All right. Any questions related to Amazon Aurora, guys? What Amazon Aurora is? Any doubts? All right. People are saying all clear. All right, guys. Let's move ahead then. So our next service is DynamoDB. So like I said, DynamoDB is also a management service, but it manages non-relational databases for you. So when I say non-relational databases, I mean NoSQL databases. So if you have unstructured data that has to be stored in a database, so where will you store it? You cannot store it in a relational database. You have to store it in a non-relational database. And the non-relational databases are managed by DynamoDB, right? So DynamoDB is actually a NoSQL database which also gets managed automatically. Alright, so when I say managed, it gets updated, the security patches are installed automatically, everything is done by DynamoDB itself. There is no manual intervention required. Also, the thing with DynamoDB is that you don't have to specify the amount of space that you will be needing. The moment more data comes in, the database automatically scales, right? So it grows automatically. Your manual intervention is not required. If the storage is coming low, nothing is required in DynamoDB. You just go to the DynamoDB console and you start creating new tables. It doesn't ask you for anything. You don't have to configure any storage property or anything like that. It grows automatically and shrinks automatically as well. So this is about DynamoDB, guys. Any question regarding DynamoDB? Alright, the next service in the database domain is DynamoDB. So like I said, RDS is a database management service for relational databases, right? DynamoDB is a database management service for non-relational databases. So when you have unstructured data, you store your unstructured data in a non-relational database. You cannot store your unstructured data in a relational database because relational databases consist of the data that can be structured in a table. But when we talk about unstructured data, we say suppose let's talk about something random. Let's talk about your posts on Facebook. They're all random, right? So if you have to analyze your posts on Facebook, you just have to take that data and you feed it into a non-relational database and it makes sense out of it. This is the power of a non-relational database, and DynamoDB is a non-relational database management service. So it's a service which manages a non-relational database for you. The other thing with DynamoDB is that you don't have to specify the storage space that you'd be needing. As and when the storage requirements increase, your database scales automatically. So if you have a storage requirement of 10 GB today and tomorrow you'd feed in data of say 5 GB more, so your database will grow automatically and you'll be charged according to that. If you're using 15 GB, you'll be charged for 15 GB and so forth. So you don't have to manually intervene to increase your storage. DynamoDB does that automatically. So this is about DynamoDB, guys. Any questions related to DynamoDB? Since you guys are all clear, let's move on to our next service, which is Elastic Cache. So Elastic Cache is a caching service. So it is used to set up, manage, and scale a distribute environment in the cloud. What that basically means is, say suppose you have an application, right? Now the way databases works is like this. You query something from database, the database processes that query and in turn gives you a result. But what if there's a lot of demand for a specific kind of result set? The same query is running again and again and again, so it increases the overhead on your database in getting the same results again. So with Elastic Cache, what you can do is, as you can see in the diagram, the user was first accessing this query from database, but with now, since it has analyzed that this query is being asked very frequently, it stores the result set in Elastic Cache, and whenever that query comes in, it directly feeds in that result. So the DB's overhead or the database's overhead is reduced because the request never reaches database because it has already been processed and it is stored in Elastic Cache, and the Elastic Cache in turn serves the user with the result, and hence this process becomes faster. And this is what Elastic Cache is all about. Any question, guys, regarding what Elastic Cache is? Alright, people are saying all clear. Alright guys, let's move on to one last service in the database domain, which is Redshift. So Redshift is a data warehouse service. So it's a petabyte scale data warehouse service. So it gets data feeded from RDS, it gets data feeded from DynamoDB, and it does analysis on it. So it's an analysis tool. It's a data warehouse service which can be used to analysis on the data that you have stored on your database, say like RDS or DynamoDB. Alright, so it's an analytics tool. So guys, any question related to Redshift? It's a data warehouse service, like I said, which is used to analyze data, and you can feed the data from RDS and DynamoDB as well. Any question, guys? Alright, Michael says no, Neil says no, Sandeep says all clear, Sebastian says all clear. Alright guys, so this is we end the database service on Redshift. Let us now launch an RDS service, and like Michael asked, he had a doubt. So let's see if we can clear his doubt when we launch an instance in the RDS. So let's go back to our AWS Management Console. Let's go to the dashboard for AWS. So under the database domain, we can find RDS over here. We'll click on RDS. All right. We'll click on instances. So there are no instances as of now. So let's launch a DB instance. So we have to select which database do we want to be managed, right? So Michael was asking me, first we have to host a database and then we incorporate RDS. Is it like that? So no, Michael, the moment you click on RDS and you try to launch an instance, it'll ask you which database do you want to manage, right? If I say, suppose I want to manage MySQL, or I want my application or my database is, say, suppose hosted on a MySQL server on my local host, right? If I wanted to be migrated to AWS infrastructure, I would want the same database over there as well, right? So I will choose MySQL over here and click on select. Now it will ask me which environment do I want it to launch in. So there are two kind of environments. One is the prod environment and the other is dev or test. That is the development or the test environment. Since ours is a demo, so we'll launch it in a test environment and click on next. So over here we'll be configuring our instance. So it'll ask me for DB instance class. Let's select the minimum, which is db.t2.micro. So we'll be discussing all of these instance types when we reach the database module. So don't worry about it. Just go with the flow. Select db.t2.micro, and then it is asking me for multi-availability zones deployment. So multi-availability zones deployment is something related to availability. So if you want your database to be there in different availability zones, so that if one availability zone goes down, the other is there, you would choose yes as an option over here. But since ours is a demo, we'll select no. And it is asking for the storage type. So it is SSD, Provision, IOPS, magnetic. So basically the options here is given according to the use case. So if you have an application, if you want low latency, so you would choose accordingly, and we would discuss all of these in the database domain. So don't worry, just let us click at default for now, and let's go in the settings. So it is asking me how will your database be identified. So let's give it the name as Edureka demo. All right. Let's give the master username as Edureka, master password as Edureka123, and let's confirm the password again. Alright guys, let's click on the next step now. So it is now asking me for a VPC. Now guys, this is a step which is really important. If you have an application that you want to deploy in AWS and you want that application to interact with the database section as well, you have to include both these services. Say suppose you host an application on EC2. Now EC2 and your RDS or whatever service you're using for your database has to be included in the same VPC so that they can interact. So this has to be kept in mind when you are trying to deploy an application on the AWS infrastructure. So let us keep it at default for now. So I have a VPC called 82A742E5. So let's keep it at that. And it's asking me if VPC security group. So let's select the default security group. DB name, let's leave it blank. We'll launch our own DB, or we'll create our own DB. Okay, so over here you can select which version do you want. So it's 5.6. Everything else looks fine. You don't have to change anything here because we have not studied anything of this yet. So once we do that, I will explain you guys all of this, right? Let's click on launch DB now, launch DB instance. So it says my DB instance is being created. It will take a while for my DB instance to be launched. Let's see if we have our instance listed in our RDS dashboard. Alright, so my instance is being created now. So it'll take a while. Let's look at the other things over here. So once you click here, you will see all the data associated with your RDS instance. Now the way you will connect to your RDS instance is using your command line, right? So using a command line, you will use a command called MySQL. So for using that command, you first have to go to the bin directory of your MySQL installation. So yes, you should have MySQL installed on your local server from which you were trying to connect to your RDS instance. So you will enter the command MySQL once you are in the bin directory in your command prompt, and space -h. So H is your host name, right? And host name is nothing but your endpoint. I will show you guys exactly what to do, but since it's being created, I'm explaining you guys the process. So the endpoint is basically the host name that you will get. So you will get that once this is created, right? So when I say MySQL space -h followed by the endpoint, space hyphen capital P, which is the port number using which you will connect to RDS. So you have to mention the port number. That will also be mentioned in the endpoint. And then you have to enter the username. So if you guys remember, I entered the username as Edureka, and it will be followed by hyphen small p, which is just the password. I'll click on enter. The next line, it will ask you for the password, and you will enter the password that you have specified while launching your instance. In our case, it was edureka123. So we will enter edureka123 over there and then hit enter, and if everything goes fine, we should be able to connect to our RDS instance. So guys, this is the whole process. In a few minutes, I will explain you guys how we will be doing that. Let's wait for we are just waiting for a DB instance to be created. So let's wait a little longer. Alright guys, our RDS instance is launched. Let's now try and connect to our RDS instance. So for that, let's launch our command prompt and navigate to my MySQL directory. So for me, it's in WAM64, the bin directory. Alright, now I'm in the bin directory for my MySQL installation. Now I will give the following command to connect to my RDS instance. So the command is mysql -h, which is the host name. So now I'll be entering the host name, that is the endpoint that AWS provides me on the console. So you'll select your RDS instance and you'll click on your endpoint and you'll hit copy. Alright, so once you've copied it, go back to your command prompt and paste it here. So the 3306 is actually your port name, so you have to enter it separately. So just delete the 3306 part and enter hyphen capital P. Remember guys, it's capital P, it's not small p. Small p is for password, capital P is for your port number. Alright, so you'll enter capital P and then enter 3306, which is your port number. Once you've done with that, then you'll enter your username. So for that, you will enter the tag as -u, which is the username. So if you guys remember, it's Edureka, followed by -p, which is the password, which we'll enter in the next line. So you will hit enter just after -p now. So in the next line, it'll ask you for enter password. Right? Over here, you will enter your password, which you have specified while in the installation. Hit enter, and if everything works fine, you will be connected to your MySQL instance. Yes, so we are connected to our RDS instance now. So you can enter the MySQL commands as you enter in your normal MySQL. So we'll enter show databases. So these are all the databases which are there for now on my RDS instance. So this is how you connect to your RDS instance once you have launched it. So Michael, like I said, had a question whether you have to host a MySQL service first and then launch an RDS instance to manage it. So Michael, does that answer your question? Does this practical explain you what your doubt was? Alright guys, so Michael says yes. Any doubts that you guys have other than Michael? Alright, everybody is giving me a go. Alright guys, so let's move ahead. Let's come back to our presentation. So we are done with all the database services now. Let me give you guys a recap what we just learned. So RDS is a relational database management service. Aurora is a database which is built by Amazon, which is based on MySQL, but which performs 5 times faster than MySQL. All right. DynamoDB is a database management service for NoSQL databases. Elastic Cache is a caching environment. It is used to cache results, which reduces the latency and reduces the overhead on databases as well. Redshift is a data warehouse service which can be used to do analysis on data, and the data can be fed from RDS and DynamoDB as well. So guys, these were the databases services. Any questions in any of these services which we just discussed? Alright, you guys are giving me a thumbs up. Alright guys, let's move on to our next domain. So our next domain is the networking domain. So let's see what all services are offered by the networking domain. So networking domain basically offers 3 kind of services: the VPC, Direct Connect, and Route 53. Let's discuss each one of them. So VPC is a virtual private cloud. So it's a virtual network. If you include your all your AWS resources that you have launched inside one VPC, then all these resources become visible to each other or can interact with each other once they're inside the VPC. Now, the other use for VPC is that when you have a private data center and you're using AWS infrastructure as well, and you want your AWS resources to be used as if they were on your own network. In that case, you will establish virtual private network, that is a VPN connection to your virtual private cloud, in which you have included all the services that you want on your private network. You will connect your private network to the VPC using the VPN, and then you can access all your AWS resources as if they were on your own network, and that is what VPC is all about. It provides you security, it makes communication between the AWS services easy, and it also helps you connect your private data center to the AWS infrastructure. So guys, this is what VPC is all about. Any doubts in what VPC is? Alright, people are giving me a heads up. Let's go ahead on to our next service, which is Direct Connect. So Direct Connect is a replacement to an internet connection. It is a leased line, a direct line to the AWS infrastructure. So if you feel that the bandwidth of internet is not enough for your data requirements or your networking requirements, you can take a leased line to the AWS infrastructure in the form of the Direct Connect service. So instead of using the internet, you would now use the Direct Connect service for your data stream to flow between your own data center to the AWS infrastructure, and that is what Direct Connect is all about. Nothing much further to explain. Let's move on to our next service, which is Route 53. So Route 53 is a domain name system. So what is a domain name system? Basically, whatever URL you enter has to be directed to a domain name system, which converts the URL to an IP address. The IP address is of the server on which your website is being hosted. The way it functions is like this. You buy a domain name, and the only setting that you can do in that domain name, or the setting which is required in that domain name, are the name servers. Right? Now these name servers are provided to you by Route 53. These name servers that Route 53 provide you are to be entered in the settings of that domain name. So whenever a user points to that URL, he will be pointed to Route 53. The work in the domain name settings is done. You have to configure the Route 53 now. Now that your request has reached Route 53, it has to be pointed to the server on which your website is hosted. So on a Route 53 now, you have to enter the IP address or the alias of the instance to which you want your traffic to be directed to. So you feed in the IP address or you feed in the alias, and it's done. The loop is now complete. Your URL will now get pointed to Route 53, and Route 53 in turn will point to the instance on which your application or website is being hosted. So this is the role which Route 53 plays. It's a domain name system. So it basically redirects your traffic from your URL to the IP address of the server on which your application or website is hosted. So guys, any question related to what Route 53 is? People say all clear. Alright guys, so we're done with the networking domain. Let's move on to our next domain, which is the AWS management domain. So the management domain includes all these services. Let's start off with our first service, which is CloudWatch. So CloudWatch is basically a monitoring tool which is used to monitor all your AWS resources in your AWS infrastructure. Now how you can monitor them is, let's take an example. Say suppose you want to monitor your EC2 instance. You want to be notified whenever your EC2 instance's CPU usage goes beyond say 90%. Right? So you can create an alarm in CloudWatch, and whenever your usage will cross 90%, it will trigger an alarm, and that alarm in turn will send you a notification, maybe by an email or maybe whatever parameter that is set. You will receive an alarm in that scene. So this is what CloudWatch is all about. You can set alarms in turn to reactions that you get from your AWS resources. So guys, any questions related to CloudWatch? Alright, let's go ahead. So our next service is CloudFormation. So CloudFormation is basically used to templatize your AWS infrastructure. Now, why would you templatize your AWS infrastructure is when you have different environments and you want to launch the same infrastructure in different environments, right? So if you create infrastructure and you don't want to create that again, you can always take a snapshot of it using the CloudFormation, and then you can templatize this infrastructure and use it in other test environments. Say suppose you have test environment, prod environment, and dev environment, and you want the same infrastructure in all of these three environments. You can do that using CloudFormation. So CloudFormation is a tool using which you can templatize your AWS infrastructure. So nothing much more to explain. Let's go ahead and see our next service, which is CloudTrail. So CloudTrail is a logging service from AWS. So you can log all your API requests and API responses in CloudTrail. And why would you log them? Is because when you want to troubleshoot a problem. Say suppose you get some error while you are using your application, and since there can be numerous amounts or countless cases wherein you don't get an error, but in a particular case you get an error. Now you have to track down the problem. Now how will you track it down? You will track it down using the logging service. So since every request is logged using CloudTrail, you can go to that particular service or go to that particular log where the error occurred, and hence jot down the problem and jot down the line where the error is occurring and hence solve it. So this is what CloudTrail is all about. Now, how are the logs stored? Now, say suppose you have CloudTrail enabled on a particular service. So the CloudTrail will generate logs and will store those logs in S3, which is a file system provided by AWS. So this is how the whole process happens. So guys, are we clear why we would need an AWS CloudTrail service? Or why do we need a logging service in that matter? Alright, people are giving me a go. Alright guys, let's move on to our next service now, which is AWS CLI. So CLI is a command line interface, which is just basically a replacement to the GUI interface that you have. I showed you guys the AWS dashboard, right? So that is the GUI. But say suppose you are comfortable with a command line. So you can also use a command line to deploy instances, and the way to do that is by using AWS CLI. Right? So there's nothing here to explain. It's just a replacement to your GUI that you use in AWS. So guys, any questions, any confusions in AWS CLI? All right, you guys seem to be pretty smart. You're understanding everything. All right, guys, let's move ahead to our next service, which is OpsWorks. So AWS OpsWorks is a configuration management tool. So it consists of two parts. It consists of stacks and it consists of layers, right? So layers are basically different AWS services that you have combined together. And when you combine them together, this whole system is known as a stack. Now, where would you need a configuration management tool? Now imagine a scene like this. You have an application which is using a host of AWS services, right? And you want to change something very basic. Now one way to change this thing is by going to each and every service particularly and changing that setting. The next way to do this is using OpsWorks. If you have deployed your application using OpsWorks, one basic setting that you have to change in all of your infrastructure can be done at the stack level. So basically all your resources, all the services that you're using are layers, there are different layers in that stack. And that combination is known as a stack, right? So that AWS infrastructure as a whole would be known as a stack. And if you have to change the setting, you have to change it at the stack level, and automatically it will be implemented to all the layers. So this is how OpsWorks function, right? It's a configuration management tool. So any questions related to OpsWorks, guys? Any part that you don't understand about OpsWorks? we are good to go. Alright, let's move on to our next service, which is the Trusted Advisor. The Trusted Advisor is just like a personal assistant to you in the AWS infrastructure. So how does it advise you is like this. So it advises you on your monthly expenditure. So say suppose there's a best practice, and if you use that practice you can reduce your expenditure. So Trusted Advisor would advise you to do that thing. It would advise you for using your IAM policies. If it recognizes that a lot of users, a lot of different people are using your AWS account, and you have not set up any IAM policies on your AWS account, it will advise you to create those IAM policies, and hence this will enable you to create your AWS account better, right? And these are the kind of advices that the Trusted Advisor will give you in AWS. So guys, are we clear with what Trusted Advisor does? Alright guys, so you guys are giving me a go. Alright guys, so we are done with the management services. Any doubt in any other services which we just discussed? Alright, so let's move ahead. So our next domain is the security domain. So let's discuss the services in the security domain. So the security domain includes two services. The first service is IAM. So IAM is Identification and Authentication Management Tool. So what this basically does is, like I said, if you have an enterprise and you and your users are using your AWS account to control the AWS infrastructure, you can provide them with granular permissions. If say suppose you want a user to just review what all instances are there, so you can give him that access. If you want a user to just be able to launch instances and not delete them, you can give that particular user that access. So these are the kind of accesses that you can do give using IAM, and that is what IAM is all about. It authenticates you to your AWS account, or in this case your employees to the root AWS account in a fashion that you want. So guys, any question related to what IAM does? Right, Michael seems pretty clear. Neil says all well. Alright guys, let's move on to the next service, which is the key management service. So AWS KMS is a key management service. So basically any instance that you have launched in an AWS is based on this infrastructure, that there will be a public key and you guys will be provided with the private key, and the public key is withheld with the AWS. Whenever you want to connect to your instance, you have to upload the private key, or you have to get the private key, and then AWS will match that private key with your public key, and if it matches, it will authenticate you to your AWS instances. So there's nothing more to explain. This is what basically KMS does. So KMS basically assigns you with a private key. You can create a new key pair or you can use an existing one. But guys, you have to be very careful with your private keys. If you lose your private keys in any case, there's no way you can gain access back to your particular AWS resource which will be using that private key. So guys, are we clear with what KMS is? Alright, Michael says yes, Neil says yes, Sebastian says yes. Alright guys, so we are done with the security services. Let's move on to our next domain, which is the AWS application domain. Right, so the application domain includes three services. The first service is the simple email service. So like I said, if you have a large user base and you want to send emails to them, you can do that on a push of a button using the SES. Also, if you want the replies to be automated, that can also be done using the SES. So it's a very simple service, nothing much more to explain. Any doubts in this particular service, guys? SES? All right, let's move ahead then. The next service is a pretty interesting service. It's called the simple queue service. So a simple queue service acts as a buffer. Now the way it functions is like this. Now say suppose you had that application, you had that image processing application, right? Now whenever you upload an image, say suppose you have to do 5 tasks. Now these 5 tasks will be listed in your simple queue service or your simple queue, and your server will keep a reference with this queue and see what all tasks are left to be done on the image. Now how does this help? This helps when you have multiple servers running for your processing, right? And say suppose your first 2 operations are done by the first server and the next 3 operations are maybe to be done by some other server, right? So the next server should know what all operations are already been done, and this knowing is actually referenced through your SQS. So whenever a task is done, that task is removed from the queue and the next task is queued. And that is what SQS basically does. So guys, are we clear with what SQS is and how it functions? So Michael is asking me, does this work on priority basis? Michael, when you'll be listing those tasks, those will be on priority. The first task that you have listed will be executed first. So yes, it's based on priority. The priority is first in, first out. So the first thing that you list has to be executed first, right? So say suppose you have 5 images pending, so the second image is after the first image, the third image is after the second image. So the first image will be processed first according to the queue, and then the second image will be processed, and then the third image will be processed. So it works like this. So Michael, are we clear with what SQS is? Any more questions, guys, regarding the SQS service? All right, you guys are saying all clear. All right, so let's move ahead. So the next service is SNS, which is the simple notification service. So it basically sends notifications to other AWS services. Now, how can it be used? It can be used like this. Say suppose that application that we just discussed about image processing, you upload the image, right? And now you also want an email whenever an image is uploaded, right? Now, how will you do it using SNS? So SNS will send a notification to SQS and SES that an image has been uploaded. Now, when the notification is sent to SQS, that notification can also include the number of tasks or the tasks that have to be done on that image, right? So SNS sends a notification to SQS with the details that have to be added in the queue. And SNS can also send a notification to SES that an image has been added, so send the respective email to the respective person. Right? So this is how SNS functions. It sends notification to different AWS services, and this is what SNS is all about. So guys, are we clear about all the services that we have discussed so far, which is SES, SQS, and SNS? Any doubts in any of these three services? All right, Sebastian says no. Michael says no. Neil says no. All right, guys. So we are done with the services now. So let's move on to our next section, which is AWS pricing. So we are done with all the services. We have learned what all AWS has to offer us. Now let's see how are we charged when we use these services. So AWS has these models. So the first model is pay as you go. So it means you pay what you use. So let's take an example of a file system here. So you don't have to foresee your requirement and buy a 50 GB chunk for yourself, even if you're using say only 10 GB out of it. If you're using some other service, if you're not using AWS and they don't follow a pay as you go model, you have to foresee what your requirement is. You have to foresee, say suppose you might need 50 GB in a month, right? But you end up using say only 10 GB. But since you asked for the 50 GB, you have to pay for that whole 50 GB, right? Even if you're using 10 GB out of it. But with AWS, this is not the case. You pay according to your usage. So if you're using S3 and you have just 6 or 7 GB of data on it, you'll be paying for that 6 or 7 GB. And in future, if you upload more data onto it, you'll be charged according to that data or that storage that you're using. Alright, so this is what the pay-as-you-go model means. The next model is pay less by using more. So this is a very interesting concept. Let's understand this. So we have included the pricing for S3. So if you're using S3 up to 50 TB of storage, you are charged at $0.023 GB per month, right? If your usage goes beyond 50 GB and it lies between 51 to 100 TB of storage, your rate reduces to $0.022 GB per month. And if you use 500 TB plus of storage on S3, you'll be charged at $0.021 GB per month, right? So as you're using more, your prices are dropping down. The rates are becoming less. And this is what pay less by using more means. So let's move on to our next model, which is save when you reserve. Now this is again a very interesting model. Save when you reserve. When you reserve your instances in AWS, you have an option to reserve them for 1 year or a 3-year term. So if you have that kind of usage, you can reserve your instances and you can save costs up to 75%. So as it is evident in the picture or in the diagram below, a lady who didn't know which service and for how long she'd be using that service, if she ends up using that service for say 1 year, she'd be entitled to pay this much amount. But in the other scene, when she knows she'd be using it for say 1 year or 3 year, whatever, and what instance she wants, She can save cost up to 75%. Now this is the power of reserving, but it makes sense for you only when you know, when your use case is like this, that you might be requiring that instance for a term of 1 year or 3 years. Like for example, our company Edureka has this website called edureka.co. Right, so it makes sense for us to reserve the instances because our website will be there as long as our company exists. Right, so we can reserve instances and host a website on reserved instances. But then since I'm giving you guys some demos today, right? So these demos should not be reserved because I might delete them tomorrow. I might not be using them maybe after a week or months, right? So it doesn't make sense for me to reserve these instances, and that is what reserving instances is all about. So if you know that you'll be using your instances for a minimum of 1 year or maybe 3 years down the line, you can reserve them and you can save up to 75% on that. So guys, this brings us to the end of the AWS pricing section. Are we clear with all the pricing models that we just discussed? Alright guys, I'm getting a yes from you guys. So let's move to our next section. So this is the fun part guys. We're done with all the theory. Let's now discuss a problem and let's see how we can solve it using the knowledge that we have gained today. Alright, so our problem would be hosting a website and we'll be hosting it on the AWS infrastructure. So let's see how we will go about it. So let's first discuss the problem. So we have to host a website on which we can upload images, and these images should be displayed on the home page once you have uploaded them, and this website should also auto scale and should be highly available. Right, so this is our use case and we have to host this application on the AWS infrastructure. So let us first see how we will architect the way this website will function. So the user will point to a website address. That website address will point to the website, and that website will actually be dealing with the file server and a database. Why the file server? Because you will be uploading your images on something, right? So that's why the file server, and you have to remember the paths of those images, and for that you'll be using the database, right? So guys, this is our architecture that we'll be constructing on the using the AWS resources. So guys, do you have any doubts in this architecture which we just discussed? All right, Shubham says no, Michael says no, Neil says no. All right, guys. So if it's clear with you, let's move on to the AWS services. All right, guys. So let's just see how we can, how we will architect this architecture which we just discussed using the AWS resources. So our user had to point to a website address which will point to our website, right? So like we said, we would need a domain name system here. So we'll be incorporating Route 53. So our user will be actually interacting with Route 53, which will in turn point to our server. So our server is actually the place where we are hosting a website, right? Now my application or my website is a PHP application. So like I said, if you have an environment which is there in Elastic Beanstalk, you should always go for it, right? So since PHP is listed in Elastic Beanstalk, I'll be using Elastic Beanstalk instead of EC2. Right, now what is Elastic Beanstalk exactly under the hood? Let's discuss that. So in Elastic Beanstalk we'll have EC2 instances under the hood which are automated. So you'll have the PHP environment automatically configured on your EC2 instances, and your EC2 instances will be controlled using the auto scaling and load balancer. So whenever there'll be a requirement for more number of instances, more number of EC2 instances will be launched, and the traffic will be distributed accordingly using the Elastic Load Balancer. So this is how it functions under the hood, but you don't have to worry about that. Let's consider, if you're not understanding what I just said, let's consider Elastic Beanstalk as a black box, right? Now your website had to interact with RDS and S3. So why RDS, why S3? S3 is the file system which we discussed in the architecture above, and RDS is the database that you're trying to connect with. Now since you have to store the paths to the file that you are uploading, those paths can be actually stored in a structured manner, right? And since it's a structured data, you'll be using RDS, which is Relational Database Management Service. So you can store your data in, say, suppose a MySQL database, right? So that is why we are using the RDS service. Also, if you're connecting a third-party application to your S3 file system, you need to authenticate that application to S3, and for that you would be needing access keys, and those access keys are provided by IAM. Right guys, so these are all the AWS services that we'll be requiring. So any doubt in why we are using these particular services and why not the others? Any doubts guys? All right, People are saying all clear. Alright guys, so let's move on to the fun part now. Let's create this architecture and let's host our website on the AWS. So first let me go back to my browser and let me show you guys the website. So guys, this is my website. I'll click on upload files. I'll click on upload image. I have this folder called images on my desktop. I'll go to that folder. Let's upload this image. Click on open and click on upload image. So it says S3 upload complete. That means my file has been successfully uploaded. Let's see if I can see it on the home page. So yes, I can see it on the home page. Now what basically happened here is that the entry to the database is made on my local host for now. So let us see if the entry has been made. Let us launch my MySQL. So this is my local host MySQL. My database name is Edureka. So let's use that database. And my table name is image. So let's select star from image and let's see if we have our image listed here. So yes, there's an entry. So let's go back and see if we have a file name like this in my S3 bucket. Right, so let's go to the our S3 service. So you can find S3 under the storage domain. So I have configured my code to interact with a bucket called Edureka RDS. So let's go to this bucket. So yes, it has a file. Let's compare the file names and see whether the same file is there in my bucket. Right, so this is my MySQL. This is my local host MySQL. So this is the file name 14867209333. Let's compare it with the file name over here 14867209333. So this is the same file. So let's see if it is the file that we uploaded. So we'll select the file, we'll click on properties and we'll click on the link now. Let's see if it is the same file. So yes guys, this is the file that I uploaded. Let me verify it on my website. So as you can see, this is the same file that we uploaded. So our website is actually working fine. For now, it is updating my MySQL on the local host and it is uploading file on the S3 and this website is hosted on my local host as well. Right. So now I have to upload this website on the AWS infrastructure. That is Elastic Beanstalk, and I have to migrate this database to RDS. Right. So first, let's launch an Elastic Beanstalk environment. Right. So let's minimize all of this. Go to our AWS dashboard. Let's select Elastic Beanstalk. So it should be under the compute domain. So let's click on Elastic Beanstalk. So there are no environments which currently exist. So let's create an environment. Let's click on create environment. So we need a web server. So we'll click on create web server. So we have to select a platform now. So ours is PHP. So let's select PHP. And since we want load balancing and auto scaling enabled, let's leave it at default. Click on next. Select a source for your application version. Let it be at sample application for now. We'll upload our code later. And let us not touch any of this because this we haven't taught you guys. So let us not touch this and click on next. So now you have to name your environment. So let's name it as Edureka demo hyphen demo, right? Let's check the availability. So this URL is available. Let's click on next. Like I said, you have to create this environment inside a VPC. Let's check that and click on next. So which instance type? Let it be t1.micro. Let's select the key pair. So we created Edureka demo 1, remember? So let's select that. It should be listed here. Edureka demo 1. Sorry, the key pair's name was AWS demo 1. So let's select that. Email address is not required. Application, nothing is required here. Okay, everything seems done. Let's click on next. Now you would have to enter the name for your instance, right? So let's name it as Edureka demo, right? Let's click on next. So now you have to select the VPC. So like I said, you have to select the same VPC as your RDS instance. So let's check the name for our RDS instance VPC. Let's go to RDS, our instances. Let's see which VPC is my RDS included in. So it's an A2A742E5. So let's select the same VPC here. So it's A2A742E5. So let's check if it's the security group. If the security group is same as my RDS, so it's SG91BB. So it should be same. SG91BB. Alright guys, so this is same. Let's click on next now. Alright, so you have to select all of these instances. I'll explain you guys later why you do that when we reach the EC2 module. For now, let's select all of this and click on next. You don't have to touch anything here. Click on next. Now you have to review it and launch your application. So everything seems fine to me. Let's launch our application. Now this might take a while to launch. Let me teach you guys how to migrate your database to the AWS infrastructure, right? So for that, before migrating my database, let me show you one more time that whether or not this is being updated or not, right? So let's upload a file. Let's choose a file now. I'll choose a second image, click on open, click on upload image. It says S3 upload complete. Let's go back and check whether our file has been uploaded. So yes, our file has been uploaded. Let's check in our database. This is my localhost database, guys. You can see the address. So let's check if an entry has been made over here. So yes, there are 2 images now. Now let's go to our S3 bucket and check whether an image has been added over there. So we'll go to S3. We'll go to Edureka RDS bucket. Let's compare and check whether it's the same file. So it's 1486721420, 1486721420. So it's the same file, but then let's confirm it. So we'll click on properties and click on the link. So this is my image. Let's verify it. So yes, it's the same image that I have uploaded. So once I migrate my database to the AWS infrastructure, this will no longer be updated, right? So this is the thing that you have to keep in mind. So let's take a backup of this database first. So for that, I have to close this and go to my command line. Open the command line. I'll go to the bin directory of my MySQL installation. All right. So I've reached the bin directory. Now for taking the backup of my database, I have to enter this command. It says MySQL dump -u. So you have to enter the username for the local host of your MySQL service, which is root, and then the password. Since there's no password, I will not enter anything. And then you have to enter your database name, which is Edureka, right? And I have to export it. So you'll be using the greater than symbol, which basically means that you're pointing it out. That is, you are exporting the file, right? So you're exporting the file to a file name called edureka.sql. So this is it. Let's hit enter, and if everything works fine, this will work without errors. All right. The command executed successfully. Let's check if we have a file called SQL in my bin directory for my MySQL. So I'll go to the bin directory for my MySQL over here. and it should have a file called edureka.sql. So yes, it has a file. So hence a file has been made. Now you have to connect to your RDS instance and then migrate this file over there so that the database is created over there, right? So I've already told you guys how to connect to your RDS instance, right? So you have to write mysql space -h, the host name. So let's copy the host name from the RDS console. So it's over here. Let's quickly come back, paste it here, right? Remove the port number. It's capital P, guys, remember. Then you enter -u, that is the username, which was Edureka, -p, not required for now, and then -p, and then you will hit enter. So it'll ask for your password, so let's enter the password. It's Edureka123. You have connected to your MySQL instance. Now let's create a database. So you have exported the file that you want to be imported to RDS, right? Now you have to first create a database here where you want the details to be copied, or where you want the database to be there, right? So you will create the same database name. So let's create the same database name, which is create database Edureka. Correct. So my database has now been created. Let's check if it's empty for our satisfaction. All right. So let's say show tables. So there are no tables in my RDS database for now. Okay. So let's now exit RDS and let us now migrate my database file to RDS. Right. So for that, you'll enter the same command as you do to connect, and then you will enter the less than sign, which means you are now importing to RDS, right? And what file are you importing? It's called edureka.sql. And where are you importing it? You want to import it to the database called Edureka in RDS. So let's do that now. So basically you understand it till here. After that, I have included the database which I have just created in my RDS MySQL, which is Edureka. And what data do I want edureka.sql to be copied to the database in Edureka? Alright guys, so now let's hit enter. It'll ask me for the password for RDS. Let's enter the password, edureka123. Hit enter, and if everything works fine, it will not give me an error. So it'll take a while for my file to be uploaded, so just be patient. Okay, so it didn't give me any error. That means my file has been uploaded successfully. So let's check if everything went well. Let's connect to our RDS instance, enter the password. My database name was Edureka, which I just created in RDS, right? Now let's check if our table is being listed over here. So I'll enter show tables. So yes, it has a table name called image. So let's check if there is any data in my table. Select star from image. So yes, it has the records which were there in my local MySQL as well. So let's launch local MySQL and see if I can verify my data. So this is my local MySQL and this is my RDS, right? So as you can see, the data is same, the table name is same, everything is same. So I've successfully migrated my database on the AWS infrastructure. Now I have to tweak my code so that it can connect to the RDS instance now, right? So let's jump to our code now. So my code is over here. These are my code files. So I'll have to change index.php, right? So the host name was localhost. Now I have to change it to the endpoint that RDS has provided me. So let's do that. So this is the endpoint. Let's copy this into my code, remove the 3306. It is now asking me for the username. So the username is Edureka and the password is Edureka123. All right, everything else seems fine. Let's save our index.php and let's see what all other changes we have to do. So I've changed index. Now I have to change the upload part as well. So let's do that. So I'm connecting to the database over here. So let's correct this. The host name is this without the 3306 part. The username is edureka and the password is edureka123. Anything else needs to be configured? Alright, everything else seems fine. Let's check if it's working on my local host now. Alright, I'm getting the home page, which means my connection is working, but then let's be sure. Let's choose a file. Let's upload this third image. Click on open, click on upload image. It says S3 upload complete. Let's go back and check whether it's there on my home page. So yes, I can see this image on my home page. Let's see if I can see it in my S3. Yes, there's a third image added. Let's check if I can see it in my RDS. So yes, there are 3 records added. So my code can now interact with the RDS instance and it can successfully more records over here. So the connection to RDS is working fine. Let's be double sure and see whether my local host MySQL is not being updated. So this is my local host. I'll use Edureka. I'll check whether the image table has been updated. So no, since my code is not pointing to this MySQL anymore, the records have now not been updated. So I have successfully migrated my database onto the AWS infrastructure. My code is now interacting with the AWS infrastructure. Let us now do the final step, that is upload my code to the AWS infrastructure, right? So I think our Elastic Beanstalk is ready now. Let's check. So the health says okay. Alright guys, so I can upload my code over here now. So for that, the way you can upload your code onto Elastic Beanstalk is by zipping your code. So let's go back over here, copy these files, go to my desktop, create a new folder, copy the files here, zip this folder. Let's call it upload. Right? So now I'll be uploading this folder to Elastic Beanstalk. So let's do that. So we'll click on upload, choose a file, we'll go to desktop, upload this folder, click on deploy. So it'll take a while for Elastic Beanstalk to deploy my application. So let's just be patient. Once my code is up and running, it'll show a green sign over here and I can access my website using this URL. If my website works fine, our next step would configuring our Route 53 to point to a specific domain name. I basically found a website which provides a free domain name to use. So I'll be using that domain name to connect to my instance. So we'll do that in a jiffy. Let's just wait for our code to be deployed here first. Alright, my code has been uploaded now. It shows a green symbol. Let's check if it's working. So I click on this URL and if everything is working fine, my website, I can see my website. So yes, I can see my website. So I have successfully migrated my website as well to Elastic Beanstalk. So let's confirm this by uploading a file. Let's click on upload files, choose a file, go to desktop, click on images and upload this file. Click on upload, says upload complete. Let's go back and check. So yes, my Elastic Beanstalk is now showing this image. If I can see this image here, this basically means that my database has been updated successfully. My S3 bucket has also been updated successfully. So everything is working fine, guys. Now the next step is to get a URL. So I have got my free URL from this site. It's called my.tk. So this website basically gives you a free domain name, right? So I have got mine. Let me log in. Alright, so I'll go to the my domains section. and click. So this is the domain name that I've got for free. So let's click on management domain. Click on management tools, name servers. So basically these are the default servers which are there for now, and you have to use custom name servers which will be provided to you by Route 53. So let's do that. Let's go to Route 53 now. So Route 53 can be found under networking. So here it is. Let's click on that. So let's get started. Create an hosted zone. So click on create hosted zone and you have to enter the domain name. For me it's edureka.tk, right? So let's create. Now you have to enter the record sets. Now these record sets will point to your application. So before that, let's copy the name servers to my domain name, right? So these are the name servers that Route 53 provides us, and these name servers have to be copied to my name servers part section over here, right? So let's do that. So let's copy the first name server first. So we'll be using the custom name servers, and let's delete all of them. So let's enter the first name server, enter the second one as well. Let's check if these are being saved successfully. So yes, let's add the remaining ones. Now let's copy the third name server as well. And the fourth one as well. So let's click on change name servers. So it says changes saved successfully. So my domain name is now configured to connect to my Route 53. Let us now configure our Route 53 to connect to my instances, right? So let's do that. So let's create a record set. It is asking me the name. Now there is this concept, guys. Now any website that you visit, you can visit it in two ways. Say suppose you have facebook.com, right? So you can either go for facebook.com or you can go for www.facebook.com. Same is the case here. So if I go to edureka.tk, I should be pointed to the same website, and if I go at www.edureka.tk, I should be pointed to the same website as well, right? So we have to create both the record sets. So let's create a record set for edureka.tk only right now. So we'll click on aliases. Now when you're launching application in your Elastic Beanstalk environment, you don't get private IP addresses, you get aliases, right? So you'll click on aliases and you will select your Elastic Beanstalk environment. So this is it. Click on it and click on create. So my record set has now been added. Let's add one more with www in it, and let's select the same alias. So guys, this is it. It's been done. I have configured my Route 53 to point to my servers that are my instances, and I have configured my domain name to point to my Route 53. Now let's check if our URL is working. So it was edureka.tk. So it's pointing to my website. Congratulations guys, this is your first website. Let's check if we are being pointed to edureka.tk if we enter this as well, address as well. So yes, we are being pointed to the same website. Let's upload a file and check whether everything is working fine. Let's click on upload image. Open, upload image. It says S3 upload complete. Let's go back and check whether a file has been added. So yes, our file has been added. So our website is functioning fine, guys. So congratulations, we have successfully completed our practical and we have migrated our application to the AWS infrastructure fully, right? So let's go back to our slide and just recap what all we did. So we launched an Elastic Beanstalk environment, and this environment is basically hosting our website. Route 53 is pointing the URL to the servers or the instance that is hosting our website. RDS is our MySQL server, which is hosting the path for our images, and S3 contains our images, and IAM is giving our application or our website access to the S3 file system. So guys, any question related to any part that we have discussed now? Sebastian says, thank you, very nice session. You're welcome, Sebastian. Michael says no. Michael says nice practical. Thank you, Michael. Right, Neil says all clear. Alright guys, let's do a recap of what we just discussed. So we started off with what is cloud computing, and then we discussed what is AWS. After that, we discussed the different domains which are there in AWS, followed by the AWS services. After that, we discussed AWS pricing, and in the end, we did a use case where we migrated our application successfully onto the AWS infrastructure. So any part of today's session, guys, that you don't have clarity in, you can discuss right now. I will explain you guys again. All right, people are saying no. Neil says all clear. Sebastian says all clear. Shubham says thank you. All right, since everybody is giving me a go, let's wrap it up. So first of all, thank you guys for being a part of this session, for being patient with me. I hope you enjoyed this session and I hope you learned something new today. For the next session, I'll be handing you guys out the assignments, so they'll be uploaded to your LMS. I want each and every one of you to do those assignments and come back to me in the next session. Also, I want you guys to try out this practical at your own. If you have any problems, you have our support team at your disposal. You can contact them 24/7. See you in the next session, guys. All right, have a good day. Bye-bye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Hey guys, I'm Vishal from Edureka and I welcome you all to this online training session on AWS. Today we are going to discuss various nitty-gritties of AWS and I hope that you all are in the pinkest of your health because we are going to have some fun today. So let's not waste any time and quickly take a look at today's agenda first. Well, as far as this online training session goes, first you would be understanding what AWS is and what are its uses. Then we would discuss its different features or its advantages rather. Next, we would understand how its architecture works and how it is. Then we would understand its different services and the domains which AWS has to offer to you. Finally, I would finish things off with the demo part. Now, as far as the demo goes, I would be talking about what AWS free tier is, how an instance is created, what are its various security groups and all those things. Plus, you'll be having a lot more to explore. So stay tuned and I hope that you all have some fun today. As far as this session goes, I would want you to put your questions in the chat box below so that we can discuss those with other attendees as well. Now, if you all are fine with it, then quickly say yes in the chat box and we can move further. Okay, Shadul was the first to type. He says yes. Ashwin says yes. Megha says yes. Atul says yes. Okay, all are saying yes now. I believe we all are good to go. So let's get started then. So what exactly is AWS? Well, AWS is Amazon Web Services and it is one of the best cloud service providers in the market. So when I say cloud service provider, we need to understand what cloud is first. So let me throw some light on this topic. First, let me give you a scenario that existed before cloud came into existence. In order to host a website, I had to buy a stack of servers, and that was very costly. Second thing, upscaling and downscaling was a huge problem because I wasn't certain as in how much space I would be needing. And that meant wastage of resources or under or overutilization of resources. Thirdly, maintaining these servers was a huge pain. So these were all the problems that came into existence. Now cloud helped you solve all these problems. How? Well, what organizations did was some of them they went ahead and they bought some space online and they made arrangements for your databases, your services, compute services, and all those things. And businesses could go ahead and rent those services. That meant you could use or rent services which was needed and you paid only for those services. You could easily upscale and downscale here. So all your issues were taken care of. And when you talk about cloud services, the first thing that should come to your mind is AWS. Why? Because it is the best in the market. Let's try to understand a little more about AWS. Well, it is a complete software suite or a cloud service provider which is highly secure. It provides you with various compute, storage, database, and n number of other services, which we would be discussing in further slides as well. And when you talk about the market, it is the best, and it has various reasons to be the best in the market. One being its flexibility, its scalability, and its pricing. Other reasons being its compute capacity. Now, why is it so important, the compute capacity? Well, if you talk about the compute capacity, you need to understand one thing. If you take all the other cloud service providers in the market and you combine their compute capacity, that is, you leave out AWS and you take all others into consideration, the space would be somewhere equal to say X. And if you compare it with AWS, it is 6X. So AWS has more compute capacity, which is 6 times more than all the other service providers that are there in the market. So that is a huge amount. So these are the reasons that make AWS one of the best in the market. And let's try to find out what are the other reasons about AWS that make it so good. What are the services, features, and its uses basically. So I would be discussing some use cases now. If you're talking about a manufacturing organization, now their main focus is to manufacture goods, but most of the businesses, they focus so much on various other services or practices that need to be taken care of that they cannot focus on the manufacturing goal. Now this is where AWS steps in. It takes care of all the IT infrastructure and management. That means businesses are free to focus on manufacturing and they can actually go ahead and expand a lot. Architecture consulting. Now their main concern is prototyping and rendering. AWS takes care of both the issues. It lets you have automated or speed up rendering as far as prototyping is concerned. And that is why architectural business benefit a lot when you talk about using AWS or any cloud provider. But AWS being the best in the market, again, their services are the best. Media company. Now, as far as a media company goes, their main concern is generating content and the place to dump it or to store it. Again, AWS takes care of all these situations or both these situations. Large enterprises. When you talk about large enterprises, their reach is worldwide. So they have to reach their customers and their employees globally or across different places. So AWS gives you that option because it has a global architecture and your reach can be very wide as far as these points are concerned. So yeah, guys, any questions on this topic as far as these use cases are concerned? Okay, Shardul has a question. He says, okay, let me get this straight, Shardul. Yeah, fine. You're talking about the applications. Okay, that is what we were discussing. Oh, you want specific examples. Now I follow you better, Shardul. Okay, if you talk about real life examples, to give you an example, we have Quora, which is an online answering platform, if you all are aware about it. And that is like used all across the world. Amazon itself, we know that it is one of the biggest e-markets as far as shopping is concerned. And again, it is taken care by Amazon Web Services. Other examples would be Netflix, which we all love. I'm sure that we all watch online series, and what better place to do it than we have our Netflix, right? Yeah. So does that answer your question? Good, good. So let's move further then. Now, advantages of AWS. As I've mentioned, I won't say advantages exactly. I would say features as well. Flexibility. Now, as far as AWS is concerned, it is highly flexible. Now, there are various reasons to support it. And one of the major reasons is it's very cost effective. Let us try to understand these 2 points together rather. Now, when you talk about flexibility, the first concern you should have is you are dealing with big organizations. They have a lot of data that needs to be managed, deployed, and taken care of. Now, when you talk about a cloud provider, if it is flexible, all these things are taken care of. The second thing is it is highly cost effective. Now, when I say cost effective, AWS takes care of almost every aspect. If you are a beginner or a learner, they have something called as a free tier. That means you have sufficient resources to use for free, and that too for one long year. So you would have sufficient hands-on without paying anything. Plus, it has something called as pay-as-you-go model. Now, when I say pay-as-you-go model, what it does is it charges you only for the services which you're using and only for the time being you're using them. Again, that lets you scale up nicely, and hence you end up paying very less. Since you are paying very less, and since you have so many options when you're actually buying its services, what that does is that gives you a lot of flexibility. Scalability. Again, the first 2 points are related to this point. Now, how is that? Now, when I say scalability, what happens is, as I've mentioned, it is very affordable. So you're paying on hourly basis. If you're using a particular service for 1 hour, you'll be paying it only for 1 hour. That is how flexible it is. And what that does is that gives you a freedom to scale up and even scale down. Since it is easy to scale up, it is always advisable that you start with less and then scale as per your needs. Plus, there are quite a few services that are there which can be automatically scheduled. Now, what that means is you'd be using them only when there is an uptime, and in downtime, you can those get automatically shut down. So You do not have to worry about that as well. So when you talk about scalability, scaling up and down is very easy as far as AWS goes. Security. Again, now security has been a topic of debate when you talk about cloud services especially. But AWS puts all those questions to rest. It has great security mechanism, plus it provides you with various compliance programs that again help you take care of security. And when you talk about real-time security, even that is taken care of. You can take care of all the suspicious activities that are there, and not you. AWS takes care of all those things, and you're let free to focus on your business rather. So these are the advantages which I feel that AWS adds value to. And apart from that, there are quite a few other points, like we have automated scheduling, which I just mentioned. You have various integrated APIs. Now these APIs, they're available in different programming languages, and that makes it architecturally very strong to switch from one programming language to another. So these are some of the features I feel that make AWS a wonderful, wonderful service provider in the market. So let's move further and try to understand other things as far as AWS is concerned. It's global architecture. When you talk about AWS, as I've mentioned, it is the best service provider in the market. So what makes AWS this popular? One of the reasons is its architecture. Now, when I talk about its architecture, it is very widely spread and it covers almost every area that needs to be covered. So let's try to understand how it works exactly. Well, if you talk about AWS architecture, now the architecture is divided into two major parts, that is regions and availability zones. Now, when you talk about the regions and availability zones, regions are nothing but different locations across the world where they have their various data centers put up. Now, as far as one region goes, it might have more than one data center. And these data centers are known as availability zone. You being a consumer or an individual, you can actually access these services by sitting anywhere in the world. To give you an example, if I'm sitting in some part of the world, say for example, I'm in Japan right now, I can actually have access to the services or data centers that are there in US right now. So that is how it works. You can choose your region and accordingly you can pick your availability zones and use those. So you do not have to worry about anything. To throw some more light on it, you can take a look at this small map, which is the global map, and it shows the different places which has its regions and availability zones. Now, as far as this map goes, I believe it's fairly old and it has been upgraded in recent times because AWS is putting in a lot of efforts to have more data centers or more availability zones as far as their wide reach is concerned. And we can expect some in China as well. So yes, they are actually reaching far and wide. So when you talk about these regions and availability zones, if you take a look at this map, what you can see is you have your region, which is in orange color, and the number that is inside it is the number of availability zones that there has to be. Now, to give you an example, we have Sao Paulo, which says that it has 3 availability zones. So that is how it is. And the ones that are in the green are the ones which are coming soon or the regions that are in progress. And some of these have actually gone ahead and already started or have been made available to people. So yes, this is how the architecture works and this is how the AWS architecture looks like. So do you have any question on this, as in do you have anything that I need to answer? Okay, Mega has a question. No, Mega, there's no restriction. Okay guys, the question which Mega has is, she says that if I am in one part of the country and if I want a data center or availability zone in some other part of the country, would that be a problem cost wise? Well, to answer this, actually there's not a lot of problem or a lot of difference. Well, the first thing you need to understand is there are certain regions in the world which are costlier than the other regions, and when you talk about the regions being costlier, the difference is not a lot. It's very little because it varies from place to place. You have to understand, if you have a data center in London, that's obviously going to be costlier than most other regions or regions because it is one of the best cities in the world, and that's understandable. The reason for this is the costs as far as AWS goes also depend on the government policies and the various resources that are made available. So it's a combined cost. But when you talk about different regions, there's not a lot of difference in it. A little, but yeah, it's there. Apart from that, the other thing you need to consider is if you're located in one part of the world, accessing data from the other part of the world, if it's way too far away from you, it can be a problem when you're dealing with large amount of data or when your resources are huge. In that case, computing and all these things might face some latency. And that case is where you need to consider a few things. But as far as a learner goes, You can actually go ahead and pick any data center and start practicing actually. But when you talk about businesses, you need to consider few of these points. I hope that answers your question. Okay, so let's move further and take a look at the next concept. Domains of AWS. Now, when you talk about its domains, the first domain that we are going to discuss is compute. And when you talk about compute, the first thing that should come to your mind is EC2. Now, when I say EC2, it is Elastic Cloud Compute. And what it does is, it lets you have a resizable compute capacity. It's more of a raw server where you can host your websites, and it is a clean slate. Now, what do I mean by this? Say, for example, you go ahead and buy a laptop. It is a clean device where you can have your own OS. You can choose which OS you want and all those things. Accordingly, your EC2 is again a clean slate and you can do so many things with it. Now, next you have Elastic Beanstalk, which lets you deploy your various applications on AWS. And the only thing you need to know about this thing is you do not have to worry about the underlying architecture. Now, it is very similar to your EC2. And the only difference between the two is, as far as your Elastic Beanstalk is concerned, you can think of it as something that has predefined libraries, whereas your EC2 is a clean slate. Now, when I say predefined libraries, say for example, you want to use Java. As far as EC2 goes, now this is just an example, don't take it literally. You'll have to, say for example, install everything from the beginning and start fresh. But as far as your Elastic Beanstalk is concerned, it has this predefined libraries and you can just go ahead and use those because there's an underlying architecture which is defined. Let me say it again. I just gave you an example. Don't take these sentences literally. Okay, I have a question here. What Ashwin says is, can you tell me something about Lambda? Okay, Lambda is again a compute service. You need to understand one thing, that it is again similar to these services, but Lambda cannot host websites and all the tasks it performs happen in the background. So yes, again, it is a very important cloud service. I missed out on it, a compute service rather. And yes, it is very popular as well. So next we have migration. When you talk about migration, you need to understand one thing. AWS has a global architecture and there would be a requirement for migration. And what AWS does is it lets you have physical migration as well. That means you can physically move your data to the data center which you desire. Now, why do we need to do that? Say, for example, I'm sending an email to somebody. I can do that through internet. But imagine if I have to give somebody a movie. So instead of sending it online, I can actually go ahead and give it to someone if that person is reachable for me. And that way it would be more better for me. My data remains secure and so many other things. So same is with data migration as well. And when you talk about AWS, it has something called as Snowball, which actually lets you move this data physically. Now it's a storage service and it actually helps you in migration a lot. Security and compliance. Now, when you talk about security, we have various services like I have IAM, we have KMS. Now, when I say IAM, it is nothing but your identification and authentication management tool. We have KMS, which lets you actually go ahead and create your own public and private keys, and that helps you keep your system secure. Now, there are quite a few other services as well, but I would be mentioning one or two services from each domain because as we move further in future sessions, we would be discussing each of these services in detail. And that is when I would be throwing a lot more light on these topics. For now, I would be giving you one or two examples, and because I want you all to understand these to some extent. Getting into details of all these things would be too heavy for you people because there are quite a few domains and quite a few services that we need to cover. And as we move further, definitely we would be covering all those services in detail. Then we have storage. Now, when I talk about storage, again, AWS has quite a few services to offer to you. We have something called as your S3. Now, S3, it works as a bucket object kind of a thing. Your storage place is called as a bucket and your object which you store in are nothing but your files. Now, these objects have to be stored in their root files, which act as the buckets basically. And then we have something called as your CloudFront, which is nothing but your content delivery network. We have something called as Glacier. Now, when you talk about Glacier, you can think of it as a place where you can store archives because it is highly affordable. Next, we have networking. Now, when you talk about networking, we have services like VPC, Direct Connect, Route 53, which is a DNS. Now, when I say VPC, it is a virtual network which actually lets you move or launch your resources. That is your AWS resources basically. When you talk about Direct Connect, you can think of it as a leased internet connection which can be used within AWS. Next on this list, we have something called as messaging. Yes, AWS assures secured messaging, and there are quite a few applications to take care of that as well. Now we have something called as Cloud Trial, we have OpsWorks, all these things, they help you in messaging or communicating with other parties basically. Databases. Now storage and databases are similar, but you have to understand one difference. When you talk about your storage, that is where you store your executable files. So that is the difference between the two. And when you talk about databases, we have something called as your Aurora, which is something which is very SQL like, and it lets you perform various SQL options at a very faster rate. And what Amazon claims is it is 5 times faster than what SQL is. So yes, when you talk about Aurora, again, a great service to have. We also have something called as DynamoDB, which is a non-relational DBMS. And when you talk about non-relational DBMS, I won't be discussing that, but this helps you in dealing with various unstructured data sources as well. Next on this list, we have the last domain, that is the management tools. Now, when you talk about management tools, we have something called as CloudWatch, which is a monitoring tool, and it lets you set alarms and all those things. Hopefully today when we are done with the demo part, you'd be having at least one part of your CloudWatch covered, because we would be creating alarms using CloudWatch today. So stay tuned for that as well. So this was about AWS and its basics, as in the points which we just discussed, that is what it is, its uses, its advantages, its domain, its global architecture. Do you all have any questions related to this? Because I'm quickly going to switch into the demo part. We would be understanding what free tier is, how AWS works, what it all has to offer as far as the free tier is concerned, how to create an account, and all those things. So if you people are fine with it, can we just quickly switch to the demo part? If that is the case, then quickly say yes in the chat boxes below. I'm getting a yes. Good to go? Yes. Okay, fine. Then we can move further and get started then. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS account. The first thing you need to understand is what AWS does is it offers you a free tier. Now, while I was talking about these things, I just rushed through it because I knew that I was going to give you a demo on these things. So, and I wanted to discuss this thing in detail. Now, when you talk about AWS, if you're a beginner, this is where you start. Now, what AWS does is it provides you with its free tier, which is accessible to you for 12 months. And there are quite a few services which we just discussed, which are available to you for free. And when I say free, there's certain limitations on it, as in these many hours is what you can use it for, and this is the amount of memory or storage you can use in total, and all those things, and its capacity and everything. Based on that, you have different instances which you can create and all those things. Now, what AWS does is it gives you these services for free, and as long as you stay in the limits that AWS has set, you won't be charged anything. And trust me, when it is for learning purposes, that is more than enough. And let's quickly go ahead and take a look at these services first, and then there are a few other points which I would like to discuss as well. But firstly, the free tier services. Now say this is what it has to offer to you. 12 months of free and always free products. When you talk about EC2, which is one of its most popular compute services, 750 hours, and that is per month. Next, you have Amazon Quick Site, which gives you 1 GB of spice capacity. Now, I won't get into the details of these things, as in what spice capacity is and all those things. When you have time, I would suggest that you go ahead and explore these things, as in what do these things do. Today, we are going to focus more on the EC2 part. So for now, let's quickly take a look at these one by one first. Amazon RDS, which gives you 750 hours of your T2 micro instance. Amazon S3, which is a storage, which again gives you 5 GB of standard storage, and AWS Lambda, 1 million free requests per month. So there are some of the videos here actually which would introduce you to these things that would help you get started with how to creating an account and all those things. And this is the other important point which I would like to mention. When you do create an AWS account, the first thing you need to consider is they'd be asking you for your credit card details. So how does the login process work? Firstly, you go there, you give in your email ID and your basic details, as in why do you want to use it and all those things. Next, what it would do is just to verify your account, it would ask you for your credit card details. Even the debit card details work. I've actually tried those. So you can go ahead and give your credit card or debit card details. And when you do that, what it does is it subtracts a very small amount from your account. I did this in India and I know that I was charged 2 rupees, which is fairly less. And that was again refunded back to me in 2 to 3 working days. The only reason they cut those 2 rupees was just for the verification purpose that my account is up and running and I am a legitimate user. Now, as long as you stay in the limits, you won't be charged anything. But if you do cross those limits, you'll be charged. Now, you might be worried as in, what if I do cross the limit? Would I be charged? Yes, you would be. But the fact is, you actually won't go beyond it. And even if you do, you'll be notified saying that you are going about the limit or above the limit. Even when your free subscription ends, you're notified saying that, do you want to enter your billing details and do you want to start billing? And if you say yes, only then you'd be charged for the subsequent months. And that is a very stringent process. You don't have to worry about it. That is, you won't be losing out on any money as long as you follow these rules. So if you do not have an account, my suggestion would be you go ahead, you log into AWS and create your free tier account, which is a very easy and 2 to 3 step process. Once you've done that, these are the services that are available to you, and you can go ahead and use all of these services on your own. Next, we have something called as your simple monthly calculator. Now, this is a very useful app to have. What it does is, whatever service which you are going to use, you can enter in the detail and accordingly you'll be given the price as well. Now, this is something for use after your free tier ends, so that you know that if I have to use these services, how much would I be charged? And this thing will tell you in total. Now, if you can take a look at here, you have these services. Say, for example, I want to add an EC2 service. An instance gets added here. I can put in the description. Now it is Linux t1.micro instance, and this is what my monthly cost is. I can go ahead and I can change the number of instances here to suit my need, and accordingly everything would get verified as in, okay, this is the cost and all those things. So if I enter these values, my AWS calculates all the values accordingly for my storage, for my compute, and there are the other details which you can go ahead and fill in here. And once you've done that, you can actually come here and you can check your estimate monthly bill, because once you save those details there, or once you calculate those details, here would be your monthly expense, because you would be dealing with more than one instances. So your different costs are added together and a total is given to you here. And you can actually go ahead and save it and share it with others, because yes, you might be required to exchange these details with some of your colleagues or whatever it is. And to do that, you have an option here as well, which is provided by AWS. There was a query on Stack Overflow once, as in, can I do that? And AWS quickly responded by going ahead and solving this issue and giving them with this save and share button. So yeah, this is your calculator, your monthly AWS calculator, which lets you take care of your usage and gives you the bill accordingly. So if you're worried about as in how much you're going to spend by using AWS or its services, you can always come here and calculate that as well. Now, that being said, let's quickly move to the demo part and see what all we can do with the AWS. Now, I have my account here and I've logged in actually. So these are the services that are there at my disposal rather. So I'm just going to go ahead and open one of these. Say, for example, I open my EC2 service. My internet is a little slow today, so yep. As you can see, I have one running instance, I have one key pair, I have 3 security groups. As we move further, we would be dealing with these and we would be implementing or creating new instances and all those things. So firstly, what I want to do is I want to go ahead and create a key pair. Now, why do I need to do that? The first thing you need to understand is when you create a key pair, what you're doing is you're actually going ahead and you're creating your SSH key. Now, when I say SSH key, that is something but a secure shell key. Now, this key is very useful when you talk about certain OSs, because that helps you establish your connection. When you talk about Windows, you do not need to do that. So, but still you would be needing an SSH key. Now, you might wonder why. The reason you'd be needing it is because given on the longer run, even if you're using Windows, you'd be required to put in an admin login, and for that you'd be requiring this key anyways. If you're on using this application on your Linux OS, in that case, it is a must that you generate the key first. One more thing you need to understand is once you generate this key, you need to take care that you do not lose it, because once it's gone forever. So that is one precaution you need to take. So let's first start by creating a key pair here. And as we move further, you'd understand why did I create one. So I say create my second key, because I believe I've created a key in this account prior to this. Second key, I say create. And there you go, I have a key. Now my second key is something which I basically have it here. I'll just cut it from here and I'll paste it in one of my folders basically. So let's say I'm here and I say I need a new folder. I come here, I say AWS demo, and I put my key in here. I would be needing this. That is why I'm doing it. Now you can see that the extension here is .pem. You might get other extensions depending upon the system which you're using and the OSs that it's running or using. So depending on that, this extension might vary. It's preferable that it is .pem. So yep, we have this key now, and let's see what we can do with it. I'm gonna go ahead and select this key, unselect this for now, and I have all the information as far as this key is concerned. Now, as I've already mentioned, that security is very important when you talk about your cloud services. So it is very important that you define a proper security group to take care of all these things. So before we create an instance, let's quickly go ahead and create a security group first. I come here. I've actually gone ahead and created a security group. So I would want to go ahead and create one more. So I would say create. Now, when I do that, I need to give in a name to it, say this security for today's demo. I say security demo description for reference sake is what I would say. There you go. And we'd be going ahead and adding in rules here. And then where do I want certain rules? Because you can go ahead and define certain rules. How do you want to give access to your system and all those things? So I say, as far as my accesses are concerned, I'd be wanting an SSH rule. See, the port range is given to you because you can communicate with the system through these ports basically. And then I can go ahead and add more. I can say HTTP. There you go. I say I would be needing HTTPS as well. And since I'm using Windows, I would go for RDP. Now these are the different port names that are there. Now, as far as these groups are concerned, so you can see that this has 00000 security, because you would be wanting these ports to be available to others as well. Because why? You're dealing with data exchange and all those things. So these are the ports that need to be active. Now you have your SSH and your RDP. Yes, for now they're secured here. I can actually go ahead and change it here for the simplicity sake. If I have it something like this, or maybe like this is how it would look like. And for the sake of being easy to use, I'd be having it like this. But as far as you are concerned, you need to consider better practices for this. You have different sources here. Why? Because you have an option to customize it. You can go ahead and customize those, because there are certain services which you would be wanting to use differently, and it is very important that your system is secured, because since certain services would be accessing your data, it is important that access is denied to them in certain cases where it's not required. And that is why you need to consider your security practices. Now, as far as this demo goes, this is a basic thing which we are doing, and we can ignore our security policies here. This is just for the demo sake, and I would be creating a simple security group. So this sources, bear with it for now. Now I say create, and there you go. My security group is created. It is security demo here. That is the name. Now let us move further and go ahead and create one of the instances that we can do. So I go to services. I say EC2, and I say launch an instance or create an instance. Now there are quite a few instances here. We have Linux and all those things. I would be going for Microsoft Windows. Let me just go ahead and pick one. We can actually go ahead and pick any. The only thing we need to consider is whether it's eligible for you. Now, when I say eligible, I mean eligible for your free tier basically. So let us go ahead and pick one of these. I would say base 2012 server. Let us see whether it's doable for us. Yep. Now this is selected by default because it's free tier eligible, and we're actually going to go ahead and use it. Now, when you're creating an instance, you need to understand one thing. These are the details that are there about the instance, and these are some of the points you need to consider. When you say review and launch, you can just click on it. You would directly be taken to the last step, and all the by default admits are given to you. But now that we are doing it for the first time here, I would want to do it step by step. There's nothing we are doing. We are just selecting the by default thing, but I just wanted to see what all it has to offer to you. Say, for example, when you pick a general purpose T2 instance, number of CPUs, 1, your memory, 1 GB basically. And these are the other details, as in network performances, low to moderate and all those things. So I say next. These are the details which I can enter in, as in the number of instances, purchasing options, network, subnet, and all these things. Is there an IAM rule and all those things? So yeah, for now, I'm not going to make any changes again here, and I'm just going to say next. As you can see the size, I have 30 GBs of total available with me. and these are the details about it, IOPS and all those things. So you can just go ahead and say next. Now you have an option here whether you want to go ahead and add a tag and all those things, and you can do that. Or you can just go ahead and say next. You have a wizard here, and there you go. I have my 7-step where I can go ahead and launch my instance. You can see I have a notification here saying that improve its security. As I've mentioned that we are doing it for the demo sake, and I've chosen few basic ones. So I do not have to worry about anything. My ports are open and those are accessible. So the thing is, my AWS is warning me as in you should not have it that way. So when you do go ahead and implement it on larger scales, you need to take care that your security groups are well defined and properly defined. For now, let's go ahead and say launch. Now it would ask you to pick a key pair. As I've mentioned, that key pair is important whether you're using it on Windows or not, but you need to go ahead and define a key pair. So I would go ahead and select an existing one because we created one. Proceed with a key pair. Okay. I say I acknowledge and I say launch. And it says that your instance is now launching. So what I'm going to do is I'm going to go ahead and view the launch log, and it gives me details as in what are inbound rules and all those things are mentioned here. How do I connect to my instances and all those things. There's an information here. I can just go ahead and say view instances. And there you go. I have both of my instances here and the details are given to me as in what are the details. Now I've gone ahead and I'm stuck with this availability zone as far as I'm concerned, which is Mumbai for my case. You can go ahead and pick an availability zone for your sake, but make sure you stay consistent with it because that would be more convenient for you. That is for your different instances. Status checks as far as this goes. Everything is okay here. This was the instance which I launched yesterday. This is the one which I've launched today, which is still initializing. So there you go. You have one here. Yeah, so this was about going ahead and creating an instance as far as AWS is concerned. Now, what we can do is we can go ahead and try and do other things as far as your AWS is concerned. Now, the other points which we need to discuss are, can we connect this instance to a server? And the answer to this question is yes, we can do that. Meanwhile, what I want is I want my instance to refresh first and everything needs to be in place before we do that. Yeah, so there you go. Now as you can see the status checks, as far as the checks are concerned, it is complete and we can go ahead and we can connect to a server now. So I was talking about the different servers that you can go ahead and connect to. Now, if you're using a Linux machine, you need to understand one thing, that you have to go ahead into your terminal and then you have to connect to your server. But when you talk about Windows, the process is a little different. Let us see how we can do that using Windows. Say for example, I select this instance here, the second one, I say connect. So what I'll have to do is I'll have to go ahead and download a remote desktop file for that. And how do I do that? I do this. I say connect. It would be asking me for my admin password here. It would give me an error because I need the password here and I guess I missed out on the password. Just bear with me. Let me just generate the password and I'll get back to you on this. Okay, so how do I do that? What I'm going to do is I'm going to get into my previous instance, this one, and I'm just going to connect or try to connect it because I have one here already. So as you can see, I have this option here which says get me a password. As far as my administrator or username is concerned, it is administrator. And when I say get password, I'll be clicking here and it would be asking me to choose a file. Say for example, I go ahead and I choose one of the files. Now I had downloaded the password last time, or the key rather. Now that is why you need the key. When you store it at some place, you'd be asked for this key and you have to enter it here. And when you say decrypt password, there you go. You'll be getting your password here, which is this. Now I would be copying this password for my reference sake. Control C. Just to give you a demo again, I'll download it. I'll close it. And I would say connect. It would ask for the admin password and I say take this. Do you want to connect despite these certification errors? Yes. And there you go. I've connected to the server here and this is the file which I created the last time. There you have it. So this is how you go ahead and actually create your instance and connect to the server. You can go ahead and create another files here. You can say new, you can have your options. It's just like your nice operating system where you can do so many things. Yes, it's more of a clean slate and you're it's fully available to you to go ahead and edit it the way you want to. So this is what we did right now. We've actually gone ahead and we've created an SSH key. The reason we did was because we wanted to log in here. Second thing, we went ahead and we created a security group. Yes, it wasn't great, but you can actually set security rules as per your needs. Then you can go ahead and launch an instance and then you can connect to a server you want to. Now this is what I have here. I can actually go ahead and do other things as well. What are the other things that I can do? Well, I can go ahead and I can set alarm for my systems. And how do I do that? Now I have something called as my CloudWatch here under my management tools. Now when I come here, I can go ahead and set alarms as well. What kind of alarms? Say for example, I want to monitor my system and I want to make sure that the usage as far as my system is concerned, it does not go above maybe say 70%. And if it does go above 70% and that happens for 5 continuous minutes, I want my system to throw in an alarm for me. So can I do that? Yes, I can actually go ahead and do that. I can create an alarm and I can do that accordingly. I click here on alarm. I say my EC2 metrics basically, or I just type EC2 here. All the services are here. And since we are creating an alarm for utilization, let's select that. You get all the details here as in how much is the usage and all those things. You can come here and define the alarm name, say CPU usage greater than 70%, say, and you say throw an alarm when usage exceeds 70%. There you go, 70. And I move down and I say notify me. How do I do that? Send notification to new list. Suppose I enter in some email ID. Now take this for example. Suppose I go ahead and use this account here and I say create an alarm. Okay, there has to be a name as well. Say VPT for example. And congratulations, your alarm has been created. It says insufficient data because there's pending information here. You need to understand one thing. When you do create an alarm, the email ID you enter in, AWS would go ahead and it would give in a message to the email ID or in the email ID saying that this is something that is trying to happen here. Do you want to be notified when the usage goes this far? And if the user says yes, or he or she confirms that that can be done, in that case, AWS would configure this status saying that yes, it is no longer pending, and the status would be displayed here and this would turn to green. So this is how you actually go ahead and create your own alarm as far as AWS is concerned. So I hope you've understood this part. Now this pretty much brings us to the end of the today's demo, as in we've discussed all the points that we were supposed to, and I hope you all had something new to learn. So do you all have any queries that I can answer? Okay, I see people typing now. Okay, Ashwin, that is about direct connect. Ashwin, we can take that offline actually because yeah, that is not something that we've discussed till time, and since we would be moving further in our future sessions, we would be discussing all these things in detail. Now that you put forth this question, I would be answering that, but let's take it offline and let's keep this discussion to the points that we've discussed for today. So do you all have any other questions, guys? Yeah, as far as the data is concerned, you would be having access to all the material that we've covered today. So do not worry about that. As far as your LMS goes, you'll be having a copy maintained there as well. So once this session is done, you'll be having a copy of it and you can have access to that as well. So do you all have anything else? Okay, that's it then. I hope to see you all again. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Welcome to this session on cloud computing tutorial for beginners. Guys, this is a live session and it is meant for people who are new to the cloud computing industry, right? So I'm going to start with the basics today. I'm going to discuss cloud computing from scratch, and I hope you enjoy this session today. All right, so let's go ahead and start with the agenda to see what all we'll be covering in today's session. So guys, this is our agenda. We'll start with why do we actually need cloud computing, and then move on to see what is cloud computing exactly. After that, we're going to see what are the different cloud models which are there in cloud computing, and moving on, we'll look at cloud providers. So cloud providers are the companies which provide you with the cloud services. All right. Once we're done with that, we'll move on to the hands-on part where you will launch your first server in the cloud. We will try to deploy it in AWS and in Azure as well. All right. So guys, this is our agenda for today. I hope it's clear to you. Some things that I like to mention, guys. Any doubt do you have during the session, please comment it in your comment box. My team is here to help you out in that. All right. So with that, let's start today's session with the first topic, which is why cloud computing. Alright, so let's understand this using an example. Say you want to host a website, right? And say there is no cloud computing right now, right? And you want to host a website. How would you do that? So first, you would have to buy a stack of servers, right? You need servers to host your website on. After that, you have to keep the peak traffic in mind. Now, what is peak traffic? Peak traffic is basically the traffic which comes for a shorter duration. For example, you can expect the most traffic between 6 p.m. and 10 p.m. because that is the time when people are the most free, right? So there's a peak traffic, and after 10 p.m. the traffic can decline. So when your traffic booms, you have to have the servers to manage them, right? And after 10 p.m. if the traffic declines, these servers that you have deployed to handle your traffic become idle, right? So you have to get maximum servers so that you don't get any problems when the traffic goes up in a peak, right? After that, since you have these many servers, you have so many servers, you have to continuously monitor and maintain them, because you don't want your website to experience a downtime, right? So you have to continuously monitor them and maintain them so that your website is up and running. All right. So the setup that is without cloud computing had some disadvantages. Let's see what were the disadvantages. Right. So first of all, the setup was very expensive because you are buying servers on your own, right? And servers, guys, are not cheap. They're very expensive. All right. So the setup was very expensive. Also, since you are troubleshooting problems on your own, that is, you're maintaining your servers, you're monitoring them at the same time, right? So these problems could be tedious, and they can conflict with your business goals. What I mean by that is, if you have someone to handle your servers, then you can actually focus on how you can expand your application. But if half of the time you're worried whether your website is experiencing any downtime, or are you protected with all the latest security patches and everything, and then you cannot focus on your security goals. All right. The third thing was, since the traffic is varying, your servers will be idle most of the time, right? So like I said, you have to have the maximum servers so that your any kind of traffic can be accommodated within your servers, right? So like I gave you a window that between 6 p.m. to 10 p.m. you'll experience the most traffic, but what will happen 10 p.m.? Happen after 10 p.m. After 10 p.m. your traffic will drop and most of your servers will become idle. So that was a problem. All right. So these problems were to be faced, or these were to be solved, and we solved it using cloud computing. Now came cloud computing, and now we were able to solve these problems like this. So first of all, our problem was that our setup was very expensive, right? So with cloud computing, it was solved. How? Because now we don't buy servers anymore, right? We just rent them from the cloud providers, and we can rent them not on a monthly basis, not on a yearly basis, but on an hourly basis. Right, on hourly basis, and now you can rent them actually on minutes basis as well. So as long as you want the servers, you pay for them, and when you're done with your servers, you can terminate them, and that's it. You don't have to pay anymore. So this is a very cool thing about cloud computing. Also the scalability factor. So you had to scale your resources according to your traffic, right? So you don't have to maintain the maximum number of servers now. What you can do is you can vary your number of servers according to traffic. So if the traffic is more, you can auto scale your servers to a number which is okay with the number of people who are trying to access your website. And as the number of people who are trying to access your website goes down, as the traffic goes down, you can scale down from the number of servers you were having. All right, so scalability is again a feature in cloud computing. Also, when you rent servers on cloud, you don't have to manage them or maintain them anymore. So that is the responsibility of the cloud provider who's providing you with those cloud servers. So so now you can focus on your business goals. You can focus on how to expand your application and other things. Right, so it becomes very tension free when you're using cloud computing, and at the same time, it's cheap as well. So it's a win-win situation. So we have understood why do we need cloud computing. Let's go on and understand what is cloud computing exactly. All right, so cloud computing is the use of remote servers on the internet to store, to manage, and to process data. Rather than doing it on a local server, you do it on remote servers. So this is what cloud computing is. You can store your data, you can manage your data using databases, or you can process your data using by renting a server which has larger processing power. So you can get it faster. You can get your work done faster rather than had to do it on a local computer, which would have been slow. On the other hand, if you wanted to do a large batch processing work, you could have bought a server which had a lot of processing power, but that wouldn't have make sense, because after your work is done, you don't need that computer anymore, right? So all of that problems could be solved with cloud computing. All right, now cloud computing also is further divided into models, right? So there are two types of models in cloud. So the two types of models are service models and deployment models. So service models basically mean the kind of service that cloud offers. These service can be divided into further modules, and then you have the deployment models. How can you deploy your application? So when I say deploy your application, how you can upload your application, in what ways you can upload your application on the cloud. Right, so these are the two different models that you have in cloud computing. So let's discuss them one by one. So first, let's discuss the service models. What are service models? All right, so you basically have three kind of service models in cloud computing. You have infrastructure as a service, you have platform as a service, and then you have software as a service. Right, so let's discuss each of these. So first, you have the infrastructure as a service. So when I say infrastructure as a service, imagine it like this: you get a server on cloud, right? So you choose an operating system and you get that server on the cloud. For example, you want a Linux system on the cloud, right? So you request your cloud provider for the Linux system, and they give you a fresh system to work on. So they'll give you the IP address, they'll give you the password, you can remote desktop into that server, and now that server is fresh. You can install anything on that server, and you can make that server anything. For example, you can make that server to be a web server, you can make that server to be a database server. It's all yours. You can do anything with it. So that is infrastructure as a service, because you have the access to the operating system of your server, right? So it provides virtualized computing resources over the internet. No worries about the underlying physical machine, because you don't have to manage the physical machine. That all of that is managed by the cloud provider, and it abstracts the user from the physical machine. All right, so these are the points about infrastructure as a service. Then comes platform as a service. So in comparison to infrastructure as a service, where you were getting the access to the operating system and you can do anything with the system, when you are using platform as a service, you don't get the access to the operating system. All you get to an access to is a user interface. For example, you want to host a website, right? So you take a service from AWS or Azure, and you say, I want a platform, I don't want the whole infrastructure. So what they do is they launch a server, and they don't give you the IP address and password to it. So you don't get the access to the operating system. What they do give you is a button, right? So you can click on that button, which is upload, and upload your website onto it, right? And that is it. You don't have to install any software. You don't have to manage the files over there. You don't have to do anything. You just have to upload your files, and those files will be automatically deployed on whatever link that they will give you, right? And you go to that link and the website will be deployed as it is. You don't have to manage the operating system at all. This is what platform as a service is. And then comes software as a service. So software as a service basically means you don't get the server, you don't get a user interface, you basically just get a software, right? For example, Salesforce Cloud, that is the most common example that you guys might know. And for those of you who don't know Salesforce, imagine it like this. So if you launch a server on the cloud, you are getting Windows operating system as well, right? Now, as you guys know, Windows operating system is licensed, right? But if you are renting a server on the cloud, you are basically using Windows as a software as a service as well, right? Because you have rented the Windows software as well, right? So that is the most easy way you can understand it in, that that you take software as a service rather than taking the whole server as a the whole infrastructure as a service, or taking as a platform as a service, right? So this is what software as a service is. Moving on, guys. Now, if you would like to conclude what you just learned, you can say if you have your own computer, you'll have to manage the networking, the storage, the servers, the virtualization, operating system, and everything, right? If you take infrastructure as a service from a cloud provider, you have to manage only the operating system, middleware, runtime, data, and applications, right? So this is what infrastructure as a service is. If you take platform as a service, wherein you just can upload your application, you get the applications and data which you can manage. The rest, everything is managed by the cloud provider. And if you take software as a service, you don't get to manage anything. You just can use the software as you want, and when you're done with it, just delete it from your subscription, right? So you don't have to manage the underlying computer, you don't have to manage the underlying operating system, not anything, just the software that you get, pay for the software that you use, and you're done with it, right? So these were the service models. Then comes the deployment models. So what are deployment models? So deployment models are basically of three kinds. You have the public cloud, you have the hybrid cloud, and then you have the private cloud, right? So what is the difference between these three? Public cloud is basically when you're sharing your server with a host of different people, right? For example, you launch your server on AWS, right? So if you're launching a server on AWS, you are basically getting a server on the AWS infrastructure. Now you don't know whether the server on which your operating system is hosted is also giving operating system to someone else or not, because on one server you might have hundreds of operating systems which are virtualized. All right. So if you are say using a Linux system on AWS, and you haven't specified that you need a standalone server, or you haven't specified that you need a private server, your server can be shared with a lot of customers. All right. So if you would like to opt for a standalone system, that standalone system could be a private cloud, because they give you the server privately, that this is your server and we have deployed only your operating system onto it, and you can use it, you can be rest assured, you can be safe with your data over there. Right? So it's not like if you are using a public cloud server, your data is not safe. But some companies have this policy that their data is confidential and it cannot be hosted on public cloud. So in that case, you use a private cloud. The other side of private cloud is that you host your own servers, right? You buy servers and you set up your own cloud, right? And you deploy applications on it. That also is termed as a private cloud. Now, hybrid cloud is actually a mixture of both public cloud and private cloud. So if you have an application wherein you're using public cloud and private cloud both, you term it as hybrid cloud. For example, if you are in a data science company, right, and you want to host a website. So hosting a website can be done on the public cloud, but you have, at the same time, you have some confidential data as well that you don't want to expose to the internet, right? So you can do that on public cloud as well, but because of companies' policies, you can host it on your own servers, right? So this kind of architecture then comes out to be a hybrid cloud architecture, wherein you're making use of public cloud and private cloud both, right? So these were the deployment models, guys. Moving along, now you've learned the basic concepts about cloud. You know why do you need cloud, you know what is cloud exactly, you know the different models of the cloud, and you understand that okay, so this is what the cloud world is all about. But how do you get started? How to get your own server in the cloud? So for using cloud computing, you first have to contact a cloud provider. And if you want to choose which cloud provider to choose, there are actually hundreds of cloud providers out there. Right, so which one to choose? So let me list out a few of the cloud providers. You have Rackspace, you have DigitalOcean, you have IBM Cloud, Microsoft Azure, Google Cloud Platform, Joint, Termac, VMware, and of course AWS, right? So AWS and Microsoft Azure, if you talk about, they are the top two cloud providers in the industry, right? And today in this session, I'll be telling you guys about AWS and Microsoft Azure both, right? So let's go ahead and launch our first server in AWS and Microsoft Azure, right? So let's move on to the demo section. Let me quickly switch to my browser where you can launch servers. So hold on a sec. All right, guys, so this is how this is my browser. So first I'll be going on to the AWS console. So let me go to the AWS console. All right, so the first thing that you need to actually be on AWS is creating an account. So I'm assuming you guys have an account on AWS, or if you don't, once you have that, just go to your console and this is how it will look like, right? So these are all the services that AWS has to offer us. So our aim is to launch our first server in the cloud, right? So the infrastructure as a service part that I was telling you, that service in AWS is called EC2, right? So you'll be clicking on EC2 and you will see this console, right? So we are interested in launching an instance, right? So I'll click on launch instance, and then I get to choose the operating system that I want, right? So for now, let's launch an Ubuntu server. So I'll select the Ubuntu server. I'll choose the processing that I want, processing path that I want. Now remember guys, for those of you who are practicing in AWS, once you create an AWS account, there is something called a free tier, right? So a free tier, under the free tier, you can launch AWS services free for 1 year up to a certain limit. All right. So remember, the only free tier eligible processor in this in these selections is T2.micro. So ensure that you're selecting T2.micro every time you're launching a server, right? For practice. Next, you'll click on next, and you don't have to worry about all these settings. Since this is a basic session, we are just interested in launching a browser, in a server. You can straight away go ahead and click on review and launch. Everything is by default set. So you can review all the settings which you have done and now click on launch. Once you click on launch, you will be prompted with this screen where you have to create a key pair. What is a key pair? A key pair is basically a way to authenticate yourself to the servers of AWS, right? So you basically have a public key and a private key. So whenever you're trying to connect to your server, you have to match your private key with the public key which is there on AWS. So they give you the private key, and every time you try to connect, you have to feed in the private key to connect to the server. All right, so let's create a new key pair right now. Let's click on create a new key pair, and let's give it the name as Hemant_2. all right, and now let's click on download key pair. All right, so my key pair has been downloaded. Let's copy this key pair to our desktop. Right, let me paste it here. All right, so my key pair has been pasted here, and now let's click on launch instances. Alright, so my servers are now being launched. I can check the status of my servers by going on to the AWS Management Console and clicking on EC2. So I can go to this particular link, and as you can see, there'll be a server which will be deployed. So it says it's in the pending state. That basically means it is being deployed right now. Okay, so while this is being deployed, let me quickly show you how you can deploy a server in the Azure cloud service as well, right? So for going to the Azure service, let me type in the URL, that is portal.azure.com, and again you have to have an account to actually work in Azure. So once you create an account, you will be prompted with this screen, which is basically the console wherein you can work with Microsoft Azure. So what we want to do is we want to launch a server in Azure. So let's do the same thing. Let's launch an Ubuntu server in Azure. So like in AWS, the infrastructure as a service was known as EC2 service in AWS, right? So if we talk about that same exact service in Azure, that service is known as virtual machine. So we'll go to virtual machines. We'll click on virtual machines, and we'll be prompted with this screen. So we have to add a new server. We'll click on add. and then we'll get this screen wherein we have to choose our choice of operating system. So let's launch an Ubuntu server, and then what type of Ubuntu server do I want? Let's choose the 16.04 one, and let's click on create. Right, with that you will get this screen wherein you have to fill all the information. So let's name our server as edureka demo-1. Then the username, so username is basically the login name that you want your server to have, so let's give it the name as edureka. The authentication type, so it supports both. You can either have an authentication type of the public key that I got in AWS, or I can just choose to have a password, right? So that is pretty simple. Let's choose a password here, and let's confirm the password. Alright, and then you are prompted to choose create a resource group. So basically a resource group is something where is a group of resources, right? So it basically is there to make your life easier. You can manage all your resources under one group, right? So we are creating a new instance. Let's create a new resource group for it. Let's call it edureka demo, and we'll click on OK. Right, so next screen they will ask me the configuration that I want for my server. So let's choose the least configuration and click on select. Alright, so leave all these settings at blank. You don't need to touch them. Just click on OK, and then you will get this page wherein you'll have to review everything and click on purchase. So this page usually takes time to come on. Okay, it came. So we just have to agree to the permissions and click on purchase, and you're set. Your server will start getting deployed on Azure, right? So while this is being deployed, let's check if our EC2 server is ready. So yes, it is in the green state, which means it's now ready. Let's try to connect to this server. We'll click on that server, and once you click on that server, you will get the public IP of that server over here, right? So this is the IP you want to connect to. At the same time, I got a PEM file, remember? So this PEM file, to connect to my Ubuntu server, I usually connect it through my Putty software. So there's a software called Putty, using which you can connect to your remote servers on AWS or on any cloud provider. Now this Putty software can only accept PPK format of key pairs or of private keys, right? So first we have to convert a PEM file into PPK, and the way to do that is using Putty generator, right? So we'll launch the Putty gen software, and we'll click on load, and then we will go to the place where you have stored your PEM file, which is here, right? So let's convert this file to PPK. So for that you will click on save private key, and you will name it as say Hemant_2 and hit save. Alright, so you have the PPK ready with you now. Now all you have to do is open the Putty software. Now over here you have to punch in the IP address. So this is the IP address of your server. Let's punch in the IP address over here. And to attach your PPK file, you have to go into SSH and click on authentication, and then click on browse, and then you'll be prompted with the screen. Just go to your PPK file and you should be fine. This is my PPK file. I'll click on open, again click on open, and then I'll get this terminal. Just click on yes, and it'll ask you the login name. So by default, any server that you create on AWS, if it's an Ubuntu server, the login name for that server would be Ubuntu. So let us enter that and hit enter. Alright, so if everything goes well, if it authenticates your key file, you'll be able to get into your server. Right, so you have successfully connected to your Ubuntu server. Now you can install any kind of softwares on it. You can install the LAMP stack or the Apache web server to host a website, and once you install the softwares, you just simply have to go to this IP address and it will start serving website for you. Right, so this is the way you connect to your AWS instance, and this is congratulations on your first server on AWS. Alright, so let me close this session. Let's go to our Azure now. So our Azure instance is also ready. Let's try to connect to it. All right, so this is the IP address of that instance. Let's copy the IP address and paste it in our putty. All right, so now in this case, guys, you don't have any PEM file or PPK file because we opted for the password option. All right, so let's click on open straight away, and this should give us the screen wherein we have to give the login name. So we created a username at the time of configuration, right? So that username was Edureka. We'll enter that, and then it'll ask us the password. So let's fit in the password that we chose at the time of configuring and hit enter. And if everything goes well, you can connect to your server. So you're now connected to your Ubuntu server on the Azure platform. So congratulations on that as well. Now these servers were infrastructure as a service, guys, right? Now remember I told you guys something about platform as a service. So let me show you how they are different. Right, so on AWS, if you talk about platform as a service, the service in AWS is known as Elastic Beanstalk. All right, so it's just an advanced version of EC2. So basically, it's EC2, but you don't have the access to the operating system. All right, so let me show you how you can launch an application in Elastic Beanstalk. So basically, you will click on Create New Application. All right, and you will give the application some name. So let's give the name as Edureka-2 and click on next. So then they'll ask you what type of server do you want. Do you want a worker environment or do you want a web server? So let's click on create web server. What kind of platform do you want? So as you can see, I'm just clicking everything. I'm not installing, I'm not typing any commands. So say I want a PHP server, I'll just select PHP and I'll hit next. Now it is asking me for what kind of application do I want to deploy in it. Let it be the sample application, and don't change any of the settings, just click next. And this is the URL that you will get where your website will be deployed. All right, everything is happening automatically. Let's click next and hit next again and hit next again. Don't put anything here because we have not discussed what these are. Hit next. And then the final page will come where you have to review everything. So after reviewing, after you are sure all your settings are right, you can hit launch, and this will launch your Elastic Beanstalk application with PHP installed on it. Right? So it takes some time to actually launch. It will take around 2-3 minutes to launch. So for the very reason, I have already launched an application so that I can show you how the Elastic Beanstalk console actually looks like. All right, so this is my application. All right, so I've already deployed, I've done the same settings that I did in Edureka-2. It's a PHP server. All right, and once that rolling goes away, you will get this green symbol, which means your server is ready. All right, so this is the console. You don't, as you can see, I cannot connect to this instance in any way. Right, it shows me that it has PHP installed on it, and it has this OS, which is Amazon Linux, and is running PHP 7.1, which is fine. But as you can see, there is no button over here which will let me connect to the system. All I have is this button which says upload and deploy. If I click on it, I'll be prompted with this screen where I can choose a file to upload. So this is basically where I will upload my website. And once I choose my website, I'll hit deploy, and that my website will automatically get deployed on Elastic Beanstalk. So once it gets deployed, once I get this green symbol, I will straight away go to this link, and this will take me to my website. So as you can see, this is the default page as of now, and it says congratulations, your AWS Elastic Beanstalk PHP application is now running. Right? So you are not installing any software, you're not installing Apache, you're not installing PHP, everything is happening automatically. So this is what platform as a service is, right? And if you were to have the similar kind of service in Azure, this service is known as app service in Azure. So if you were to search app service, you can get it over here. All right, so app services. So app services is similar to your Elastic Beanstalk. So in app services, there's a service called web app, which is used to deploy your website on AWS. But the difference between these two services from these two cloud providers is that over here in AWS, you can quickly click on upload and deploy and just upload your application. But in Azure, it is the other way around. You actually have to do it through Git, right? So you should know Git. You should have your code uploaded on Git, and from over there it pulls your website and deploys it on itself. I mean, the logic is same. You still are not getting the access to your operating system, but the method of uploading your website is different. All right, so this is the difference between the two platform as a service from these two cloud giants. All right, and with this, guys, I think we are done. We are done with the demo section. Before ending the session, let me tell you some of the things that you should know. If you are more keen to learn about the cloud, what you can do is you can choose a cloud provider that you want to learn first. I would suggest learn AWS first. So you can go to our YouTube channel and go through all the videos which are here. Right, so these are the videos that we has been uploaded by us. So you can go through all these videos. These videos will give you an idea about what AWS service is, right? And then you can pursue your journey on learning AWS. Similarly, we have a playlist on Microsoft Azure as well. You can go here and learn about Microsoft Azure, and if you guys are into reading, we also have a blogging section. So this is our AWS tutorial series. You can go through all the blogs and learn about all the services. And then we have the Azure blog series as well. You can go through the Azure blogs and learn about Microsoft Azure, right? So we as a company, Edureka, we also offer courses on cloud. So if you're keen to learn about learn cloud from us, you can go to our website. There is actually a program called Cloud Masters Program. So it's a combination of different cloud programs that we have. So first of all, you'll get to learn about fundamentals of cloud computing, then AWS, how to migrate your application on AWS, and then also DevOps. Right? We also have included our Azure course in these profiles, and these are given to you at a discounted rate. If you want to pursue single courses, that is just AWS or just Azure, you can also do that. You can go to our website and you'll find all the information related to it over there. Also, guys, we have our batches. We take batches on weekdays and on weekends, right? So if you want to, so we at Edureka, we understand that you as professionals, you don't have time, right? So we have flexible batch timings. You can choose a batch according to your time and go ahead. Right. Also, before ending the session, I would like to ask you guys to fill in a survey form about this live session that we just took. Right. Put in your details and submit it, and you can actually claim on an offer on the courses if you will buy from our website. Right. So we'll be delighted if you can fill the survey form. And with that, I think we'll wrap up the session. So thank you guys for attending today's session. I hope you learned something new today. So everything that we practiced today, I would recommend you guys to practice it once on your own as well, so that it becomes a better learning experience. All right. Till then, guys, see you next time. Have a good day ahead. Goodbye.
Hey guys, this is Vishal from Edureka and I welcome you all to this session. Today we are going to discuss top 10 reasons as to why AWS is an absolute must when it comes to learning it or using it to solve various business problems. So let us move further and take a look at these reasons one by one. Firstly, on this list we have security. Now there has always been a debate as in whether cloud services are secure or not. But AWS puts all these debates to rest. It provides you with security that meets the need of both small scale and large scale businesses. Plus, what it does is it provides you with complete security. That means your business owners can focus more on the business goals and don't have to worry about the security part. Now, there are compliance programs which help you set up your security better and also provide you with real-time security. That means you can have real-time insights on various vulnerabilities and security issues. Hence, if security is your concern, don't worry. AWS will definitely help you solve that. Next on this list, we have API. AWS provides you with various programming APIs. So if you're dealing with different programming modules, don't worry. AWS will take care of that as well. Plus, what it does is it helps you have a strong infrastructure programmatically. You can launch instances, you can take backups, and also focus on those AWS resources which would help you save time and money. Next, we have recovery. Now, I just discussed security, and yes, security is important, but that does not neglect this point, that is recovery. There are quite a few businesses in the market which cannot tolerate downtime. They have zero tolerance for it. In that case, having an application that serves your recovery purposes well is very important. Now, AWS provides you with a platform which is very versatile and also provides you with various recovery tools. Hence, recovery is also taken care of by AWS. Next on this list, we have customization. Now, what AWS does is it gives you various features to customize your applications and your infrastructure much better. Features like tagging or having user-defined tags lets you manage and monitor your resources much better. Plus, what it does is it gives you various options where you can track your costs, you can automate various things, and what this does is this helps you customize your business much better. Hence, if customization is your concern, definitely again AWS will help you solve all your problems. Now, since I've mentioned the word automation, let's go ahead and discuss this feature, which is automated scheduling. Now, AWS deals with various instances, and it is very important that you know when to start and stop these instances. This is where automatic scheduling comes into picture. Since you can schedule your instances much better, your services like EC2 and RDS can function very well because you do not have to worry about they being in a running state when there is a downtime or when the traffic is very low. Plus, there are quite a few third-party tools which help you eliminate coding or scripting completely. And these features go very well or very hand in hand with your scheduling features. Hence, these two features are very important when you talk about choosing a very strong cloud service provider, and AWS is definitely one. Now, next on this list, we have consistency and reliability. Now, AWS is an extremely useful platform when you talk about backups and disaster recovery. That is why it is highly reliable. Plus, what it does is it gives you negligible outage and very less downtime. Yes, there was a time once when the outage was very high, but it has dropped down a lot and there have been no outages whatsoever. Even the survey which was taken in recent times proved that it provides you better reliability or less or negligible outage compared to other service providers like Microsoft or even Google. Hence, if you talk about consistency and reliability, yes, AWS is again the best. Next, we have PaaS offerings. Now, AWS is highly scalable and it replicates this feature into various other services which AWS provides you with. Say, for example, we have a database, we have caching issues, we have data warehousing, transcoding, storage, and even application management. Now, all these things can be scaled up and down very easily and very efficiently using AWS. And AWS provides you with a PaaS platform that also helps you solve various other problems. What this does is this lets you set your business up very nicely or your application and infrastructure very nicely. Plus, this means that you are spending less on the setup and all those things, and you end up saving a lot of money. Now, third on this list, we have global architecture. Yes, AWS is a global leader when you talk about cloud services, and it has achieved that thanks to its wide reach. So how does AWS do that? Well, thanks to its global architecture again. Now, it has various locations in the world where it has set up its data centers, and those locations are called as regions. And these regions, they have various data centers or replications where they can hold their data basically. And these replications or these data centers are known as availability zones. In all, AWS has some around 16 regions and around 40 availability zones all across the world. So that means no matter in which corner of the world or which part of the world you are based in, you'll have some data center or region close to you which you can have access to, so that when you talk about getting your data or processing your data using all these services, you do not face any lagging or downtime issues whatsoever. Hence, global architecture does come into picture. And since AWS has such a great global architecture, all the more reasons why one should learn it or use it in their businesses. Next, we have another very important point, that is scalability. This is one feature on which AWS relies highly, because when you talk about cloud services, you are never sure as in how many compute capacities you need or what is your capacity for your computation, plus how much space you would be using. And these things, they vary on real-time basis. So estimating these things can always be an issue, and this is where AWS comes into picture. What it does is it provides you high scalability. You can go ahead and use those resources which you want, and if you want those in a more quantity, you can go ahead and you can scale it further. If you feel that there's downtime or the traffic would be low in these hours of the day, you can scale it down as well. That means it is highly flexible and it meets all your scalability needs basically. Last on this list, we have pricing. Now, this is a very important point. Money is important to everyone, and when you talk about businesses, if you can optimize your money, there's nothing better for you. What AWS does is it serves all your purposes. Think of yourself as a student or a person who wants to get started with AWS. You have something called as a free tier. What it does is it gives you access to all AWS resources and lets you use those freely for 1 year. Yes, there is certain data limit or limits on all these services, as in how much can you use these, but they would definitely serve your purpose when it comes to just learning those. For businesses, don't worry, you have a model called as pay as you go. What that means is you pay only for those resources and only for those hours during which you use these resources. Yes, AWS charges you on hourly basis and it charges you very less. That is the best part. Plus, there's also something else called as the more you use, the less you pay. Yes, the more resources you use, again, you'd end up paying very less. So this highly flexible pricing architecture of AWS again solves and meets a lot of needs of a lot of users. And I feel this is one of the very important reasons when you talk about using AWS and all those things. So this was the last point in today's discussion. I hope you all had something new to learn from this session, and I hope you're taking back something from this one. That's it from my end. I would be taking a leave now. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, my name is Vishal and I welcome you all to yet another session by Dureka. Today we are going to go ahead and talk about different roles and responsibilities of a cloud engineer. But before we do that, let's take a look at the offerings of this particular session. So first and foremost, I would be talking about who a cloud engineer is. Now there might be quite a few people who are completely new to this topic, so a little bit of intro would definitely help. Moving further, we would understand why should you go ahead and choose this particular domain, because yes, there has to be certain benefit out of it, right? Next, we would understand what are different cloud engineer roles and what are their responsibilities as well. Now, for people who attended my last session, now some of the pointers might seem a little repetitive, but that is not the case, guys. We would be getting into the details of these roles and would understand what are the exact responsibilities of these individuals. Having said that, let's not waste any time and get started with the first topic of discussion, that is, who is a cloud engineer? Well, to stick to the basic definition, as you can see, a textbook definition is here. It is nothing but you can think of a cloud engineer as an IT professional who is responsible for performing certain IT responsibilities. Those are related to cloud computing. Now, he or she mainly may be responsible for something like the designing part, maintenance, monitoring, and deployment. So if you are an IT professional, you might be wondering as in, okay, some of these things are something that we do in our real life as well. So how is this particular role different? Well, to be very honest or frank to you people, IT professionals are someone who do all these things on premise. Now, the only difference here is you would be doing all these things on cloud. Yes, you would be doing similar tasks. I mean, if you are involved in these kind of responsibilities, so you would be involved in similar responsibilities. But the major difference here is you'd be practicing all those things on cloud. And there are benefits of doing that on cloud. How? Because cloud provides you with various services. Yes, we have quite a few service providers in the market, or vendors in simple word. Now, these vendors basically what they do is they have created so many services. You can make use of those services and actually perform your task with a lot more ease. And how does an organization benefit out of it? Well, the fact that these services are made available to you at a cheaper rate or at a lesser prices, you can actually go ahead and utilize these services by spending lesser amount of money and actually saving a lot of time and effort, even if you take a look at it from an individual perspective. So that is where a cloud engineering role is little different. I mean, yes, you would be working on your similar roles probably, but the difference is there are certain nitty-gritties that you have to go ahead and adapt to, because cloud would let you do these things with ease. But yes, there would be a different way to do it as well. So understanding different cloud service providers, how they work, do play a key role. But yes, if you talk about a cloud engineer, he or she again is an IT professional, and more or less you would be related or would be performing these kind of roles that are here on the slide. Having said that, let's move further and try to understand why should you opt for this particular career. Now, first or a major reason is the pay scale. I mean, yes, many people switch job. Why? Because salary is a bigger concern. Now, if that is your concern, do not worry. Cloud would definitely help you here a lot. Because if you talk about an average salary, now take a look at any job forum or portal, you'd realize that an average salary is somewhere around $125,000 to somewhere around $180,000 for a cloud engineer. Now, that is a fairly high amount if you talk about, engineering roles. Even in India, it is fairly high. I mean, we have salaries in Indian rupees, and somewhere around 15 to 20 lakhs is what cloud engineers get if they have the right amount of experience and the skill set. So yes, if you do put in certain efforts, definitely your money issue or your pay scale issue would definitely be answered if you talk about cloud. And this is where cloud computing is actually getting started. I mean, as you move further, if you take a look at the trends in near future, you'd see that cloud computing is going to grow, and it's going to grow like anything. So yes, these pay scales might just grow further. Now, having talked about the trends, let's take a look at some of those as well. If you take a look at Gartner's report, you'd realize that there's going to be a 60% rise in cloud adoption. Yes, if you take a look at current market stat, it is somewhere around 30 to 40% if I'm not wrong. And I'm not that updated with the stats because they change very frequently. But the last time I checked, it was somewhere around 30 to 40%. And this is expected to grow by 60% even more. And if you actually calculate it, it's actually more than 60% of the total enterprise share that is there in the market, and which is going to be huge. And this stat is going to be achieved by somewhere around 2023 if I'm not wrong, and that is 5 years from now. So yes, in next 5 years you're going to see more cloud, and the reason for that is all the industries want to cash in. Why? Because cloud is affordable and they see that it is the way going forward, and that is why these stats, if most of the companies are going to adopt to cloud platforms, it would become a mandatory skill for people. And these days, analytics and cloud are two of the most sought after skills because companies have realized one thing: it has become a necessity for their employees to have these skills going forward, because companies would be needing these in various practices they perform in the companies. And that is why the rise and the need for this particular domain or this particular job role. And then finally, we have high market reach. Now, what do I mean by this? As I've already mentioned, everybody wants to cash into this particular domain. Why is that? The thing is, cloud computing makes any kind of IT work very easy. Not just IT work, it supports any kind of business, because whether you're interested in marketing, whether you're interested in probably branding something or creating IT services, basically everything is taken care by using cloud. Whether you want to develop games, you want to do analytics, you want to maybe create artificial intelligence devices or applications, even that is possible by using cloud. So yes, no matter what kind of domain it is, probably it would be impacted by cloud computing in near future. And that is why I say high market reach. So these are some of the reasons why you can opt for a career in this particular domain. Now, as I've already mentioned, your salary is covered here, the market reach is covered, and the stats to prove that cloud has a bright future in near times. Having said that, let's move further now and try to understand some of the roles and responsibilities of a cloud engineer. So guys, if you've attended my previous session, you'd know that I've talked about quite a few roles, or I've given you quite a few roles in general. I haven't spoken about those in detail, but I had given you quite a few roles. Like, even if you are interested in something like SEO, marketing, branding, PR, game development, application development, whether you're into networking or whatever it is, cloud has all kinds of roles for you. But if you talk about utilizing cloud computing or using different cloud vendors for a particular job role, that is a cloud engineer, what these cloud service providers have done is they've classified the roles into three major categories. Now, these are fairly technical roles, guys. Yes, cloud computing does support marketing and all those kind of roles, but you can actually go ahead and use those tools and make use of cloud computing to do that. But if you want to get into the technical aspect, you would have to focus on these particular roles. Let's take a look at those one by one. So first and foremost, you have a cloud architect, then you have a cloud developer, and you have someone called as sysops or system operations administrator. So guys, we would be focusing on these key roles and we would be covering all the facets like what are the exact responsibilities of these individuals and what are the skill sets that you need to pick up if you want to become one. So let's start with the first one, that is the cloud architect. So who exactly is a cloud architect and what does he or she do? Well, again, to go with the definition, these are the people who are responsible for creating blueprints of your application designs. So they need to have technical knowledge as well as the viewpoint where they can actually go ahead and design applications. Now, to be very specific, or not to be very specific, rather to be very simple, I would say that these are the people who chalk out a plan or they design a plan, as in this is how the application should be built and this is how it should look, just like the normal architects. But these people are actually going ahead and building your software applications. So that is the major difference. So yeah, that is what these people are, basically the ones who actually go ahead and design. So what are their responsibilities? Are they only limited to designing a particular application? And if that is the case, why do they need technical skills or all those things? Well, to keep it simple, these are the people who would be designing the application. So they need to understand, as in, okay, I need these many servers, this much space, and all these kind of resources. So that is why they need to have that technical expertise as well. They should know what programming languages should be used, what approach should be used, how much time would developers need to build this kind of an application or architecture. And they also have to be in line with the developers as well as the admins, because their job is not limited to just designing this application, but they actually stay involved in this particular role while the application gets deployed as well. So again, if you talk about a cloud architect, these are the ones who actually form the blueprint and help the developers and the admin to bring that blueprint to life. Let's take a look at some of the responsibilities of these individuals. So when you talk about a cloud architect, as you can see, they're responsible for designing and deploying dynamically scalable applications. These applications have to be available, fault tolerant, and reliable as well. Now, these are some of the aspects which are core to designing and application development. I won't be getting into the details of terms like what are scalable, available, or fault tolerant devices. But in simple words, those applications once built, they should actually go ahead and survive greater faults, or they should be able to take care of all the aspects of a particular application. That is what they mean by these terms. Again, they should be able to select an appropriate cloud service provider. Now, this is very important, guys. Again, to give you an example, suppose if a cloud architect is building a particular application, he or she should understand what is their existing technology they want to work on, or what is their existing plan on which they actually want to go ahead and build their architecture. Are they any technology dependent? Say for example, if you have a particular need where you want to build applications using maybe .NET framework, in that case choosing Microsoft Azure would be a good option because they have all the resources made available. So again, depending upon the need, an engineer should be able to understand what is the exact service provider or resources they want to use. Again, they should have complete knowledge about applications. If they do, they would know what are the applications, how do they work, and if you wish to migrate from a particular architecture to cloud or maybe to some other service provider, how do you do it? And would it be feasible to do that? That is where the technical knowledge comes into picture again. The other responsibilities are designing and deploying enterprise-wide scalable operations on cloud platforms. Yes. So their aim is to design and deploy the applications. Now, when I say design, build new applications, or if you already have an existing architecture which you want to move to cloud, either redesign it or see how can it be actually moved to cloud. And they should be aware about the cost factor as well, as in they should know. This is where the knowledge again comes into picture, because this is where they should know, as in these are the services that would make my budget look better and I would be able to maximize or make use of the resources that I have to the best possible way and yet spend very less money. So yeah, these are some of the responsibilities of a cloud engineer. So what are the skills a cloud engineer should have? First and foremost, he or she should have vision to actually go ahead and understand what the company needs and what are the resources he or she should actually incorporate in that particular blueprint. They should have a complete understanding of the resources that are available, like the number of people who are going to work on the project, the time to delivery, and all those things. Apart from that, they should have good people skill because they are required to communicate with a lot of teams when these blueprints actually come to action. And they should have a very good understanding of different cloud service providers and also have technical know-how about the applications they want to build. Not to the core, but they should have an understanding of how do these things work. So these are some of the skills they should have, and the responsibilities we've actually already discussed those. So let's move further and try to understand the next role. Next comes in a cloud developer. Now, when you talk about cloud developers, these are the people who actually bring the blueprints to life. Now, we've talked about what cloud architects do. They give you a blueprint or a design. And what developers do is they actually go ahead and help you build these applications, help them deal with various issues that are there with these applications. They also help the monitoring team with debugging certain issues, which the monitoring team cannot do. So these are the people who actually bring these applications to life. They develop it, they use different programming languages using which these applications can be built. So what are the responsibilities of these individuals, or what are the skills that these individuals need to have? First and foremost, they need to have an understanding of at least one high-level programming language. What does this do? One, it gives them an approach where they know how programming languages work and how to use them. So understanding of at least one language is very important. If you have multiple programming languages at your disposal, even better. They should have skills for developing, deploying, and debugging applications. Yes. So when you talk about deploying or developing cloud applications, it is not very different from normal software application development, but you have to be familiar with certain protocols that are done on cloud, and that is where this knowledge varies. Skills with API, CLI, SDKs for writing applications. You would be dealing with a lot of integrations. You would be dealing with various command line interfaces, not various, command line interfaces, where you would be actually going ahead and putting in codes. You'd have to work with Linux and all those things. So that is where you should have an understanding of software development toolkits, and you also need to have an understanding of how different APIs work. Lifecycle management is something that you should know. Yes, when you talk about development on cloud, it's no different from software development. You need to have an understanding of how the complete application is going to function and all those things. Going further, you should have an ability to use continuous integration and pipelines for deployment. Now, this again is a part where you have a particular software which needs continuous updation, because when you use any kind of software, you know that there would be a certain pop-up every now and then where you see that there is a new version that has been released and your computer asks, do you want to update to it? Why does this happen? Because developers constantly work on making a software better. And it is no different on cloud platforms as well. You'd be having continuous updates, and those would get integrated with your existing software, and you should be able to deploy the new version as quickly as possible. Time to deployment again is very important, and this is where the efficiency of developers comes into picture. What are the other skills? Knowledge of key features of cloud service providers. Yes, if you are using a particular platform, you should know how it works and what are the requirements or upgrades that you need to make in your skill set as well. Ability to implement code where you have to ensure security. Yes, cloud platforms do take care of security, and the level has increased a lot in recent times. So if you're dealing with data, you need to be able to ensure that these platforms are highly secure. Again, writing codes and ability to debug the codes that are there. And again, writing codes for serverless applications. Yes, guys, when you talk about cloud platforms, they ensure serverless environment where probably you'd not have to worry about servers and all those things. You'd be dealing with virtual machines, and not virtual machines exactly, but you'd be dealing with compute services where you can actually go ahead and kind of spin up certain machines which you can use, different operating systems and all those things, where coding again becomes very easy. So that is a benefit. But again, understanding that infrastructure or those domains or services becomes important. Containers. Now, I won't be getting into the details of what containers are, but those are shaping the technological world again. And having an understanding of containers becomes very important, because Kubernetes, Docker, these things are making news when you talk about any platform, even on cloud platforms. Now, DevOps kind of merges very well with AWS. And then if you have knowledge of containers like Kubernetes or Docker, you would be one very bright cloud engineer is what I can say. So yeah, this is what a developer, or these are some of the responsibilities that a developer should possess. Moving further, let's try to understand the third role, which again is very important, sysops administrator. Now guys, we've designed an application and our developers have built it. So we need somebody to take care of it after that, right? I mean, what happens to an application? It has to be maintained as well, not just the application, the complete infrastructure that you're dealing with. I've been quoting application for this long, but if you talk about these individuals, they're responsible for building the complete architecture. So yes, it also needs to be maintained as well. And who does it? Your sysops admin. As you can see, they have two primary responsibilities. One is to configure cloud management services and monitor and manage those services. Now, for people who have worked as admin, they would know that ITSM is very important. I'm talking about IT service management practices, where you actually go ahead and manage applications. You know how to monitor them and what are their responsibilities, how problems are dealt with, how they are resolved, and all those things. I mean, you need to have understanding of these minute details, and this is where a cloud admin comes into picture. So what are some of their responsibilities? Now, guys, again, I need to tell you one thing. All these roles, they're kind of interlinked. So you cannot, if you ask me, you might at times like question as in, okay, these roles seem very similar. Yes, they are similar. Yes, they're very different as well, but there are certain aspects which are very common to all these roles. So yes, there would be certain repetitive pointers where even as a developer, as an admin, or as an architect, you would be expected to perform those responsibilities. But apart from that, you have your specialized responsibilities which you need to take care of. So if you talk about a sysops admin, they should have experience as an administrator. As I've already told you, you need to have an understanding of how to operate on certain applications, how to perform ITSM or ITIL practices. They should be able to work with virtualization. Yes, your developers would do all the work, but again, something that works in the development environment should work in the production environment as well. And this is where admins come into picture. So having an understanding of how virtualization works would help them a lot. Experience in monitoring and auditing systems. Yes, you should be able to monitor your applications. This is your prime responsibility. Knowledge of networking. If you're talking about huge infrastructures, they need to be connected. You need to have proper access rights. And if you have certain customers, how would those access that application? Now, these are your admin people who take care of all these things. And once the application is built, they are responsible for troubleshooting all these issues as well. Translate architectural requirements. Yes, now these people also have a say in certain aspects, as in if there are certain issues, they actually go back to the development team or the architect team, as in, okay, these are the changes that you need to work on, and this is the approach you should take. Again, they should be able to implement and control the flow of data to and fro from a service provider. Yes, I've talked about the importance of different cloud service providers. So they need to understand as in how the data flow works. What are the changes that they need to make on their end for the application to work smoothly? They should be able to select an appropriate service provider. Yes, well, not so much. I mean, the main task or the main responsibility, it lies with the designing team, because once you have designed an architecture, yes, these people should be able to make changes when there are certain upgrades, because at times what happens is certain application is not able to bear a particular load. In that case, you need to scale higher, right? So in that case, these people come into picture because they need to understand as in, okay, this is the compute capacity we need, and we need to replace this particular instance with this one. So having an understanding of your compute data services or security requirements is essential. But as I've already mentioned, if these things are taken care during the design part, their workload becomes lesser. But yes, as I've already mentioned, these things don't come planned. So again, these people need to have knowledge about these things as well. They should have understanding of cost optimization, because if you are planning to scale it, use different instances, you might be charged differently. Networking concepts, again, very important. And finally, you should be able to deal with migrations and all those things. So yes, when you talk about a cloud admin, they are actually concerned with the operations part, or making sure that application is up and running, it's smooth, and they should be able to deal with the customers as well, not as customer representatives, but they should be able to adhere their problems as well, should be able to troubleshoot their queries as well. So yeah, these were some of the roles and responsibilities of cloud engineers. Let's just go ahead and visit a particular cloud service vendor and try to see what are their requirements. So guys, I've actually gone ahead and opened this Amazon website, AWS website rather. Now, if you talk about AWS, as I've already mentioned, if you come to this website and take a look, there are quite a few services that these people have to offer to you. So based on your company's need, you'd be using these services. So as an engineer, you should have expertise in handling these services. Again, based on your role, your requirement might vary, but you need to have an understanding of these. As I've already mentioned, you have services for analytics as well. You can take a look at it here. You have services which let you deal with real-time data, which actually let you perform analytics in n number of ways. So yes, there are services for everything that you do here, whether it's your business applications, or if you talk about development in particular, see there are quite a few development tools as well. So you need to have an understanding of these tools. And how can you do that? For that, you need to have an understanding of how these service providers work. So AWS is one, you have Azure, which is very popular. GCP is one which people are using very frequently these days. So I would suggest that you do go ahead and take a look at those websites as well. And again, one thing that you can do is you can actually go ahead and take a look at specific roles as well. Suppose I say AWS certified sysops admin, and if I look for it, I would be getting quite a few searches. And if I visit this particular page, all the roles and responsibilities are mentioned here. What is the relevant experience that you need to have and all those things. So I would suggest that you visit these websites as well and get an understanding of what role do you want exactly and how should you go ahead and prepare for that as well. Again, guys, if you're interested in structured approach and you want to take in certification training, probably this is a very good option. Edureka is a place where you have online courses which are made available to you. And if you take a look at this particular program, it is very specific to mastering cloud platforms. You have 10 plus courses here, 10 in particular, not 10 plus, and somewhere around 200 plus interactive learning, 200 plus hours that is, and this is their fees basically. So if you take a look at their fee structure, it varies when you talk about this particular website, and it is very real time because they have constant discounts that are made available to you. So if you register or you like stay in touch with the Edureka website or the YouTube channel, you probably might be a part of various contests, and you never know, you might get this course for free as well. So stay tuned as well. And if you wish to enroll, you can actually go ahead and take this course up, which is very nice. Apart from that, there are certain other pointers here. You have your testimonies, which you can take a look at. And then there is a complete course curriculum, which is made available to you, as in what is to be taught and all those things. Plus, you have certain elective courses, which you can take as self-paced courses, and you can learn those on your own. Say, for example, this one focuses more on AWS. So if you're interested in Microsoft Azure, you can take those as self-paced courses, and you can actually use or utilize those for your maximum usage as well. So guys, this was about today's session. I hope that you all had something nice and new to learn. As far as this particular session goes, guys, I would be resting it here and here. If you do have any queries, put those in the chat box below and we'll be more than happy to get back to you. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hi, good morning everyone, and welcome to the webinar on cloud computing. Today we'll discuss what is cloud computing, what are the different forms of cloud computing, in terms of the deployment models, in terms of, players which are available in the market, and most importantly, we'll cover where AWS stand in terms of cloud computing. So today's agenda is going to be discussion on cloud computing, followed by the service models and the deployment models of the cloud computing, and how cloud computing is advantageous in comparison to your traditional data center environment, and what are the typical use cases for cloud computing, especially in case if anyone wants to move their environment or move their workload onto the cloud, then what are the options available to them and how they can start moving the environment over to the cloud as well. And then we'll also discuss about some of the cloud providers which are prevalent in the market and what are the demands for AWS. And in case if anyone is interested in pursuing their career in cloud computing or in AWS, then what are the options available for them as far as learning is concerned. All right, so before cloud computing, so anyone who has worked in a data center environment or let's go 5, 7, 10 years back, typically what would the process be in case if you want to host a website, or in case if you want to host a web application, or if you want to host any application for that matter, then what was the typical process that we used to follow? Well, the typical process was, first of all, there was no clarity in terms of sizing of the infrastructure. So typically, let's say if you want to deploy a website or if you want to deploy an application, normally you will have to rely on developers' inputs in terms of what is the capacity of server, or what is the number of resources that you want to deploy that application. So those resources can be servers, those resources can be storage, those resources can be database licenses, and so on. And typically, developers are someone that, they may be good in developing solution, or they may be good in programming languages, but then usually do not have any idea about the infrastructure. So typically what would happen, they would guess a capacity based on, if somebody has deployed it somewhere else, then they will just take a guess that this particular application was running on XYZ environment and they're using this capacity, so let's go ahead and order this capacity. So that was the capacity sizing part. So mostly it was guesswork. Then let's say if we have decided that these are the resources that we want, then we need to buy a stack of servers. So let's say we need 2 servers, 3 servers, 5 servers, and so on. Who would be normally responsible for buying the servers? So there is another team who would be responsible for procuring those assets. So of course you need to take approvals. So you need to take approvals from your accounting department, you need to take approvals from your business unit heads and so on. Once the approvals are in place, then you need to place an order. So who will place an order? Again, there is another team, which is a procurement team, who will place that order. And there are again multiple vendors. You can purchase those servers from HP, from IBM, from Dell, and so on. Now, typically, as I said, your sizing, whoever does the sizing, they're always keeping their peak traffic in mind. So peak traffic, it's not important that your web application or your website will always be at peak demand, because normally your demand always fluctuates. So let's say that if you're an e-com store, normally, there is a trend that whenever there are some festivals around, you will receive more traffic during festive season when people buy more products, right? And rest of the days, your demand would be pretty much less. But in case if during the capacity sizing, during that guesswork, if you have guessed it wrong and suddenly you are seeing that you are hitting more traffic than you expected, then again you need to buy more servers, right? So all of this thing was a lot of headache, a lot of pain, and a lot of guesswork was involved in sizing your environment. And of course, how would you know that whether you are hitting the peak traffic or not, or whether you need more servers? So you need some kind of monitoring environment. So somebody was responsible for monitoring your servers. Somebody is responsible for maintenance of your servers. So typically you will have a maintenance agreement with your OEMs. So maintenance agreements with companies like IBM, HP, Dell, and so on, from where you have procured those servers. And then of course you also need to have in-house staff as well, who is responsible for updating the patches, updating the making sure that all your security updates are in place and so on. So as you can see that before cloud computing, there was a lot of hassle, and typically the process of deciding to buy a server to the point when the server is actually ready for the developers to develop an application or deploy an application or deploy a website, the typical period was around 4 to 6 weeks, and at times it may be more depending upon the company that you're working in, depending upon the approval processes in place, and depending upon how quickly that servers are available with your OEM or not, or your resellers or not, and whether those servers are available directly in the warehouse or they are getting it directly from the OEM. So typical 4 to 6 weeks is a standard time that we used to take before buying a server, or before the server is getting ready for your deployments. Now, of course, there are a lot of disadvantages. The setup was very expensive, because we have said that there was a lot of guesswork involved in the capacity sizing of your environment or capacity sizing of your servers. So one scenario was that you have guessed it wrong and you are hitting a peak usage, and your current server capacity is you're not able to support your peak usage. In that case, you need to buy more servers. Another scenario can be that you have oversized your environment, you have over provisioned your environment, you have bought more servers or more storage than was actually required, and now you are not hitting that much of usage, and then you're lying with these servers sitting idle at your environment, but you are not able to make any use of it. And after 3, 4, 5 years, normally each and every infrastructure hardware that we procure, they follow some kind of life cycle. So typically in IT environment, 4 to 5 years is a refresh cycle associated with all those environment, whether you talk about storage, you talk about network, you talk about servers and so on. So if you are not able to make use of the infrastructure that you have procured, after 3 to 4 years, you will anyway have that infrastructure will be depreciated, and you again have to procure a new one. So of course this setup is very, very expensive. In case of troubleshooting, your troubleshooting problems can be a very tedious task and may conflict with your business goals. So as I said that there are multiple parties involved. So there is a monitoring environment, again depending upon whether you want to invest on the monitoring tools and you want to keep that monitoring environment in-house, or you want to outsource it to some third party. So there are again multiple providers or multiple companies available in the market who provide monitoring and management services for your infrastructure. But of course, that's again a costly affair. And then depending upon what your business goals are, whether you really want to invest in the skill set for monitoring and managing all those environment in-house, or whether you want to focus on your core business and you want to outsource all this monitoring and management environment to the third party or not. And even if you outsource it to a third party, in case of any problems with your website, in case of any problems with your application, you have multiple parties to talk to before you can find out whether whether the problem is with your code, whether the problem is with your network, with your storage, with your internet service provider, or whether the problem is with the hardware as well. Troubleshooting is quite a pain in that kind of environment. Since I said that most of the time, any application, any website, your traffic is always varying. So there is no fixed demand as far as your application or as your website is concerned. Normally they go from various phases. So there may be time that there is no traffic or there is very less traffic on which is hitting your website or your application. And there may be time, which we normally call it as peak usage, that the demand surges and you really need to make sure when you're hitting the peak period, you have enough infrastructure in place to take over your load, because any customer lost due to non-availability of your servers is a business lost. So your servers will be idle most of the time if you have over-provisioned it, but at the same time we need to make sure that we have enough capacity in place, especially during peak hours. So how do we fix this? Well, the answer to all your problem is cloud computing. So what do we do after we have cloud computing in place? First of all, rather than putting every infrastructure or every server or every storage, networking, etc. in our own environment, we put all our data on cloud servers, and there is no more buying of expensive servers, because most of the cloud computing, irrespective of the provider that you choose, irrespective whether you're going for a public or a private and so on, most of the cloud computing providers, they offer you OpEx model. So rather than putting upfront costs associated with procuring your hardware, you can normally break it down into your operational expenses. So if we talk about the public cloud providers, most of the public cloud providers, the pricing for their servers is normally in the range of per hour, or some of the providers also provide per minute billing as well. But let's make it a baseline that each and every public cloud provider will bill you your server usage based on per hour per month. Okay, so there is no more expensive hardware or expensive servers to buy. There is no upfront cost associated with it, and you can terminate those servers as the moment you want it. So for example, again, even if there is a guesswork involved, so you will provision those servers. You will monitor the usage of those servers. In case if you are making use of the servers that you have provisioned, you can continue to use it. If you are not making use of those servers, if those servers are sitting idle, you can terminate those server instances, and without having to worry about any residual cost in that case, because you're only paying for the capacity that you're using. So if you have only used it for 4 hours, you will pay for 4 hours. If you're using for 24 hours, you'll pay for 24 hours, and so on. There is no more money that is going to get stuck into your infrastructure. It also offers scalability. So again, even if there is a guesswork, you have under provisioned your hardware for some reason, and suddenly if you're hitting your peak usage and you want to deploy more servers, you can deploy it instantaneously. Because your server capacity will vary according to the traffic, you can increase or decrease your server capacity based on your traffic needs. So it's quite a cool feature. So there is a normally feature called auto scaling, which is available in, for example, AWS Cloud. So you can actually monitor your live usage on the servers. You can configure your auto scaling so that whenever your usage is hitting a certain threshold, it will trigger an event, and based on that event, you can add, or you can, for that matter, reduce the capacity of your servers as well. So we are not just talking about scalability in terms of scaling up, you can even scale down. So for example, if you are provisioning 5 server instances and most of your server instances are sitting idle, so you can monitor your environment, and then you can decide that just to give you an example, if your CPU utilization of your servers is less than 25%, then you can terminate one instance and so on. Or for that matter, if your CPU utilization is hitting more than 80% constant for consecutive period of, let's say, I don't know, 24 hours period, then you can decide to add one more instance as well. So those auto scaling events can really help you to automate the deployment of your environment based on your traffic needs. And in terms of management, in terms of monitoring, you don't need to invest in any environment for monitoring or for that matter for management of your servers, because most of the cloud providers, they offer you this compute capacity or the server capacity as a service. So they will monitor your servers, they will manage your servers. So you don't need to worry about any underlying infrastructure. You don't need to invest in any monitoring licenses or monitoring infrastructure to manage your environment. So what is cloud computing? So it is the use of remote servers on the internet to store, manage, and process your data rather than a local server or your personal computer. So traditionally, all the servers that you would deploy, so you would ideally deploy your servers locally in your own offices, in your own environment, or if you are a big enterprise customer, then typically you will have your own data centers to manage. So we have just talked about cost associated with servers, cost associated with storage, networking, and so on. There are facilities cost associated with it as well. So for example, if you want to deploy your servers in a data center, so you would need to pay for the facilities cost as well. So cost associated with leasing of the real estate where you want to deploy your servers, cost associated with your power, cooling, rack space, and so on, cabling, and so on. So there's lots and lots of other costs associated with keeping your environment in-house as well. But in terms of cloud computing, you can purchase those servers, or rather you can provision those servers, and you will only pay for the used capacity. And since all your servers are going to be deployed remotely, so there is no facilities cost associated with it as well. How you want to access those servers? You can access those servers from the internet, or in case if you are worried about the security part, you can also connect to your cloud environment using private connectivity as well. So for example, you can connect them using IPVPN, IPsec VPN, you can connect them using leaseline, you can connect them using MPLS, and so on as well. So what are the different service models which are available in cloud computing? So primarily there are three types of service models. So now most of the cloud providers are coming up with more and more versions of it. Okay, so we have a question from Hemant that in autoscaling, what metrics decide whether our instance is reaching threshold? So in terms of AWS, 4 different types of predefined metrics which are available for us. Those predefined metrics are, CPU usage, then you have, disk read and write, then you have network bytes in and out, and then there is also system checks involved. So these are the predefined or default metrics which are available to us. You can decide which particular metric you want to monitor and what threshold that you want to set. So for example, I gave you an example of monitoring your CPU utilization, because typically it is seen that in case if you are hitting your peak usage, your CPU utilization is the first metric which normally goes high, because your server is responsible for doing a lot of processing, and in that case your CPU cycles will be involved a lot. So you can set your threshold whether you want to add or delete more instances based on CPU utilization, or you want to add or delete instances based on your disk read and write, or you want to add or delete instances based on your network in and network out bytes as well. Or in case if any of your servers are failing the system health checks, then you can add or delete instances as well. So there are 4 predefined or default metrics available, but of course there are options to decide you can also create your custom metrics as well, but that's something that that's not part of this particular webinar. But yes, there are options to define custom metrics as well. All right, so let's move on. So in terms of service models, as I was saying, that there are 3 types of service models which are prevalent in the market. Of course, most of the providers are coming up with their own versions of this model. So we normally call them as X as a service, but let's focus our discussion on the prevalent ones. So there are 3 types of models. So one is infrastructure as a service, another one is platform as a service, and third one is software as a service. So let's have a look at each one of these. Okay, so infrastructure as a service, it normally provides your virtualized computing resources over the internet. So as I have said that you can choose the type of connectivity. So even though those infrastructure is available at the cloud hosting providers, and you can connect over internet, you can connect over VPN, you can connect over private connectivity as well. But primarily your infrastructure as a service model will provide you virtualized computing resources. You don't need to worry about underlying physical hardware or physical machines, and it will provide you the abstraction layer from the physical machine. So think of infrastructure as a service. So what is the typical infrastructure that you would have in your environment in your local data center? So you will have some servers, you will have some storage, you will have some kind of networking, you will have some kind of security gears as well. So rather than having all of these, boxes or all of these hardware devices on your own, you can put everything on cloud. Now, when you put everything on cloud, and if you want to use each of these components yourselves, typically have all these resources available to you, but you can pick and choose what are the resources that you are looking for. Of course, all those resources will be virtualized. There are no physical hardware boxes which will be dedicated to you in that case. So for example, you can pick and choose whether I want, one server instance, two server instance, or 10 server instance, and whether that server instance will be of a Windows server, will be a Linux server, will be a Unix server, will be an Ubuntu server, and so on. And whether you want the storage associated with it, whether you want to have a magnetic storage, or you want to have an SSD storage, or you want to have an object-based storage associated with it. And similarly, you can decide whether you want elastic load balancer or not, or whether you just want a normal servers and a virtualized firewall or not. So all the services are available to you, but you will have to pick and choose which services you want. So that is your infrastructure as a service. So example, so you will have multiple providers. So you have Microsoft. So the prevalent ones are AWS is of course on top of the Gartner report for infrastructure as a service model. Apart from AWS, Microsoft Azure is something which is really catching up. In fact, the year-on-year growth of Microsoft last year has been 300%, so it is catching up really fast. But of course, AWS continues to lead the infrastructure as a service model in Gartner report and I think AWS has been leading from last 4 or 5 years. Apart from AWS and Microsoft Azure, you also have Google Cloud, which is the recent entrant into this market. You have cloud providers like Rackspace and so on as well. The second service model, which is again prevalent in the market, is your platform as a service model. So even in this model as well, there is no control over the underlying architecture, including OS, storage, server, etc. So infrastructure as a service model, you had the liberty of choosing which server instance you are looking for, which operating system you're looking for, what is the storage capacity you want to attach to your servers. But in platform as a service, you do not get the control over the underlying architecture. So the architecture will be preset for you. For example, that architecture can be a Linux operating system, Apache web servers with a storage capacity of 100 GB and so on. So typically you can call them as runtime environment as well. So the platform as a service model is primarily dedicated for or targeted at developers community who want to, who do not want to spend their time on the infrastructure related issues or infrastructure related decisions. All they want is that I have a Java application and I want to deploy Java application. I have a Node.js application. I want to deploy the Node.js application. So platform as a service model will, give you option in terms of runtime environment. So you choose which particular runtime environment you're looking for. I'm looking for a Java runtime environment. Whatever a Java application would need in terms of underlying infrastructure, that will be pre-populated for you or pre-installed for you. You can just choose your runtime environment, you can upload your code, and your application will be deployed instantaneously. So it is primarily dedicated for developer community or targeted for developer community. In this model, your cloud provider gives the ability to customer to deploy your created application using programming languages, using tools, etc. that are provided by the cloud provider. Again, so if I talk about AWS, so there is a service which closely relates to your platform as a service model. The name of that service is Elastic Beanstalk. So in that particular environment, what you will do is, if you go to the Elastic Beanstalk console, all you have to do is select which application you want to deploy. So there are, I think, 6 applications in the runtime environment which are supported. So for example, there is a Node.js, there is a Java, there is PHP, there are Go, there is Docker, and so on. So you just select the runtime environment, upload the application code, and the moment you upload your application code and click on deploy, it will automatically deploy the underlying infrastructure in terms of the server instances, in terms of load balancer, in terms of your security groups, and so on. So you do not need to worry about any of the provisioning requirements for your application. The third service model is software as a service. So as the name implies, this will give you your software as a service. In this particular environment, your cloud providers will lease the application or the software, which will typically be owned by the cloud provider, but it will be provided as a service to the client. For example, Salesforce.com, they provide their CRM software on a cloud infrastructure to its clients. So for example, you can get a CRM application directly from the Salesforce, in fact, they also have their own cloud as well. So you can get the CRM application directly from Salesforce. In this particular environment, you do not get any liberty in terms of what is the platform they are using, what is the infrastructure they are using, or for that matter, whether you need any customization in your software or not, because the software will be deployed and will be provisioned as a standard environment, and it will be given to you as a service. Of course, in terms of charges, your charges will again be based on the usage capacity. But keep in mind that in this particular environment, the software that you're going to use, that software will always be owned by the cloud provider company. You cannot own the software. And also keep in mind the requirements for your data security or data retention as well, because any data which is associated with your software will normally be kept in the cloud. So keep in mind your data requirements as well when you choose your software as a service model. Other examples that I can give you is, so for example, I think we have Gmail for business. So you get your Gmail application for you, but what that application is using at the backend, you do not have any control of it. And you do not even get to customize your application as well, because every user who will opt for Gmail for business, they will get the same environment, will get the same look and feel of that software as well. So there are multiple options available for software as a service. So for example, Gmail for business, Skype for business, you have Salesforce, you also have Exchange as a service. So there are multiple options available for software as a service as well. Okay, so let's do a quick comparison of all the 3 service models that we have discussed, and the 4th one, of course, if you keep everything in your own environment, we normally call it as a package software. So in case if you want to deploy everything on your own, so you will be responsible for complete environment. So you will manage the networking, you will manage the storage, servers, virtualization, operating system, any middleware, runtime environment, any of your data, and any of your applications. So you will be able to monitor, manage, and deploy all these infrastructure components. Okay, question from Heyman, that the data which will be generated by the software, it is also owned by the company hosting the software. Well, data will always be owned by you. Of course, the software company or the software as a service provider cannot claim the data that is generated. Of course, the data will be owned by you. But what I'm trying to say is that keep in mind the data that you are going to generate using your software, that data will be stored in cloud service provider. Okay. So make sure that you are following your best practices based on the industry that you are working in, based on the data retention policies that you have. You need to talk to your cloud service provider and understand that what is your data retention policy. So for example, if you're using, let's say, Gmail for business, or if you're using Exchange as a service, that typically most of the companies have the policies in place which says that you need to keep your mails at least for 1 year or 2 year or 3 year and so on. So you also know that whenever you open your Exchange boxes, it does give you an option or error at times that says that you need to delete your old emails. So that's something that will be decided by your cloud service provider, that what is the data retention policy that they are using. So make sure that you talk to them and understand the data retention policy, that how long your data will be valid for and when will be your historical data be deleted. Okay. And secondly, even if you want to, let's say today you have used Exchange as a service and you're getting that Exchange as a service from one provider, you want to move to another provider. So of course you do not want to lose all your data to the previous provider. So you can copy your existing data and move out of one provider and copy it to the another provider as well. All right. So in terms of package software, so you are deploying everything on your own. You are deploying everything within your environment. So you are responsible for managing everything right from top to bottom. So you are the owner of your application. You are the owner of your data. You are the owner of your runtime environment or operating system, networking, storage, server, and everything as well. In terms of infrastructure as a service, the cloud provider will give you the underlying networking, the underlying servers, underlying storage, underlying virtualization. But whatever operating system that you want to run on top of your infrastructure as a service model, whatever middleware you want to run on top of your infrastructure as a service, whatever runtime environment you want to run, whatever data you want to run, and whatever application you want to run, all those things will be managed by the application owner or by yourself or by the customer. Cloud provider is only responsible for the underlying physical infrastructure or up till the virtualization layer. So once you have chosen that you want to have, let's say, a Linux virtual machine, so of course there is some networking associated with it, that how that virtual machine is going to connect to the internet, how it's going to connect to the firewall, to the load balancers, etc. All these things is something which is managed by the cloud service provider. All you need to do is you just choose the machine and then you deploy your runtime environment. Maybe you want to deploy Apache, when you want to deploy PHP, etc. And whichever application you want to deploy, you can provision your application on top of it. In terms of platform as a service, so we get a step ahead. So apart from your networking, storage, server, virtualization, even the operating system, the middleware or the runtime environment is something which is preset or pre-populated by platform as a service. You do not get to choose which operating system you are looking for. You do not get to choose the runtime environment variables that you want to set. So if you want to deploy the example that I gave, a Java application, so you will just upload your data. So data refers to the application code, and then you will deploy your application. Now, whoever is using your application, they will generate that data, but you will be responsible for managing that data as well as the application, whereas the cloud provider will be responsible for managing everything in terms of physical infrastructure, in terms of your virtualization, operating system, and runtime environment. If we go for software as a service, so apart from the runtime environment, now in this case even the application is something which is managed by the vendor. So vendor will deploy the application. The vendor here, the cloud service provider, will deploy the application. Even the data will be stored in the cloud service provider model. So even the management of data is something which will be done by the cloud service provider. Okay, question from Heyman, that is AWS just infrastructure as a service, or is it PaaS or SaaS? Well, in terms of cloud computing, normally your AWS is always falls under infrastructure as a service. If we talk about AWS in general, but there are some services which falls under platform as a service model. So I gave you an example of Elastic Beanstalk. Because Elastic Beanstalk gives you the runtime environment, and you just have to deploy the application code on that environment. So that particular service falls under platform as a service model. If we talk about software as a service, there are multiple vendors or there are multiple companies who are using AWS infrastructure environment to provide software as a service model as well. So let's say that you have deployed some application, okay, and in that you have created an application and you are deploying that application on AWS environment. From the AWS cloud environment itself, you are offering your application as a service to your end client, right? So you can create software as a service model or software as a service environment on AWS as well. If I talk about the Gartner report, where they normally rate the different cloud service provider, so AWS does fall under infrastructure as a service model. In terms of software as a service model, typically Salesforce is what is typically called software as a service model. All right. Okay, let's move on. So this is the service model. So again, just to recap, there are three types of service models which are prevalent in the market. They are infrastructure as a service, platform as a service, and software as a service. So let's take a look at the deployment models. So there are three types of deployment models which are available. So deployment model refers to how you want to deploy your environment or how you want to deploy your applications. So the deployment model is public cloud, private cloud, and hybrid cloud. Let's discuss a little bit more on public versus private versus hybrid cloud. So again, you will use the same service model. So your service model can be infrastructure, can be platform, can be software as a service. Now, where do you want to deploy your environment? You can deploy your environment in a public cloud. So public cloud is something which is available over the internet. So public cloud like AWS, Microsoft Azure, Google, Rackspace, all of this falls under public cloud category. Private cloud is when some of the companies are using their own data center to host their infrastructure. So for example, if you are an enterprise company and you want to run all your infrastructure on your own and you will have your own data centers, then that falls under private cloud. So there are multiple companies. There are companies like IBM, HP, Dell, Rackspace, VMware. There are companies like AT&T, CSC, even for that matter, companies like HCL, Wipro. They all have their own data centers as well. And they normally, typically falls under the hosting companies, I will say. So any of the hosting companies which are hosting your environment or your application or your infrastructure within their own private data centers, that falls under private cloud. Now, whether you want to use private cloud or whether you want to use public cloud is totally your decision, because as the name implies, your public cloud is something which is available and which can be accessed from the internet. Of course, there are some security policies in place and you can make use of that security policies as well. But in case if you are very, very cynical about security and you don't want to host your business critical applications on public cloud, then you can choose to deploy your business critical application on private cloud as well. Whether that private cloud is something which is managed by yourself, which means you have your own data center and deploy everything on your own, or whether you want to outsource that private cloud environment to some third parties. So again, companies like HP, IBM, CSC, companies like HCL, Wipro, TCS, all of these companies, they have their own data centers as well. So you can use the data centers owned by these companies to host your infrastructure as well. That will also fall under private cloud environment. But the most, of course, in terms of pricing, your private cloud environment will be more expensive compared to your public cloud environment. But in terms of security, your private cloud environment probably will give you more security features compared to public cloud. And your private cloud environment will give you more flexibility in terms of where exactly you want to deploy your infrastructure, because you can pick and choose. Let's say that you're working in a US region or you're working in a European region. So you can pick and choose from the multiple private cloud providers which are available in the market to decide where exactly their data center is located and where exactly you want to host your infrastructure. Whereas in terms of public cloud providers, the public cloud providers have limited number of data centers available to them, and you do not have an option to say that if they have a data center in London, you cannot say that I don't want to deploy in London, I only want to deploy in, let's say, XYZ location where they do not have a physical presence as of now. Whereas in terms of private cloud providers, you can say that I want to choose a company who have a private data center in this particular location. So there may be multiple companies, but some of you can pick and choose which company you want to go for, which have a data center in the location of your choice as well. But as I said, your public cloud providers are cheaper than your private cloud providers, and most of the companies, rather, in fact, they are moving to public cloud these days. But you're worried about the security part, so what you can do is you can start with non-critical application or non-critical environment. You can put non-critical environment on public cloud, and you can continue to run your business critical applications or business critical environment on private cloud. So if you are making use of both private cloud as well as public cloud, then you are following the deployment model of a hybrid cloud, because you are making use of both the models. Now again, as I said, private cloud does not mean that you are keeping everything on a third-party data center. You can also have everything on your own data centers as well. Even if you're keeping your business applications in your own data center and you're moving some of the stuff on public cloud, you're still following the hybrid deployment model. Any companies, as an architect, as a cloud architect, if there is any company who wants to move to public cloud, you will always say that they will follow the hybrid cloud model initially. So typically they will always start with deploying the development, and they will always start with dev and test environment. So they will want to move their dev and test environment onto the public cloud. And once they get their feet wet, once they understand the public cloud environment, once they gain some kind of they become more comfortable with the public cloud providers, and they see the benefits of getting associated with a public cloud provider in terms of pricing and so on. Then slowly and gradually they start moving their business critical applications on public cloud as well. Okay, so Hemant is saying that my own data center will also be private cloud, and if that is the case, won't my data be more secure on AWS because they have better security practices in place? Well, as I said, that you can host your applications onto your own data center as well, and you can probably deploy some of the development and test environment on AWS or any third-party public cloud provider as well. In that case as well, you will be following the model of hybrid cloud. Yes, if you keep everything onto your own private cloud, your data will be more private or more secure, because you know your data, you know what type of security measures you want to take. You are in complete control of your data. But at the same time, that's absolutely right that companies like AWS, since they are a public cloud provider and they are hosting big MNCs, they are in fact hosting some of the biggest names in the financial industry as well. So their security practices will be probably more mature than you as a customer. But then I don't know you as a customer, maybe you have more mature security practices as well. Security in terms of public cloud versus private cloud, it is more of a perception, I will say, because most of the customers, they have a perception that if I move my environment onto the public cloud environment, I'm exposing my applications for more security risks. Whereas if I keep everything in my private environment, my applications or my data is more secure. So it is more of a perception rather than reality. The reality is, yes, since the public cloud providers are hosting, numerous, I don't know, I mean, thousands or millions of applications and thousands of customers, so their security practices will be more mature. But at the same time, if you move your environment to the public cloud, the security is not something which is only the responsibility of the public cloud provider. You as a customer is equally responsible for making sure that you are keeping your environment secure. So for example, there are all the features and all the security policies in place, but you need to make use of those policies as well. So just to give you an example, that when you launch a server instance in the cloud, you need to select the security group. So security group is nothing but it is a virtual firewall which is given to you. Now, if you keep that virtual firewall open to the entire world, so if you are accessing all traffic from the internet, then of course you are putting your application or your server at risk. And if that server is getting hacked by someone, you cannot blame that my server got hacked because it was on public cloud, because AWS has given you the feature of security group, but you need to deploy that security group. You need to select which ports I want to open. If you are gonna keep everything open to the entire world, then of course you are putting yourself at risk. So security, normally we say that the security is something which is a shared responsibility model between the public cloud provider as well as the customer as well. And this is where it is very important to understand that even if you put your environment onto public cloud, you are not secure by just putting it on AWS and saying that it is the biggest cloud provider which is available, and probably it will be more secure because you are equally responsible for it. Okay. All right. So what are the advantages of cloud computing? The first is there is no upfront cost. Anyone would move to the cloud, whether it is a private cloud or a public cloud or a hybrid cloud. Anyone would only want to move to the cloud environment because it gives them a lot of saving in terms of their ITO budget, because there is no upfront cost associated with it. So you are directly taking your capex, out of your IT budget, and you're converting your capex into an opex. It gives you better security. So again, we have discussed that most of the public cloud providers, since they are hosting so many companies, so many infrastructure, so their security practices are more mature than you or any of the other private cloud providers as well. There is no maintenance associated with your infrastructure. So all your infrastructure is maintenance free because it is something which will be maintained by the cloud provider. Anywhere access, so you can access your environment from anywhere. So let's say that you're running your test and dev environment in the cloud. So rather than accessing it only from the company, you can also access it from home or from any location as well. Fast implementation. So we have already discussed the typical, life cycle of from ordering a server to provisioning of server is normally it takes 4 to 6 weeks or sometimes 8 weeks as well. Whereas in terms of cloud, the moment you have got your approvals to deploy the servers, you can deploy those servers in a matter of minutes rather than 6 to 8 weeks, because there is no provisioning, there is no procurement that needs to be done, there is no capacity planning that needs to be done. All you need to do is get an approval from your business unit that I want to launch 2, 3, 4, or for that matter 1,000 servers, and then you can just click on your AWS console and launch those servers. You do not need to worry about whether that infrastructure is available or not, whether that capacity is available or not, or whether who will deploy those servers in terms of racking, stacking, and so on, because everything is done for you by AWS. It also gives you instant scalability. So as I have discussed, the auto scaling part. So rather than guessing your application needs, rather than guessing the infrastructure capacity that you would need, you can start with the minimum server capacity that you're looking for and start monitoring your environment. The moment your environment is hitting your period or getting more traffic, it will automatically scale up, or it can automatically scale down as well. So it gives you instant scalability without any user intervention as well. So what are the use cases? So there's a company called Twilio which is using cloud computing platform which helps developers to communicate between their application using messaging and voice communication APIs. So Twilio is something which is used by Airbnb, Netflix, Uber, and many more other companies as well. Twilio has deployed their environment onto the cloud. So they have moved from their environment to the cloud, which has resulted in reduced latency and easy scalability. So Twilio is kind of a messaging service which you can use to send text messages, voice communication, and so on. So when it was not on the cloud, scalability was something which was very, very difficult to achieve. So of course, they faced a lot of stress in terms of scaling the environment up as and when their application got more popular. And of course, it was very expensive to keep on buying more hardware and provisioning those hardware to manage your application, because they want to manage their application, not the infrastructure. So by moving on to the cloud, they have reduced latency, and now scalability is very, very easy to achieve as well. Some of the fun facts. So Twilio, as I said, is using AWS added backend. It was started in 2008, and it is all in on AWS to power its cloud scale communication apps globally. It uses AWS to deploy an average of 30 features in a day and still maintain 99.999% of availability. So imagine, deploying those 30 features in a single day on your own private environment or private servers. Do you think it would be possible for them to test these many features in a single day? Because in that case, you would definitely need to have, first of all, a lot of infrastructure capacity, and secondly, your skill set in terms of system resources at your disposal as well, so that you can, in case if any of the issues is happening at the infrastructure layer, those infrastructure layer issues can also be handled very quickly. But rather than focusing on increasing their IT budget by hiring more people and buying more servers, they have moved on to AWS. They do not need to worry about the underlying physical infrastructure. They just focus on their application, and they know that the infrastructure will always be available for them. So they have been able to test on an average, deploy and test 30 features in a single day, and while still maintaining 5 nines of availability for their application. All right, so I think we are coming at the tail end of our course or our webinar. Now, if you are convinced by now that I want to start my career, or I want to probably enter into cloud computing, and you're still confused on how do you want to get started with it, especially on AWS, So first of all, you need to understand that there are different cloud providers available in the market. So some of them I've already named. So you have Azure, as you have AWS and Azure leading that particular market. Then you have Google Cloud, which has recently come up, or not recently, but probably it is catching up a lot. Then you have Rackspace, DigitalOcean. Then you have IBM Cloud, VMware, Terramark, Joint, and this is just a subset of the cloud computing market which is there. If you just search on Google what are the different cloud providers, I'm sure you will see that there are tons and tons of cloud providers which are available. So for example, I can name in the few. So apart from IBM Cloud, you have cloud from Salesforce. You also have cloud from HP. You have cloud from Dell. You have cloud from telecom companies like AT&T, Verizon. You have cloud from companies like CSC, HCL, Wipro, TCS. You have cloud providers from Box as well. So there are multiple cloud providers which are available in the market. So if you are entering into this particular segment, you are sure to get opportunities in different cloud providers as well. A quick comparison on AWS versus Azure. So Azure, as I said, that is something which is catching up really fast, but again, still AWS is a leader in the recently issued Gartner report as well, and it is leading by quite some margin. Azure, in terms of server capacity, it is again very less compared to the server capacity which have been deployed in AWS. In fact, your AWS has 6 times the server capacity of all the cloud providers combined together. So including your Azure, Google, and so on. The number of servers which are deployed on AWS is approximately 6 times of all the servers deployed in all the cloud providers. In terms of market share, Azure is at 11% of global market share, whereas AWS leads the pack with 31% market share. Again, 31% of the total market share of the cloud computing market. So imagine there are thousands and thousands of cloud providers who are competing in this one, but AWS is currently owning 31% of the total market share of cloud computing. AWS was started in 2006, whereas Azure came into picture on 2010. In terms of servers, AWS charges you for per hour usage, whereas Azure charges you for per minute of your usage. So in terms of pricing, you may see that probably there are some features. In fact, there will always be a price war going on. So at some time, in some of the features, probably AWS will come in cheaper. On other features, probably Azure will come cheaper, and probably Google Cloud may come in cheaper than both of them in some cases as well. So you literally have to pick and choose which service you want to be interested in and which service will give you more features and more availability and durability, and then you can also decide on the price factor as well. AWS, as I said, it wins, and it wins by quite some margin. So as you can see, it has greater market share, 31% of the total cloud computing market. It has a more mature model of infrastructure since it is, it was started in 2006. Of course, their practices have been, more mature compared to, other cloud providers like Google, Azure, and so on. It has more server capacity. So imagine there are lots and lots of servers, but just to give you a rough number, if there are 1 million servers which are deployed across all the cloud providers which are available in the market, then your AWS alone is running 6 million servers. And I'm pretty sure they are running more than 6 million server. And it offers you better pricing as well. So in terms of pricing, as I said, there is a price war going on between different cloud providers. So maybe you will see that if you do a apple to apple comparison, maybe you will see that there are some services on which AWS is cheaper, there are some services where Azure is cheaper, there are other services where maybe Google is cheaper. But you need to take a holistic picture. You need to understand that if you want to deploy your environment on any cloud provider, then you need to make sure that of course you cannot keep moving from one cloud provider to another. So you need to take a holistic picture in terms of which cloud provider offers you a complete solution and better availability and better scalability and ease of usage before you want to move to that particular cloud. In terms of market demand for AWS, so if you see, this is the solution architect job posting. So we are talking about AWS solution architects. In 2016, there are 35% jump in the number of job posting which is having a keyword of AWS certified solution architect in the job description. So there are 35% more jobs which needs this kind of skill set. So if you are gonna get this skill set, you are pretty sure to get ahead of the pack in terms of making sure that your career is on the right track. Now, If by this time, if you have decided that you would want to learn AWS, so what are the options available to you? So Adureka offers a very structured training for you to get into, get your hands and feet dirty in AWS. So there is an AWS Solution Architect Associate level course which is provided by Adureka. So just to give you a quick recap of what that course content involves. So it starts with introduction and getting started with AWS, where we talk about what are the global infrastructure which is available in AWS. So the concepts of global infrastructure in terms of regions, availability zones, in terms of your caching locations or your edge locations, and how AWS uses those different features to give you a highly available, scalable, and a secure infrastructure. Then we move on to Amazon EC2. So EC2 is your server instances in the cloud. So we normally call it as Elastic Compute Cloud. So just to keep it simple, so this is basically your virtual machine in the AWS cloud. We call it as an EC2, which you can call it as a VM, you can call it as a server, you can call it as a server instance as well. So of course there are a lot of features in EC2, something which is worth exploring. Then we move on to the storage services and AWS CLI. So storage services include services like EBS, which is Elastic Block Storage, services like S3, which is simple storage service or an object-based storage. Elastic Block Storage is your block-based storage, which you can use to deploy your databases, deploy your file systems, and so on. Then we also talk about different types of storage classes which are available in S3. So we, services like S3 storage, standard storage, S3 infrequent access, and S3 reduced redundancy storage, and storage options which are available for archival purposes. So storage options like Glacier, and in how you can use different services within AWS for moving your workload from your data center to AWS. So we talk about services like storage gateways. We talk about services like AWS import and export, which helps you in moving or migrating your workload from your environment to the AWS cloud. Then we move on to next section, which is about the networking in AWS environment. So we talk about VPC, which is your virtual private cloud in AWS, which tells us how you can create your own little segment within the public cloud, which gives you even more security. And then we'll discuss the connectivity options in the cloud. So things like how you can create a VPN connection in case if you do not want to connect over internet, or how you can use direct connect for connecting to AWS using private connectivity like LeaseLine, MPLS, and so on as well. There is a section on databases. So there is a service called RDS or Relational Database Service in the cloud, which supports 6 types of database engines like MySQL, SQL Server, Oracle, Postgres, MariaDB, and Amazon Aurora as well. We explain how you can use these services to deploy your database in the cloud environment, and what are the different features which are associated with launching your database instance in the cloud. So features like creating read replicas, creating your multi-AZ databases for highly available and secure databases as well. Then we move on to the Elastic Load Balancer or ELB and autoscaling. So as I have explained that you can use the autoscaling feature to automatically scale up or scale down without any user intervention involved. So this is where we integrate the different concepts of monitoring your server environment and then using those monitoring metrics to create some kind of events or some kind of thresholds, so that whenever your metrics reach a certain threshold, it will trigger an event, and based on that event you can configure your autoscaling policies to either add or delete your server instances in the AWS cloud. So that gives you automated environment in terms of your traffic needs. Then we move on to the service called Route 53, which is a DNS service in the cloud, and we talk about the different management tools which are available to us, like CloudWatch, which is basically a monitoring service in the cloud. Then we have different services like application services like SCS, Simple Email Service, SQS, Simple Queue Services, and then you have SNS, which is a simple notification services, something that you can use to send a notification to your IT admin guys if something goes up or down in your environment as well. There are services like Lambda, which is an event-based programming, so that whenever someone is, for example, uploading any content on your S3 storage buckets, then it will trigger an event and you can use that event programmatically take some action on as well. Then we talk about Elastic Beanstalk, something that I have talked in platform as a service model. So this is basically a platform as a service kind of model where you just select the runtime environment that you're looking for, and then you upload your code and with just a click of a mouse, you can deploy your applications. Then we move on to some of the more automation stuff. So things like ops work, cloud formation, the security features in the cloud, and identity services. How you can make sure that you can use identity services. We call it as identity and access management services, or IAM, to manage your user authentication or access control in your cloud. So there are different concepts like how you can create different users, how you can create different groups, how you can assign those IAM users into groups, and how you can assign different roles to the group or user level so that they can access your AWS cloud securely. And lastly, of course, we have a mock test and doubt clearing session as well. So after completing all these services, we will give you some kind of tips in terms of how you can approach your AWS exam, how you can clear those exams, and what are the different reference material that you need to go for before you attempt your exam. So primarily more of an exam tips, and of course a session which is kept to clear any of your doubts on any of the previous modules that we have covered. So as you can see, it's quite a structured way of delivering a session. So there's a structured training which is available from Edureka, which I'm sure that you guys would love to enroll into in case if you want to get started with AWS. All right, so let's quickly recap what we have learned so far in this webinar, or what we have covered in this webinar. So we started off with what is cloud computing and why cloud computing. So cloud computing, as I said, that it's a service where you can deploy your infrastructure remotely onto the cloud environment, and then you can access that infrastructure from internet. And AWS, we have seen, is a market leader in this particular segment with 31% market share globally, with 6 times more server capacity being run in AWS cloud compared to other cloud providers. Then we talked about different types of services models. So there is infrastructure as a service model, platform as a service model, and software as a service model. And which particular service models fits for which categories, and what you will be responsible for in those service models as well. Then we followed it up with deployment models. So there are 3 types of deployment models, which is public cloud deployment, private cloud deployment, and hybrid cloud deployment as well. So public, in case if you want to move to public cloud providers like AWS, Google, Microsoft, and so on. Private, in case if you want to use some other third-party companies, and hybrid is if you want to use both, a mix of both. We also had a look at the different cloud providers which are available in the market, and lastly we covered the structured training which is available for students to get started in AWS from Edureka. So this will conclude our session for today. So I'm going to pause for a moment for if there are any questions from anyone. Any questions from anyone on any of the topics that we have covered, or anything that you want to know if you want to enroll in Edureka's AWS Solution Architect Associate Level Training? All right, so if there are no more questions, so we will conclude our session for today, and I would look forward to having you on board on Edureka course. I am a certified trainer with Edureka, so hopefully I'll see you in one of the courses as well. Thank you so much for your time, and good luck with your cloud journey.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Java and Python are the 2 most trending and powerful languages of recent times, and it is quite common to get confused when it comes to picking one out of the 2. Now, the most common question asked by the beginners is which one is better, Java or Python? This is Shantini from Edureka, and in today's session, I will talk about how both the languages differ from one another and which one fits your goal better. So let's get started. The number of programming languages used in production and day-to-day life has seen an enormous growth in the last decade. Now, from those bustling numbers, we are going to narrow our focus to the 2 most popular languages that have created quite a buzz among the developers as well as the beginners. So let's begin with a brief introduction of both the languages. Java is one of the most fundamental languages that produces software for multiple platforms. And the best thing is that it is machine independent and can be written once and run anywhere. Python, on the other hand, is a simple, easy to read, and high-level programming language. but programmers mostly fall in love with it because of the increased productivity that it provides. Both of these have been the two most popular and controversial languages of the decade. So let's move ahead and take a look at the various aspects of comparison that will help us to find an answer to the question, which one is better out of the two? Now, if we take a look at the speed of Java and Python, the former is a statically typed programming language, which makes it faster, whereas the latter is an interpreter, which determines the type of data at runtime, thus making it slower comparatively. When it comes to legacy, Java's history in the enterprise and the verbose coding style are typically larger and more numerous, whereas Python has less legacy problem, which makes it difficult for the organizations to copy and paste codes. Now, both the languages are pretty simple and easy to write, but if we look at the length of both the codes, Python consists of less number of lines or shorter codes as compared to Java, which are also easy to understand. Another characteristic is the databases. Java database connectivity is most popular and widely used to connect, whereas Python's database access layers are weaker than JDBC. That is why it is rarely used in enterprises. Now, if we look at the practical agility, Java provides more undeviating refactoring support than Python because of its static type system and universality of IDE for the development of mobile and web applications. But Python has become a popular choice for all the recent technologies like data science, machine learning, IoT, and artificial intelligence. Next up, if we look at the search results of US and India in the last 5 years, US has seen a drastic drift in the domination of both the languages. There has been a significant growth in the search for Python, whereas the other has seen a gradual decrease in the graph. India has also seen a growth in case of Python. The next feature of comparisons is the salary growth of Java engineers and Python engineers based on their experience. We can see that there has been a steady growth in both the situations over a certain period of time. Now, if we compare the growth of both the engineers in case of freshers, Python has a little edge over Java due to its increased demand in the recent times. Nowadays, the jobs are mostly related to automation and artificial intelligence, which prefer Python over Java. And that's exactly why we can see the shift in the graph. Whereas if we look at the growth in case of experienced engineers, Java dominates over the time. Because Java has been in use way before Python became popular, and the experienced engineers find it convenient for them to stick to their comfort zone instead of moving to a new language. Now let us have a look at one of the most important aspects that makes Java and Python different from each other, and this might help you to finally decide the winner out of the two. Let's have a look at some of the basic differences. Java is a compiled programming language, and the source code is compiled down to bytecode by the Java compiler, and the bytecode is executed by a Java virtual machine. On the other hand, Python is an interpreted language, as the translation occurs at the same time as the program is being executed. Now, Java supports encapsulation, inheritance, polymorphism, and abstraction, which makes it an object-oriented language. Python is also an object-oriented language, but it has an added advantage. It is also a scripting language, and it is easy to write scripts in Python. Now, statically typed programming languages do type checking at compile time as opposed to runtime, whereas the dynamically typed programming languages do type checking at runtime as opposed to compile time. And it helps you write a little quicker because you do not have to specify types every time. Next, if we compare the number of lines in a code, Python can perform the same action with fewer lines than the same code written in Java. In this example, we are printing the statement hello world using both the languages. But in Java, we need to define a class and a main function, which makes it a 3-line code already. Whereas we can just use the print function for the statement in case of Python. In Java programming language, if you miss the semicolon at the end of a statement, it will throw an error. But there is no such need of any semicolon to end a statement in case of Python. Now, another important difference in the syntax of both the languages is the indentation. In Java, you must define a particular block using curly braces, otherwise the code won't work. But in case of Python, there is no such sight of any curly braces, even though indentation is mandatory. It also improves the readability of the code. So, if we take a closer look at all these aspects of comparison, we can say that Python has a slight edge over Java, and it would be fair to declare the former as the winner in this battle. So, what do you think? Do let us know about your opinion in the comment section below, and also mention other aspects where you think Java wins over Python. Till then, thank you and happy learning!
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, I am Vishal and I welcome you all to this session on AWS Cloud Computing. Now in this session, we are going to take a look at quite a few concepts that would keep even the beginners and also intermediate level people interested. So let's not waste any time and quickly start by taking a look at today's agenda first. First and foremost, I would start by talking about the basics of cloud, as in we would discuss what is cloud and what are the fundamentals of cloud computing. We would also understand what AWS is, what are its features, and what are its services. Then I would talk about an important topic called as migration. We would understand what migration is, what are its phases, and what are its different strategies that would help you actually go ahead and carry out the process of migration. Finally, I would finish things off with the demo part. Again, the demo would be something that would keep even the beginners interested, and we'd also discuss a use case where I would talk about migrating a particular virtual machine to AWS. So stay tuned and let's quickly jump into the first topic of discussion, that is, what is cloud? To explain this particular topic, I would like to explain the pre-cloud era. So let's try to understand what happened before cloud came into existence. Well, first and foremost, in order to host a particular website, you had to buy a stack of servers. Now, what happened here was these servers were costly, and maintaining and monitoring these servers or applications on top of them was a complicated process. Now, what this meant was people had to go ahead and pay a lot of money and invest a lot of time. Still, they did not yield a proper output or desired results. Now, what happened next? Well, certain people, they went in and they bought huge space online and a collection of servers. What they also did was they rented this space, these servers, and certain compute capacities or services which people could actually just rent or use for their service sake. That means all these services and this space was orchestrated. Now, let me throw a little more light on this particular topic. Back then, we used to buy servers, right? So buying the servers is still possible. What we are doing is we are renting it. But how is it different from buying it, right? Because we are still paying the money. But when you rent a particular service or a server, you are paying less money. Why is that so? Because back then you had to buy the entirety of the architecture. That meant you were never sure as in how much space and compute capacity you needed. So you pre-planned stuff and you bought all those services. Now, in that case, there was a possibility that you buying excess amounts of space and services which you did not actually need. Or in certain cases, what happened was you bought something that was very less and then you had problems upscaling. Now, that is not the problem which you face in this scenario. Here, you can rent services and compute capacity to your needs, and when you need to upscale or downscale, you pay only for that upscaling and downscaling, and you can do that as per your needs as well. This whole process of orchestration of all these activities is nothing but your cloud. I hope this idea is clear to you guys. So let us move further and try to understand some other basics of cloud computing. Before that, let's try to understand cloud computing in general. To keep it simple, it is nothing but the process of storing data, processing data, and accessing data from anywhere or across any place in the world or on the globe. Now, to keep it more simple, I would say think of it as a situation where you have this cloud where your data resides. You can actually go ahead and put your data there. You can process it there, and you can actually access all this data by sitting anywhere across the globe. So that is what cloud computing does, or these are the phases or stages as far as your cloud computing is concerned. Next, let us try to understand something called as service models. Now, we've just understood what cloud computing is and we've understood what cloud is. Now, this is something that is very basic or very core when you talk about cloud computing. Now, we just talked about how you can actually go ahead and rent particular servers or compute capacities or compute services or any other services that a cloud has to offer to you. Now, based on the way you rent these spaces or these services, you have three models. You have your software as a service model, you have your platform as a service model, and infrastructure as a service model. Now, how are these three different from each other? Let me give you some basic examples or some basic explanation on all these three topics. Well, when you talk about software as a service, as the name suggests, you're actually renting or taking the complete software, ready to use software as a service. That means if you have, say, a provider XYZ who is providing you with these services, now this XYZ provider would give you a complete software which you can use. You do not have to worry about anything. You do not have to worry about the applications, runtime, middleware, operating systems, virtualization, security, storage, networking, anything. You do not have to worry about anything. Everything is taken care by the vendor or the provider. All you have to do is just consume that service and pay for the usage of that particular service. To give you a basic example, electricity. Now, you do not produce electricity, do you? You just consume it, right? The provider takes care of everything, supplying it to your house, everything else that is concerned. You get a bill and you just pay that, right? Similarly, you have, when you talk about technology or computing world, Gmail, for example, what you do is you just send in mails, right? You do not have to worry about anything. It can be opened on your system. You do not have to worry about where it is stored or where it is taken care of. You do not have to worry about anything, right? Everything is taken care by the vendor, even the security part and the operation part. All you do is you type the mail and you send it to the concerned person. That's it. So this is the best example when you talk about software as a service. So this is one way in which you can use cloud. That means you just consume a particular software or a particular service. Next, you have platform as a service. Now, this is a little different than what we just heard or talked about. As far as platform as a service is concerned, here the service provider gives you a complete platform for your usage. That means he says, here you go, you have certain, means this is the so-called platform where you can actually go ahead and do certain things. That means I would give you a complete platform where you can actually go ahead and run your applications and put your data on it. Again, here everything is taken care by the vendor. That means networking, storage, servers, virtualization, operating systems, middleware, runtime, everything. What you do is you just use the existing architecture or existing platform. On top of it, you put your application or build your application and start using it. To give you an example, you have your Google App Engine where you have a proper platform where you can go ahead and put your applications or build new applications using the existing architecture they have. And finally, we have infrastructure as a service. Now here, the complete infrastructure is given to you. That means virtualization, servers, storage, and networking is something that your vendor takes care of. Apart from that, you have to start fresher. That means you have to take care of your operating systems, middleware, runtime, applications, and data. That means you manage all these things on your own. To give you another example, well, what example should I give you? Say, for example, you're eating pizza, right? Now, when you do go ahead and eat pizza, what happens is you decide to make your own pizza. In that case, you'd go ahead and buy certain stuff, right? Say, for example, you'd buy your dough or your pizza base, you'd buy all the toppings and all those things, right? So when you do go ahead and bake your own pizza, in that case, you just have the material with you. It is your way or your method to go ahead and cook that particular pizza or bake that particular pizza or oven it or whatever it is. I mean, you have to take care of everything, right? You have the basic infrastructure, and on top of it, you are going to go ahead and have your own pizza and then consume it, right? So this is what infrastructure as a service is. The vendor provides you with the infrastructure. You have to take care of remaining things. So you have infrastructure as a service, you have platform as a service, and then you also have software as a service. So these are three basic service models that are very core to cloud computing. And this is how cloud operates, or these are the ways in which your cloud operates. I hope this is clear to you guys. So let us move further and take a look at some other concepts as well. So yeah, this brings us to the next topic of discussion, that is AWS. Now, AWS is Amazon Web Services, which, as the name suggests, is an Amazon product, and it is one of the first. I'm using the term one of the because it's not the first, but yeah, one of the first cloud service providers, and it is very popular. And when you talk about its market share, it is the best cloud service provider in the market because it has great grasp when you talk about the cloud computing world. If you talk about its compute capacity, it is 6 times larger than all the other cloud service providers combined. Plus, since they have been there in this market for a very long time, all their services are very well fine-tuned and their services are very good, just like Amazon is. I mean, we all know that it is a world leader when you talk about quite a few other services it provides. And same is when you talk about its cloud computing services as well. So yeah, Amazon Web Services is a secure cloud services platform. What it offers is it offers you compute power, database storage, content delivery, and other functionality to help you scale up your businesses and make them grow. Yes. So what they've done is they've actually gone ahead and divided their so-called resources into 8 different domains. Under these 8 domains, you can have a number of other services. So you're free to go ahead and utilize all their services. As we move further, we would be discussing those services as well. When you talk about AWS, it is a cloud service provider and it is one of the best cloud service providers that is there in the market. So what are its features? First and foremost, what it does is it gives you on-demand provisioning. That means you can ask for whatever you need, when you need it, and how much you need it. And AWS would provide you that. It provides you scalability in minutes, and that is very true. Not even in minutes, even in lesser time. What happens here is, say for example, you are using a particular server or a particular space rather. Now you need 2 petabytes of memory. In that case, suppose you're using that memory and certain situation comes in where you need to upscale. So within minutes, you can actually go ahead and add more space to your already existing infrastructure. Or at times what happens is you might not be using the whole 2 petabytes of space, right? So you require, say, lesser space for the remaining time where you're not in your peak hours. In that case, you can downscale as well. And you'd be paying only for the services which you're actually using and not for the whole infrastructure. So this flexibility comes in, and that is why scalability becomes easier and quicker. Pay as you consume. As I've already mentioned, you'd pay only for the services which you're using and only for the time duration you're using it. So if you need more services, you can rent more services and you can pay more as well. And even if you pay more, trust me, it is affordable than in most of the other situations you might be in. Fourth, we have abstract resources. Now, what happens here is when you talk about abstraction, you can actually go ahead and focus on particular tasks which you're supposed to implement, and you have to stop worrying about hardware, maintaining, monitoring, and security issues because everything else is taken care by your provider or by your vendor. In this case, AWS. Efficiency of experts. Now, what this does is it lets you utilize the skills, knowledge, and resources of experts. That means now the people who've built this platform are experienced people, and the people who are maintaining it are also highly experienced. Plus, the level of integration and adaptation which you can do by using this platform is unimaginable. And that is why both scaling up, integrating, and experimenting becomes a lot easier. That's why you actually go ahead and achieve an efficiency that is at an expert level. Plus, whatever you do is measurable. These metrics monitoring practices which AWS follows lets you keep track of all the money that you might be required to invest, and it takes care of all the issues that are there as far as your so-called application lifecycle is concerned. So all in all, everything can be measured and you can keep track of everything. Something that lets you focus more on your business and less on the other parts which you would not want to go ahead and concern about. So these are some of the features when you talk about Amazon Web Services. Let us move further and try to understand what are the different AWS service domains. Now, when you talk about AWS, we have 8 domains in total, and each of these domains, they have quite a few services. I won't be talking about all these services in detail, but I would be giving you a quick walkthrough of certain domains and certain services that lie under these domains. So let's start by discussing these domains one by one. First and foremost, we have compute. Now, when you talk about compute, it provides you with computation power, and it has certain services called as EC2, which is one of the most popular services it has. It stands for Elastic Cloud Compute. Think of it as a raw server, which is a blank server or a clean slate, just like your newly bought laptop, which is without an operating system and all those things. You're free to install the applications you want and use it. Similar is with EC2, that is Elastic Cloud Compute. Then you have something called as Lambda, which is again a compute service which works in the background. And you also have Elastic Beanstalk, which again is like EC2, but something that has, say, plugins, not plugins. Think of it as plugins or libraries. Say, for example, you use Java, right? I mean, in Java, or say in some programming language, you might be needing certain libraries which have some predefined tasks. You just go ahead and use those libraries, right? So these are some of the compute services which are very popular, and AWS supports these. Then you have migration. Now, when you talk about migration, we would be discussing this, do not worry. You're actually moving your data from your on-premise location to cloud, or from one infrastructure to the other. Now, this migration has a number of other factors and various ways to do it. One of the ways to do it is to physically move the data from one place to another. That can be done by using Snowball, which lets you actually physically migrate your data. Now, you might ask me, why do you need to go ahead and migrate your data physically? Think of this situation. At times you have to drop a mail. Mail dropping becomes very easy because if the file is small in size, you just copy it, enter the email ID and forward it, right? But in case if you have to go ahead and transfer a movie to someone or send a movie to someone, it's better to copy that movie in a pen drive and give it to that person or in particular, right? So that is how migration also works. In certain situations, you might be required to go ahead and move your data physically, and Snowball lets you do that. There are a number of other ways of migrating your data as well. As we move further, we would be discussing that as well. So this is what migration covers, or all the services that are under migration that talk about moving your data to and fro from or within or between various services. Next, we have security and compliance. Now, what AWS does is it implements stringent policies when you talk about security, because cloud security has always been at stake or under the scrutiny. But in recent times, it has been proved that cloud platforms are highly secure. And the reason for that is platforms like AWS implement various compliance programs, and they have various services like IAM, which actually implement a lot of thought and work into identification and access management. You also have services like KMS, which actually use key pairs or key protection methods where you have your public and private keys and all those things. So, yep, when you talk about security, these are some of the services which you should know about. So next we have different storage services as well. Now, when you talk about storage services, you have something called as S3, which is your simple storage service, which works like a mechanism where you have a bucket and objects kind of an architecture. Now, these objects are your file, which are stored in a particular bucket, which is your root folder. Then you have Amazon Glacier, which actually supports archival storage. You can store certain files here, which you do not need to retrieve again and again. That means if you do request for a particular retrieval, it might take 3 to 5 hours, where this is the total retrieval time of that particular data file. Now, here we store the data that might not be required frequently, and that is why this method of storage is affordable or cheaper. Then you have database services as well. Now, when you talk about databases, it is similar to your storage services, but you cannot store executable files here. You have to store those in your storage services or store those using your storage services. Now you have quite a few databases as well. You have something called as RDS, your relational database services. Apart from that, there are other services as well which let you have various SQL functionalities as well. You have Aurora, which works like your SQL databases, but it's 5 times faster is what Amazon Web Services claims. Then you have messaging, where you can actually exchange messages and carry out quite a few other tasks as well. Again, I won't get into the details of these things, but yeah. Then you have networking, where you can actually take care of the networking part. You have various virtual private networks and all those things, and the services that concern all these operations that fall under networking. And finally, you have your management tools like your CloudWatch, where you can actually go ahead and set alarms and keep a track of all the metrics and all those things. So yeah, these are some of the services when you talk about AWS, or at least the domains under which there are quite a few other services. Now let us move further and try to understand the next topic, that is migration. Now cloud migration is nothing but a process of moving your data, applications or other business elements from an organization's on-site computers to the cloud, or moving it from one cloud environment to the other. Now this is a very basic and generic definition, and it actually gives you the gist of what we are going to discuss. For people who are completely new, do not worry, I would be again talking about certain topics. Now, as I've already mentioned, AWS is a cloud service provider, and that lets you consume all these services. Now, there are situations where you have an existing architecture or applications that you're using. Now, yes, you might be using those applications before the advent of cloud happened. And now that there is this cloud thing, you might be wondering, or some of your friends might be using this cloud and they come and tell you that this cloud is good and you should try it. So you as an individual might wonder, as in, okay, I need to use this cloud, but I do have an existing architecture or application. Now, what can I do? Can I move my application to AWS or any cloud provider? Likewise, do I need to completely move my applications? Do I need to move a part of it? Can I run it partially on premise, and can I partially run it on the cloud? Well, there are quite a few questions that you might have, right? I mean, you have a website, you're hosting it somewhere else. Now you want to put it on cloud. So how do you do that? Well, you migrate your so-called website to cloud or to AWS. Now this process is migration. I hope this is clear to you guys. So let's try to understand a little more about migration, how it happens, what are the factors that are considered when we talk about migration. Now these are some of the phases of migration. As I've already mentioned, suppose you have your so-called architecture or business application which you want to migrate to AWS. In that situation, what you would do is you'd evaluate the opportunity. That means you would first evaluate the possibility, as in, do you need a migration? If you do migrate, would it be affordable for you? And then you would accordingly do all the research and take a call on it. Portfolio discovery and planning. Again, now in this situation, you'd analyze your architecture completely. To give you more business level example, you have your various databases, right? You'd monitor all the capacity and infrastructure that you have. You'd think, as in, okay, these are the existing systems that I use. If I do migrate to cloud, these are the systems or architecture that is available. So when I do migrate, would it be beneficial? Would it be something that would be convenient? And if I do have to migrate, how do I actually go ahead and migrate all these applications there? So this is what you do in your portfolio discovery and planning. That means you discover or you plan all the resources that you have, and then you actually go ahead and move all these applications or your so-called infrastructure, or make a plan that lets you actually go ahead and take this decision about migration. Then is the third part. Now, when you talk about these phases, there are 5 in total. We've discussed 2. This third point basically covers 2 other points. Here we are discussing designing, migrating, and validating applications. Now, these points that I've mentioned here are basically combination of 2 points. So what happens here is, this is a very core concept. Now, in the future slides, we are going to discuss about the different strategies. Now, your strategies are pretty much something that is implemented in this phase of your migration. Here, what you do is you design, migrate, and validate. Now, how do you design? There are quite a few factors that you need to consider when you actually go ahead and design this migration strategy, and it considers various other factors as well. So we'll be discussing those factors, do not worry. So based on those factors, what you do is you go ahead and you design a particular strategy, then you take care of migration, and after that you validate your applications whether what you've migrated is as you need or not. And finally, you have modern operating models. Now, what happens is, modeling is something that you need to do, because once you move to cloud, then you have quite a few things to take care of. Do you want to stick to the architecture that you have? Do you want to upgrade to something that you can do? Because once you move to cloud, you have quite a few other tools and applications that are available to you, and you can restructure or redesign your applications completely. So these are the phases that happen. That means first and foremost, you think of the situation whether you want to migrate or not. Then you plan it and take a call on it, as in you do a complete research of what you have and what you need to do. Then you actually go ahead and design or chalk out a particular plan. And finally, once you've migrated your application, you validate it. Then you think about other optimizations and other modifications as well. Next, let us try to understand what is migration when you talk about AWS, and what are the strategies that you need to take care of. First and foremost, we consider rehosting. Now we are going to talk about 6 R's. The first one is rehosting. Now when you talk about rehosting, what you do is you basically move your application from one host to the other. That means you're simply migrating your application. Even if you do not go ahead and restructure or rescale your application, even rehosting can be beneficial at times. There are quite a few companies who have just rehosted their applications from one place to other and have made certain changes to certain applications. That means, say for example, in one situation, there was n number or n type of application handling your data, and then you move to some other type where, say, a particular Java application is taking care of your data. In that case, you might face a situation where you're actually saving n number or n percentage of your investment, and that is one benefit that you have out of rehosting. That means when you do go ahead and change your hosts, or you move your application or migrate your application from one on-premise platform to the other, or to your cloud, basically, in that case you're actually doing a lot of things and saving a lot of money. So this is one approach, that is moving your application from one host to the other. Think of it as a situation where you pick up your application and you place it somewhere else. Second, you have replatforming. Now this is similar to the first topic that we discussed, that is you pick up your application and you move it somewhere else. But what happens here is you tinker or you make slight changes. That means I would be picking up my applications, and along the way I would be making certain changes for this application to adjust to my new platform. This process is called as replatforming. Then you have something called as repurchasing. Now, say for example, again, when you talk about customer services, or not customer services, but when you talk about CRM, what happens here is you have a popular contender called as Salesforce, which helps you manage all your CRM activities in a much better way. So when you're actually going ahead and thinking about moving to a particular cloud, in that situation, what you can do is you can actually migrate to cloud, and then you can repurchase everything that you need, or replan everything that you need. In this situation, what the proper example would be your so-called Salesforce, where you're moving your CRM requirements to Salesforce, right? Refactoring. Now, when you talk about refactoring, think of this situation as, say, for example, I have a particular application which I've moved to, again, AWS. Now, in this situation, I might be needing certain advancements in the business that are available. I can refactor, rescale, or re-architect my business as per the needs, and I work on the architecture in that particular way. So this process is called as refactoring. Then you have something called as retiring. Now, here what happens is, again, once I've migrated my application, there are certain services which I do not need to use, right? In that case, if I have to save or optimize my business, I can let go of those services, either adapt to new ones or stick to the ones that I have and release the ones which I do not need. And then you have something called as retaining your applications. Now, when you talk about retaining your applications, you're moving your business from an on-premise environment to your so-called cloud. Now, in this situation, you might take a call where you might want to run certain part of your applications on-premise and certain on cloud. So you can take a call on which applications to retain on your on-premise environment and which to move to the cloud. But trust me, when you move to cloud, there are quite a few things or very less things which you would actually want to run on premise, because that is how cloud is and that is the flexibility it gives you. So these are some of the strategies when you talk about AWS or migration that is related to AWS, and these are some of the important terms that you need to understand. I hope that you've understood these terms. In that case, let's move further and switch into the console where I can give you the demo, or we can work on quite a few things which I discussed in the agenda part. Let me just quickly switch to the demo part and let's have a proper look at the demo as well. So yes, guys, what I've done is I've gone ahead and I've logged into my AWS account. This is it here. But for people who are completely new, if you want to go ahead and use AWS, I would suggest that you sign into their free tier account. Now, what is a free tier account? Well, when you talk about a free tier account, basically what happens here is AWS provides you with certain services which you can explore and use for free for one complete year. Yes, there are certain limits. If you cross those limits, they would charge you, but the limit margin is huge. So you do not have to worry about they charging you or any such thing. So yep, this is what you have here. All you have to do is you have to go ahead and click on this icon, and They'd ask you to fill in the details, as in your details. Okay, you'll have to specify your role and the area in which you are interested in, and then some other details like your login details, your email ID, a valid email ID, a password, and one more thing. They would ask you for your credit card or your debit card details, and you have to give in those details because that is where they would bill you. But do not worry, as long as you stay in the limit, they won't actually go ahead and charge you. So do go ahead and create an account and sign in. So do not worry about the charges because it is available to you for free, and you can actually go ahead and set certain alarms that ensure that you are not charged when you do go ahead and use certain services. So yep, I won't go ahead and continue with the signing process because I believe you all can go ahead and create an account. It's not too difficult. You just have to fill in certain details, and yes, AWS would ask you your debit card details and it would debit 2 rupees. Now I'm from India, and 2 INR, that is Indian rupees, were deducted from my account just for the verification purpose, which is very less when you talk about in normal sense. So 2 rupees would be debited and those would be retransferred back to your account. This is just for the verification sake. So what do they have when you talk about their free services? If you just go back, instead I would just go ahead and type AWS free tier again. There you go, AWS free tier. And these are the free tier services that are made available to you. You have Amazon EC2 available for 750 hours. You have your Amazon QuickSet, which is for analytics. Now I won't get into the details. This is the capacity given to you. And yep, there are quite a few other services which you can use and do so many things with it. Say for example, Amazon S3, which we are going to use today in the demo part, has a capacity of 5 GB of standard storage, which is made available to you for free. So yes, as far as today's demo goes, you won't be charged anything. And these are some of the other prices which you should consider. So for people who again are completely new, I would suggest that you come here, take a look at this page, sign in, and take a look at certain videos that introduce you to so many concepts that AWS has to offer to you, at least from a beginner's perspective. Now, once you do have an account, this is what you get. These are some of the recently used services. As far as this session goes, I am supposed to give you a demo on migrating a virtual machine. So I had to use these things to do that, which I would be doing again in this session as well. So that is what you see in the recently used services. Plus you have something called as other services as well, like your compute services, management tools, mobile services, and all those things. Let me quickly give you a small introduction as in how can you go ahead and create a virtual machine or an instance rather. So when you click on EC2, this is the page you get redirected to. Now you see there are 0 running instances and those things. Do you want to launch an instance? You can say yes. And then you have all these options from which you can choose. Some of those are free instances, some of those are charged. Somehow I cannot scroll back. Yeah. So these are some of the instances which are free tier eligible. So if you select these, you can say review and launch. This is the one which I've selected. These are the details. So this is the instance which I've selected. These are the details here. Say for example, we have number of CPUs that are made available, the space that you're going to use, and quite a few other things as well. So you can just go ahead and say next, fill in these details if you feel it is necessary, add storage details, and then you can say review and launch, as in your instance would be, yeah. So it says either go ahead and choose the existing key pair, or you can always go ahead and create a new key pair. Now, when you talk about an EC2 instance, every instance would have its individual key pair, which is unique to itself. Now, why is it unique? Because there are certain policies or rules every instance follows. You cannot just clone or make duplicate copies of a particular instance. Yes, you can copy the data, but having duplicate instances is something that is difficult or prevented against the privacy laws. So when you talk about a key pair, it is unique to every instance. So when you do need to go ahead and use that instance, you need to have this key pair for various purposes. So yeah, you can say create a new key pair and you can download it here. You would get an access to those things. Now, I won't get into the details of this thing because I'm not here actually to go ahead and create an instance because I won't be using it. But what you can do is you can download that key pair and then you can just go ahead and follow the processes where you click on next, 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 and you'd actually have an instance which is made available to you. So this is how easy it is to go ahead and create an EC2 instance. Now, what is an EC2 instance? It is basically a virtual machine or a space that is made available to you, which you can use and perform various tasks with it. Virtual machine exactly would be a wrong term, but yeah, think of it as a raw server is what I would say, where you can actually do quite a few other things. So yeah, for now, what I'm going to do is I'm just gonna go back, or I'm gonna say cancel and come back here. So this is where you actually go ahead and launch an EC2 instance. I would say back again, and I'm taken back to the console that I have. So yeah, these are some of the services that are made available to you, and these are the ways in which you can do stuff. Now I just almost showed you how to create an instance. I would suggest you go ahead and create an instance on your own. If you do have any problems, you can refer the other AWS videos that Edureka has to offer to you that are there in the stack. When you talk about YouTube list of videos, there's a video called as getting started with AWS, and there's one more video called as introduction to AWS. You can refer any one of those videos, and I'm sure that at least one of those videos has a demo as to how should you go ahead and create an EC2 instance. But yeah, I just wanted you to have some understanding as in what an EC2 instance is and how do you create it. So yep, you can click here, you can select the version, preferably select the one that is free if you do not want to spend any money, and then you go ahead and do the procedure, that is just follow the next steps, and you would be having an instance. The only thing that you need to keep in mind is you need to generate a key value pair which is unique for every instance, and you'd be needing that key value pair. So when you do generate an instance, keep that copy with you. Now what I'm going to do is I'm going to go ahead and switch into the demo part which I committed when I started this session. That is, we would be going ahead and migrating a virtual machine from some other environment into AWS. Now for people who are completely new, this might sound a little too much or a little too difficult, but do not worry, I would be giving you step-by-step explanation as in what we are going to do and what are we trying to achieve. So if you do have any doubts, you can ask those doubts in the comment section below, and we would be more than happy to get back to you on all your queries. Just try to keep up with me, and we'd be having a fruitful discussion, I'm sure. So first and foremost, let me just give you a flow as in how do you proceed with this so-called migration. To understand that, you need to understand one thing, that what we are doing is we have a virtual machine. We are converting, or we are taking the converted format. We are migrating it to a cloud. Now, when you say cloud, there too you need some arrangements done, right? I need a place where I can store this virtual machine or hold this virtual machine. And I need proper access rights and user rights to go ahead and carry out this process, right? So we are going to do all those things one by one. For people who are completely new, first try to understand what a virtual machine is. Now, a virtual machine is nothing but creation of a virtual environment where you can run softwares which you cannot run in your normal environment, or you have some other motive for that you are creating a virtual environment. Now, this is one software that lets you create virtual machines. I've actually created a virtual machine for Ubuntu here. Now I have a Windows operating system, and I wanted to create or have an operating system which could run certain applications that run only on Ubuntu. To do that, I had to create a virtual machine. Now that is what a virtual machine is. It is nothing but a way of creating an environment that supports certain applications or that helps me in better computation. So yeah, what my aim is, I want to move this kind of VM to my cloud. To do that, I need to convert this VM into a VMDK file, or a file that is supported by my so-called cloud, right? So I've actually gone ahead and converted it into VMDK. If you have workstation player or something like this, like say for example, you have created a virtual machine in your VMware workstation, do not worry, you can actually convert it into this kind of file. All you have to do is go to their opening tab, click on file, and click on export, and you can choose this format and you'd get a file in this so-called format. So my aim is to move my file in this format on my so-called cloud. So how do I move my file on cloud? Well, let's get back to this part. For that, I would be needing a storage place, right? Which I just mentioned. Say for example, S3. My internet is slow for some reason today. I do not know what that reason is. There you go. So I have this so-called S3. I can click here and create a bucket. Again, I won't be creating a bucket because I have two buckets here. You should go ahead and create a bucket. I would be using this bucket saying demo new bucket. For you to create this bucket, you have to click on this thing. Probably enter this name only just to keep it simple because we are going to use too many terminologies today. So yep, use this name and then go ahead and follow the procedure. That is, select a region. Again, remember the region name. What region name are you using? Because we would be needing that. Bucket name, region, next, and you'd be having a bucket which is made available to you, as you can see in this case. Then once you have a bucket, go ahead and upload files in it. Now there you go, I have this bucket, right? So in this bucket I've uploaded my vmdk file. All you have to do is click on upload and it gives you options. The reason I'm not doing this process is because uploading a file takes a very long time. My internet was slow and it took me more than an hour to upload this file. So yeah, create a bucket and upload your vmdk file here and we would be more than good to go. So you have a file now which is moved, or you have uploaded your so-called file on your S3. Next thing is you have to go ahead and create a user using which you can migrate your applications with ease and have them working. So how do you do that? To do that, again go to services and this time search for IAM. Now it is nothing but identity management and access basically. So what happens here is you monitor all the laws which deal with access and management. When you talk about identification, that is, this is for the security purpose, like creating laws by which you can set certain group policies, certain user policies, accesses, and all those things. Now I need a particular role and a policy assigned to it saying that I can import a particular file from client system to my so-called cloud, and that is what I'm going to do. So to do that, I have opened this IAM and here you have this option of roles. You click on it. So you say create a new role, select EC2 here for the service sake, and then click on next. There you go. It would say, do you want to create a policy? For now, say next and give it a name. I'm giving it a name called as VM import. I would suggest you give this name only because that is the name I would be using in the piece of code I have. So I say create. There you go. I have a VM import role. And then I click on this icon, trust relationships. And in this, I would edit the setting. Now I need to go ahead and paste a piece of code because these versions, they change every now and then. So you get fresh codes on AWS docs. So use this link to do that. I would be sharing it in the description, do not worry. And once you come here, you need to come here, image import. Import VM in the form of image, as an image rather. So how do I do it? Again, I come down or scroll down and I have certain pieces of codes here, right? Select this one to create service roles, right? Because I'm assigning my service role a policy, or I'm just updating the piece of code that is here. So I come here and I paste this. Now the name here is VM import. That is the reason I want my so-called role to be called as VM import, because last time I did it, it kind of gave me a lot of ambiguity. To avoid that, use this name and I say update. So my so-called role is ready. I also need to assign it particular policies, or a single policy rather. So I would say create policy, and this time again I would come here, scroll down and pick this piece of code. Guys, back then I told you to create a bucket, right? We would be needing the name of that bucket right now. So I would be copying it here first. I come here, I paste this piece of code here. I scroll up and as you can see, you have your bucket names here. Go back. My bucket name was demo new bucket. I enter it here. Again, demo new bucket. There you go. Demo new bucket, demo new bucket. And I say review policy. It says give it a name. Let's say VM import policy. VM import policy, let I be capital. And I say create. So now I have a role and I have a policy which I've created. The policy is almost there. As I've told you, the internet is very slow today. I refresh this thing once. I again go back to roles. In that, I open my VM import, which I just created. There you go. And I say attach policies. So the name was VM import policy. I select it and I say attach that policy to that particular role. So I have a role and I have certain policies attached to it. Now I need a user who can actually help me do quite a few things. So I say users, I say add user, and in that I need to give it a name, say demo 1234 is the name, and say programmatic access. Then it says, do you want to attach policies? I say yes. So I say attach existing policies, but I do not have an existing policy which I want here. So I would say create policy. And again, I would come here for the piece of code. This time I go to requirements. I scroll down and there is this piece of code which is required permission for IAM users. You copy that code. Okay. Control C. You come here. You say it was here. JSON file. Go here. Paste it. And again, the bucket name needs to be changed. So it is demo new bucket. There you go. So the name has changed, and again we need to give some name to this policy. Let's say VM import demo, maybe. Yeah, there you go. I say next. Now I come here, I have to attach that policy, right? So I say I refresh this thing once because it won't reflect unless I refresh it. VM import demo, was it right? And I would look for one more policy. Let me just add this first. Now you have something called as the CSV file which you need to download and keep it with you because these credentials are something that we are going to use. Go back to services and then say IAM. In that you go to users. We just created a user called as demo123. Okay, there was a slight mistake here. I wanted to add more policies. I could not. So I would just quickly repeat the process till the last step. I just go back here. I delete this user and I recreate it. So you bear with me meanwhile. Say delete this user. Yes. And for that, I would be deleting that policy as well. VM import demo, right? So I delete this policy as well. I would just quickly do the same steps again. Just bear with me meanwhile. You say add user, right? Say demo 1 2 3 4 5 programmatic access, attach policies. Now this is what you need to attach. One. Okay, first we create that older policy which we just skipped. You copy this piece of code here. You say JSON. There you go. So I've recreated the same policy. The reason I've recreated the user is in this you need to add more than one policies. One is your demo policy, that is your latest one, and you also need an administrative access here, which is this, because otherwise you won't be able to work through your console. That is why you need this as well. So demo latest policy, where you copy this piece of code which we just I showed you. Yep. And this, that is administrator access. Then I say next. And I say create a user. So my user technically has two policies that are attached to it. So again, I would be shutting this thing off and downloading it. There you go. Now these are the credentials which I would be needing. These are my access key and secret key. So let's keep this minimized for now. Now I've created a user as well. Now I actually need to migrate my so-called files, right? For that, I need to have a container file as well. So how do you create a container file? Well, if you come here again and say image import, you get this piece of code at the bottom, which gives you a container file. This is what you have. This is the file you have. You have to copy it completely and use it. You need to make changes here. I would be importing an Ubuntu file, right? So I would be entering in that name here. My format would be vmdk, and this is where I enter my bucket name, and then I have my S3 key. Now S3 key is nothing but here I would be entering the name of my so-called VM file. Now this is the name. I would be copying it and using it. So I've actually gone ahead and copied everything. As you can see, Ubuntu 64-bit, vmdk, demo new bucket, and this is what I have, the name of the vmdk file, right? So once you do that, you kind of save it in the form of JSON. That is, this file has to be saved with the extension of JSON. So containers.json is the file, and keep the path of this so-called file with you so that when you do go ahead and use your command prompt, you would be having this path, right? So close it. So now everything is done. I mean, I have so-called VM and I have its image file as well, which I've uploaded to my so-called S3 bucket. Then I have created a bucket. I've gone ahead, I've created users, user policies. And then all I need to do now is I need to go ahead and move my so-called file. So for that, I would be needing something called as CLI, that is command line interface. Now, what is that and what all it does? I won't be getting into the detail of those things, but I need to use an interface, that is this command prompt. And to do that, I would be needing CLI. What I'm going to do is I'm going to give you a link where you can download CLI and install it. Now, so you just go ahead and follow those steps and download all the files that are needed. For now, what I'm going to do is I'm going to go ahead and show how to import your so-called stuff. Now, if you do go ahead and install your CLI and open your command prompt, this is what you get. So what all do you enter here? First thing you do is you type this command, AWS user, and you hit enter button. Not user, I'm sorry, AWS configure. It would ask for an access key and the password, right? So we have the access key here. This is my access key. I copy it and I paste it here. You cannot use Control V, you have to do it manually, and then you hit the enter button, and then it would ask for your security key as well, which is this. Control A, Control C, come here, manually paste it again, hit the enter button. It would ask for the region. Now this is the region of your so-called bucket which you created, because you're moving your VM into your storage place, right? So it has to be same where your bucket is created. Mine was created in US West 2. So when you do go ahead and create your so-called bucket, you would get the region name as well. So enter that region name here. And once you do that, hit the enter button. It would ask for a file format, enter JSON, and then hit the enter button again. Now you need to start the migration process. How do you do it? Again, when you come here and you see this piece of code here, you have a particular command, right? Import multiple disks. I don't want multiple disks. I want a single disk. So you'd be copying this piece of code and making certain changes to it. So what are those changes? So this is the file here, okay, or this is the command rather. So the command remains the same. The only thing I've changed here is one, I've given in the path of the JSON file which I'm going to use. Now I created a containers file, right? File with containers.json extension, right? So I created a file, right? JSON, that is containers.json. So you should be using that file or the path for that particular file, and that path has to be entered here, as you can see. And then you have the name or the description. Now this is the description, Ubuntu 64-bit, the one which we used in the containers file. You have to enter that as well. So you can use this piece of code. What I've also done is, if I come here in this code, see, I've entered Ubuntu 64-bit here. License type is optional. You can remove this from the code. And disk containers, this is where you give in the path of your containers.json file, right? So once you have this piece of code, which is here, Control C, you copy it and you enter it here, paste, and you hit the enter button. And there you go, your migration starts. Now it is in progress, and this is the disk image size and all the details. This migration will continue and might take a very long time. I would suggest that you go ahead and do it on your own, because I'm sure that it's gonna take at least 2 hours as far as my internet is concerned. But once you do that, you also have one more command here. Let me just show you. Yeah, where did it go? Well, it has to be somewhere here. I have that command here somewhere. Yeah, so this is the command which you can use. If you use this command, what it would do is it would give you the details, as in where is the migration or what is the status of your migration. So when you enter that command here, it would give you updates. Means, say if you put it after maybe 15 minutes, if there is a progress and there has been a migration for say maybe 30%, you'd be updated accordingly. So this is how the migration works, and if you do go ahead and complete these steps, you would be successfully able to migrate your so-called virtual machine to AWS. As far as this session goes, these were the topics which I wanted to talk about. I hope you all had a clear understanding of whatever we've discussed. If you do have any queries and questions and you feel that you need answers to that as well, you can feel free to put those queries in the comments or the chat box below, and we'd be more than happy to get back to you with the solution as soon as possible. As far as this session goes, thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Today's session is going to be on AWS certifications. So why is a certification important? Let's shed a light on that. So say you apply for a company and you're looking for a job change, right? And the other candidate which is competing with you has the same experience as you. And now how will a company like me, so if I am a company, how will I decide that you are better than him or he is better than you? So if any one of you is certified, I will give more priority to that person. And that is the reason certifications are important. But certifications are important just for the stage one, that is for getting screened, right? They don't guarantee you a job. Just because you're certified, that does not mean you'll end up with a job in the AWS sector. You have to have hands-on experience as well. Now, why am I saying this is because in my experience, I've seen a lot of people who have the certification, but they hardly know anything about the subject, right? So if you don't have the hands-on exposure, it is actually your certification is a waste because no company will hire you. Because the only reason they hire certified people is because they think okay, so this guy knows a lot about this subject. And when we talk about AWS, it is all about implementing. It is all about hands-on, right? So if you have not practiced hands-on and you have the certification, you might not get a job. Finding a job will become very difficult for you, right? So it is very important to actually know what you're studying rather than just studying it for the sake of passing. Having said that, let's move ahead and see what certifications are actually offered by AWS. So AWS basically offers you 5 kind of certifications, under which 3 are in the associate level and 2 are in the professional level, right? So the certifications have actually been divided into domains. So you have the architecting domain, you have the developing domain, and you have the operations domain. The most famous certification or the most sought after certification out of all these certifications is the solution architect certification, right? Now, I've seen a lot of people without doing any research, just because the other person is doing a solution architect certification, they also get in line and start preparing for that. But you have to understand your expertise, right? So if you're a person who is from a development background, okay, so why not apply for the certified developer certification? If you're a person who has been handling machines, who is a Linux administrator or something like that, why not apply for the AWS Certified SysOps Administrator certification, right? So it is very important to choose the right certification because that is how your career will progress, and these certifications will actually give you a direction in your career. Moving on, let's discuss each of these certifications in brief. So talking about the first certification, it is the AWS Certified Solutions Architect. So basically in this certifications, your job will be to create highly available and cost efficient systems or architectures, and then ensuring that they are the most cost efficient, right? The second certification, that is the Certified Developer Certification, is for people who are from a development background, right? So if you are from a developer background, you might or you should apply for this certification, and because it tests you more in terms of the programming knowledge. That does not mean that you won't be tested on AWS. You will be tested on AWS, but with the programming also in mind, right? The next certification is the SysOps Administrator certification. So this basically certification is for people who are from a administration background, right? So if you're a Linux admin and you have been working since 2-3 years in the administration department, it makes sense for you to actually go for this certification. Now talking about the roles or the differences in the jobs that these 3 certifications are, let's discuss that. So on the top level, you have the Certified Solutions Architect, which actually get into interaction with the customer and understand their needs, right? Once you understand their needs, you actually come up with an architecture that is in line with the requirements that they have put through, right? And this is what the Certified Solutions Architect is all about. You might or might not implement that architecture because it is actually the job of the SysOps administrator, but usually when I see people, they actually implement it as well, right? So this is about the certification. Then you have the Certified Developer Certification. So this certification is actually for people or for developers who will be making their application on the AWS infrastructure, right? So solutions architect provides the developers with the infrastructure, and developers work on that infrastructure and make applications. The third certification is about the SysOps administrator. So this guy actually is responsible for maintaining the servers once they are made, right? So once solution architect has implemented whatever architecture is required, it is the job of the SysOps administrator to ensure that everything is running fine. This is the role of the SysOps administrator, and these certifications are the associate level certifications. If you want to go to the next level of certifications, the next level certifications are actually called the professional certifications, right? Now, the professional certifications can only be applied when you have a prior experience in the associate certification. For example, if you are a person who wants to become a professional certified in the solution architect role, you should actually be an associate certified in the solution architect role before. Similarly, if you are looking for going on to the next level, if you are a developer certified person, or you're a SysOps certified person, and you're looking on to go to the professional certification, you will actually become the DevOps engineer professional, right? So for DevOps engineer professional, the only two requirements are that you should already be solution architect associate certified person, or you should become SysOps administrator certified person. So these are actually the certifications which are offered by AWS. Like, moving on now, how will you prepare or how will you get certified? We now know what all certifications are offered by AWS, but how do you get certified? So for getting certified, you actually have to pass an exam which is conducted by AWS, right? Now, how can you actually register for that exam is like this. When you click here, you will reach the screen, right? And over here you have this option which says schedule an exam, right? So once you click on this, you can actually schedule a preferred date for you, and you can book a slot for your exam. So this is how you can actually apply for that exam. Now let's talk about a little more about the examination. So your exam, your associate level exam will be for $150, and if you want practice exams for by AWS actually, so for them the fees is $20, right? Similarly, for all the associate certifications, the fees is around $150, and for the practice exam it's $20, right? Now the next question which comes to your mind is what to study exactly for passing this exam, right? So for that, AWS has made your life a lot easier because AWS has a lot of services, guys. But then you should know which service to study exactly for a particular exam, right? So, and that actually has been provided by AWS as well. Let's talk about one certification as of now. Let's talk about the Certified Solutions Architect Associate certification. So this is the exam guide for this certification, guys. So basically they've divided the exam under 4 domains, right? You have designing highly scalable, cost efficient domain. You have implementation domain, data security domain, and troubleshooting domain. And they were also divided these domains in percentages. Like if you talk about the troubleshooting domain, the whole exam will have only 10% of questions which are related to troubleshooting. If you talk about the highly available cost efficient domain, the whole of 60% of your exam will actually be based on this domain. Now these are domains. Now how will you or what to learn in these domains is actually mentioned further. So under the domain 1, you have these many topics that you should be prepared for while you are preparing for your AWS exam. Similarly, for the implementation domain, you have these many topics. For data security, you have these many topics. And in the end, for disaster recovery, you have these many topics, right? So your study should actually be very focused. You should not study everything. Be smart, study what is important. And that is the reason, because most of you guys are working, right? And it becomes very difficult for you guys to actually take out time for these AWS exams. And that is the reason there are a lot of online trainers which are out there, or online companies, e-learning companies, which provide you with a course which is suitable for passing your certifications. Along with that, they also offer you hands-on practice, wherein they might give you an environment where you can practice all you want for that particular service. How to prepare for this certification? So like I said, you actually have to be very focused on what to study, right? Moving on, let's see how you can actually practice whatever you're learning. So AWS has this amazing free tier, guys. So under the free tier, you get 750 hours of free usage for your AWS account, right? You have some services which are there under the free tier. So let me quickly show you guys what all services are covered under the free tier. So the free tier is actually divided between two parts. One is called the non-expiring free tier and the other one is the introductory free tier. So the non-expiring free tier is where you get all these services for free for the whole of your lifetime until a certain threshold, right? If you talk about the introductory free tier, so these services are free for the first year, and for every month you get 750 hours of free usage of each of these services, right, for the first whole year. Now like I said, you have to have hands-on experience, right? So this is where AWS has been very generous and has actually given you this opportunity so that you can actually practice a lot on AWS using the free tier. So this is the way you prepare, guys. The other thing is, like I told you guys, there are a lot of e-learning companies which are out there that provide you with a structured training, right? Now this is typically how a structured training or a syllabus for your AWS exam would actually look like. So this actually is for a solutions architect exam. So our company offers courses for the AWS certifications, and this structured training is actually for your AWS solution architect role. Now, this training or this curriculum has actually been prepared based on the exam guide which has been given by the AWS, right? So similarly, so if you don't have the time to actually make your curriculum or understand what all has to be studied, why not go for a course wherein you'll have a certified instructor who will share his experience and teach you that how you can prepare for this certification. So guys, this brings us to the end of our today's session. So we have discussed all the certifications. I've told you guys what all exams are there, how you can prepare for those exams. And this is it, guys. So remember the part where I told you that don't prepare for these certifications just for the sake of preparing them. You have to be very thorough with all these services which are there in AWS which are relevant to your role in the certifications. And if you actually prepare very well for any of the certifications that you want to master, you will definitely end up with a job. Because if you see the job trends which are there for AWS, they are actually rocketing, right? And if you have very good knowledge in your subject, you can easily get a job. So on that note, let's finish off today's session. So thank you guys for attending today's session. I hope you learned something new today. I hope it made your doubts clear when it comes to certifications. So any kind of questions that you have, you can always email me. It is there in your LMS. And you can always reach out to our support team. They might be able to help you out in whatever query you have. All right. So, okay guys, so on that note, I'll be taking a leave for you guys. Thank you for attending today's session. Have a good day ahead. Goodbye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Today in this session, we'll be talking about the AWS Certified Solutions Architect role. So we'll be talking about quite a few things today. So let's move on to the agenda to see what is our session about. So we'll start off with what is AWS, and then we'll move on to whether you should use AWS or learn AWS. So this is basically the theoretical versus the practical approach. And obviously the practical approach is better. So after that, we'll move on to the problem statement. We'll be discussing a problem statement, and we'll see how we can solve it using the AWS infrastructure. But before you can start using the AWS infrastructure, you should have an AWS account. So I'll teach you guys how you can create an AWS account, and then how you can use the AWS free tier so that you don't get charged when you're using AWS or when you're practicing on AWS. After that, we'll be discussing the solution to the problem statement that we discussed, or the architecture. And then I will teach you guys how you can deploy that architecture on AWS, which is our demo part. Our next section is about AWS certifications. So we'll be talking about all the roles which are there in AWS certifications or which is offered by AWS. And then we'll move on to the role that you guys have applied for, which is the AWS Certified Solutions Architect role. We'll be discussing the topics which come in your exam when you apply for this role. And then we'll be talking about a structured training that you should follow or the learning path towards becoming a solution architect. So guys, this is our agenda for today. Are we clear with it? All right, I'm guessing yeses. So Jason says yes. John says yes. Neil says yes. All right, guys, so since most of you are saying yes, let's go ahead and start off with today's session. So our first topic for today is what is AWS? So AWS is a cloud services platform. So it's a platform on which Amazon provides you with cloud services. Now these cloud services are in the form of compute, it's in the form of database, it can be in the form of networking, storage, database, etc. Right? So you use all these services or all these domains to create your application, and this is what AWS is all about. Right? It's a cloud provider which gives you services which you can use to create your application. So guys, this is what AWS is all about. Do you have any doubt in what AWS deals in? All right, Jason says he's clear. John says he's clear. So does Neil, Maria. All right, guys. So let's move ahead. So let's move on to our next section, which talks about whether we should use AWS first or whether we should learn it first. All right. So it's basically the practical approach versus the theoretical approach. So let's shed some light onto that. So let us discuss something very general first. So let's talk about gravity. So when Newton first discovered gravity, did he straight away jumped onto the formula and then he learned gravity, or did he first saw the apple falling from the tree and then he thought, okay, maybe this is gravity, so let's see what gravity is all about, right? So this is what is our approach for today. We'll be seeing how AWS functions, or will be our approach throughout our journey. We'll be seeing the practical first, and then we'll be talking about the theory, so that you know when you learn a service that, okay, this is how the service functions. All right, so this is the way I think, this is the way I will be teaching you guys. So from the left side is all the theoretical, that is the theory about these services. So rather than telling you guys about, okay, Elastic Beanstalk or SES or SNS, okay, Elastic Beanstalk is a platform or SES is an emailing service, rather than telling you all that, I will first explain you the practical part. Okay, this is how Elastic Beanstalk functions, this is what it does, and then we'll move on to the definition of what Elastic Beanstalk is. So that should give you more clarity onto what AWS is all about, right? So this is the approach that we'll be following when we'll be learning, or when we'll be moving ahead in the sessions that we'll be following henceforth. All right. So let's move on to the next section, wherein we'll be talking about the problem statement. We'll see the problem statement and see how we can architect or solve it using AWS. So we have to create and host a website on AWS which dynamically adds backgrounds. All right, so we'll have a website and there will be a slideshow of background images going in, and we'll have the functionality to upload an image, and that image should be added to the queue which is being played in the slideshow in the background, right? So this is what our website is all about. And this website should be highly available and should also auto scale according to traffic. The website is pretty simple, but this is to give you guys an insight of how you can think when you're from an architect's point of view. So if you have this website, forget about the coding part, right? So that coding is already done. This is the website. Now you have to see what all components would you require when you have to host this kind of website. Okay, so Jason is asking me about the free tier. Jason, I'll be covering the free tier in a few moments. For now, we are discussing the problem statement, and after that, I'll be covering the free tier. Is that okay? Oh, you're asking about this website. Will it be free? Of course. So yes, whatever services that we'll be using today to deploy this project will be covered in AWS free tier. So don't worry, you will not be charged for deploying this website. So should I move ahead? So guys, are we clear with the problem statement, what we have to architect? All right. So Mayank says yes, Jason says yes, John is clear as well. Okay guys, so like I said, you have to think with an architect's mind, and analyze what all components would you require when you would be hosting this website on some infrastructure, right? So let's see the components. So first of all, you would be needing a server because obviously you have to host your website on something, right? So you'd be needing a server. And since you have to upload your images, those images should be hosted somewhere, right? It should be hosted on a file system. So you would be needing a file hosting service. And then you should also have the paths, as in your file is stored in a file system, right? So you should have that path stored somewhere. So for that, we'll be needing a database. So these are the three components that you would majorly need in hosting a website which has this kind of problem statement. So guys, do you have any more ideas that we should use, or do you have any doubts in why we are using these three services? So Jason is asking me what is a file hosting service. So Jason, you need a file system. Say in Windows, you have your hard drive, right? So on your hard drive, you have your Windows installed or you have your files. So your C drive, for example, is a file system. So basically NTFS is the file system, but C drive is the place where you're storing it, right? So similarly, your hard drive is basically serving you that file system. So what is that hard drive on the cloud? That hard drive is actually a cloud provider which is providing you with that service. So we need a cloud provider, and that is what a file hosting service is. So you need a cloud provider which will be giving you the file hosting, and so that service will be called the file hosting service. So Jason, are you clear with what a file hosting service is? Okay, so Jason has a question. What is the difference between a server and a file hosting service? Okay. So Jason, basically a server is just a computer. You don't have to get confused between a server and a computer as well. So a computer is a server, right? But when a computer is providing you with a service, it's a service, right? So if a computer is giving you a file hosting service, so if my computer, if you have a server installed in your company, on that server you can serve or you can install or you can save your files, right? So that server is actually providing you with a file hosting service. It is hosting your files for you, or it is storing your files for you. So on the cloud, when a cloud provider, a server is giving you a service in which you can save your files or you can host your files, that service is called a file hosting service. So Jason, are you clear now of what file hosting service is? Okay, so Mayank has a question. He's asking me, does the RDBMS reside on the same server? So no, Mayank, the whole point behind AWS is that your applications, they should be distributed. And that is the way it should be, because you don't want a single point of failure. So if you have your database as well as your file system on the same server, and if that server goes down, your file system and your database both will go down, right? And you don't want that. So you will have your database on a different server, you will have your file hosting service on a different server, and your website will be hosted on a different server as well. Now you can architect it in a way so that everything is on the same server, but that will be a bad practice. Now the best practice according to an architect, or since you guys are going to be an architect in the near future, you have to be very careful when you're designing applications so that your applications or your services are highly available. And you also have to make sure that each service or each server is redundant, so that even if one server goes down, you have a redundancy in place so that you can switch over to the other server so that your applications have been served. So that is the whole point behind distributed computing. So Mayank, are we clear why you should not have a RDBMS service on the same server? All right, Mayank says yes. Guys, any other questions related to these three components that we'll be requiring towards a website? All right, everybody is giving me a go. Okay, guys, so let's move ahead. So like I said, these are the three components that you'll be needing when you want your website to be created. So let's understand these services now, or these components now, in terms of AWS. So since now we understand these are the three components that we need, let's move on to see how these components can be related to AWS. So when we talk about a server, we'll actually be needing the Elastic Beanstalk service. When we talk about a file system, we'll be needing the service called S3, which is Simple Storage Service. It's an object-based file system. When we talk about database, we'll be talking about RDS in terms of AWS, which is a relational database service. Right? So let's understand these three services in detail now. So let's first talk about Elastic Beanstalk. So Elastic Beanstalk, it's a platform as a service which automatically configures your environment. Now, what it does is you basically upload your code or you specify what environment you need. Say, suppose your website is in PHP, all right? So you don't have to configure your server, or you don't have to install your PHP files and configure your firewall so that it becomes a web server. No, you don't have to do that. With Elastic Beanstalk in place, you just have to specify the environment, which is PHP, that you'd be requiring, and then you launch it. And when the environment is ready, you have an option to upload your code. You don't have the access to the operating system. You don't have the access to the firewall. You don't have the access to anything. All you can do is upload your code, or obviously you can change the configuration as well, whether you want a specific virtual private cloud or some other. But the point is, you upload your code and that is it. You don't have to configure your server now. Everything will be done automatically. Now, this Elastic Beanstalk service is actually deployed on another AWS service, which is EC2. Now, EC2 is a server wherein you have the access to the operating system, you have the access to the firewall, you have access to everything. Now, Elastic Beanstalk is an advanced version of that EC2 service, which has been automated, right? So if you have a PHP application, right, and you want it to be deployed, you would obviously deploy it on Elastic Beanstalk rather than on EC2. So when would you need EC2 for website hosting? You would need EC2 for website hosting when you have an application or you have an environment which is not listed in Elastic Beanstalk. All right. So this is the difference between Elastic Beanstalk and EC2. So we're not talking about EC2, but I wanted you guys to know that Elastic Beanstalk is an automated version of EC2. All right. So I have a question. Let's see. So Jason has a question, which database we will be using. Okay, Jason, so we'll be using a relational database since we are storing just paths. We don't need a NoSQL database for that. So we'll be storing the paths to our pictures that we'll be using in the backgrounds of our website, all right? So for that, the use case is perfect for a relational database. And then when we talk about what database, so I am using MySQL. We can use any relational database. But since MySQL is more accepted and you guys maybe can relate to it, I've selected MySQL. All right. So guys, any other question? Any question related to Elastic Beanstalk that we just discussed? Okay. So I have a question. So this question is from John. So John is asking me, which database are we using? So John, we'll be using MySQL for our website. Now MySQL is a relational database, and as you can see, I'm using a relational database service. So why are we using a relational database? We are using a relational database because we are only saving the locations to our images that we are showing in our background, right? So when you show locations, for that we don't need a non-relational database or NoSQL for that matter. So we can store that in a MySQL since it can be represented in the form of a table, right? So for that we are using the relational database, and I'm using the MySQL server because it's pretty simple, it's easy to use, and I have already coded it, right? So that is the reason we are using the MySQL. Any question related to Elastic Beanstalk? All right, John says all clear. Jason is clear as well. Mayank says please move ahead. Okay guys, so since we're clear, let's move on to our next service, which is the S3. So S3 is a file system. It's an object-oriented file system. So whatever file that you upload on S3 is treated as an object. Now, when we'll be uploading our images, these images will be stored over here on the S3 service. All right. So this is all about file system. There is nothing new to how you can store your images. But with S3, your files are treated as objects, but that doesn't change how your file is actually executed. It is the same. Our next service is RDS, which is a relational database service. So it is not a database. First of all, it's a database service. So it is a management service. So it basically manages your relational databases, right? Since there are around 5 databases under RDS, we'll be using MySQL. Now, how does it manage your database? It will do all the manual tasks that you used to do before automated database management servers. The first task could be maybe automatic rollbacking, right? Applying your security patches or updating your database engine. So all these tasks can be done automatically, and it can be done using RDS. So in RDS, we are using MySQL. So like I said, MySQL is a relational database. So we are using our relational database to store paths to our images. So we'll be using MySQL to store the paths to our images, which will be fetched by our website to show the images in the background. All right, so this is what RDS is all about. So we have a question. Okay, this question is from Atul. So he is asking me, can we use the Aurora service in RDS instead of MySQL? Okay, Atul, first of all, I'm impressed that you know about AWS. So Aurora service, like Atul pointed out, can also be used over here. So Aurora service is a database. So it's basically a database which has been created by Amazon, and it works exactly as MySQL. So it uses the same language as MySQL, but it is 5 times faster than what MySQL is, even under AWS. Right? But why are we not using Aurora, or why didn't I use Aurora, is because I wanted it to be simple. Because since it's your first session, guys, you are pretty new to AWS, so it should be kept as simple as possible. And since this is the first practical that you guys are seeing, we are using MySQL. I wanted to use services that are more familiar to you. But good to know, Atul, you know about Aurora, and like I said, you can use Aurora as well. It will be actually better to use Aurora because it is faster than MySQL. Right, Atul is clear? Any other question, guys? Okay, so let's move ahead. So let's start using AWS now. So we have learned about all the services. We now know what services we are going to use in our project. Let's start with AWS. But before that, you should have an account. You cannot proceed without an account. You should create an account in AWS first, and then you'll be able to access the services which are there in AWS. So let me teach you guys how to create an account. So first of all, you have to go to this link, which is aws.amazon.com. All right. After that, you'll be prompted with the screen, and you have to click on create an AWS account. Once you do that, you will reach this screen. So now over here, the step 1 is clicking on I am a new user. Step 2 is putting in your email address. And step 3 is then clicking on signing using a secure server. Now this page is used to log in as well. So for a new user, you have to select this option. Like I said, I am a new user, put in your email address. This password field will be disabled. You don't have to put anything, don't worry. And then click on sign in using a secure server. All right. In the next screen, you will be asked for your login credentials. So you have to enter your name, your email address, and then you'll be asked for the password. Type it, confirm your password, and click on create account. On the next screen, you have to enter your address. So you'll be entering your address, you'll be putting in the captcha number, your phone number, and you'll be clicking on create account and continue after agreeing to all the terms and conditions. After that, you'll be prompted to enter your credit or debit card. So why would you need your credit or debit card? Because this is the way you get charged. So if you have a credit card attached to your AWS account, you will be automatically be debited. If you have a debit card attached to your account, you will be presented with a bill, and you can pay it using the same debit card that you're attaching here. All right, so you'll be prompted for the details of your debit card or your credit card. You can click in and then click on verify card and continue. So Jason is asking me, are we not using free tier? Jason, yes, we are using the free tier, but then let me reach the free tier, Jason, and then I'll address your question. You have to enter your card details anyways, because if you are not, since free tier is all about some limitations, all right? So if you have a service, so that service can be used under the free tier up till a certain extent. If you cross that extent, you will be charged for it, all right? And AWS is a business, they have to earn money, right? So at some point of time, or after your training is over, once you become a solution architect, you have to use your account, all right? So you won't be entering your card details later, you have to enter your card details now. But don't worry, I will teach you guys how to use the free tier, and you will not be charged. Your card will not be charged. You can enter your card details without worrying about anything. All right, Jason, are we clear? Okay. So like I said, you'll be entering your card details, and then you'll be clicking on verify card and continue. In the next step, you'll be asked to verify a number. So you have to enter your number, clear the security check, and then you will be getting a call. All right, so you have to click on call me now. You'll get a call, and then you have to enter a code, enter the OTP. So it's kind of an OTP that you have to enter. It's a one-time password. You enter that, and then they'll be able to verify your phone number. And once you do that, the next step is about choosing your plan. So these are the plans. You have the basic, the developer, the business plan. So the business plan is basically used when you're using AWS for your prod environment, when you have your business website hosted on AWS, or maybe you have an application which is deployed on AWS. So when you have all of this, you would obviously be needing the support from AWS. So if you run into any problems, you want it to be immediately solved, right? So you'll have access to 24/7 support from AWS, but only under the business plan. If you choose the developer plan, you will again have the access to the support, but the response time would be more. Now, what is the difference between the developer plan and the business plan? It's basically the rates. So if you pay more, you'll have more access to the support. But if you pay less, you'll have a slower service from the support. But we will be choosing even the cheaper plan, which is the basic plan. So the basic plan is basically for personal use, for practicing, right? So we chose the basic plan, and since you guys have to practice, you can choose a basic plan. You can change a plan later by calling AWS, but for now, since we have to practice, we'll be choosing the basic plan. Once you choose your plan, the next screen is this, which confirms that you have been registered. So your registration has been completed. You can now sign in and come on to the AWS dashboard. So Jason, now for you, we are moving on to the AWS free tier. All right, so let's understand the free tier. The free tier is basically divided between the non-expiring part and the introductory free tier. All right, so the non-expiring part of the free tier is basically that doesn't expire. It is there for your lifetime. So services like SES, Lambda, DynamoDB, and CloudWatch to an extent can be used every month for free. All right, and this validity for these services are there for a lifetime. So the introductory feature is basically valid for 1 year from the time you have registered. So since you just registered, right? Considering you just registered, from today till the 1 year when it completes, you will have these many services, which is the RDS, EC2, S3, and CloudFront for free. Now, you cannot use these services as a whole for free. You have some limitations on them. Say like in EC2, you can only use 750 hours every month, and that too only for the T2.micro instance. When we talk about RDS, again, we have the db.t2.micro instance on which the free tier is applicable. So likewise, and when we talk about S3, in S3 you have 5 GB of free space. After 5 GB you'll be charged. Right, so this is the introductory free tier, and the services that we are using today are S3, RDS, and EC2. So we are using Elastic Beanstalk, but like I told you, it's basically EC2 but automated EC2. All right. So if you have 750 hours of usage for free in EC2, you'll have 750 hours of usage for free on Elastic Beanstalk as well. When we talk about RDS, if you're choosing the db.t2.micro instance, you are in for a treat. You don't have to pay anything. Again, if you're using S3, the file system, if you are well below 5 GB of the space that you're using, you won't be charged. So Jason, your card won't be charged if you follow these rules for free tier. So Jason, are we clear now that our website won't be charged if we host it on AWS? All right, guys, any other person, John, Mayank, any question that you have, Atul, others that you feel that should be asked over here, any service that you're not clear in the free tier, any confusion using the free tier? Okay, Mayank is clear. So is Jason, John, Atul, Maria. Okay, since most of you are clear and I'm getting a confirmation, let's move ahead in today's session. Okay, so it's my favorite part, the demo. So now we'll be actually seeing AWS in action. But before that, let's see what all we'll be doing in our demo today. So guys, this is the architecture for the problem that we discussed. So let's do a recap. We had to create a website that will have background images rolling, and we have to dynamically add more backgrounds from the same page, right? So this was our use case. Now I told you we need a server, we need a database, and we need a file hosting service. That server is Elastic Beanstalk for hosting a website. That file system is S3, where you'll be storing your images, and that database is RDS service, wherein you'll be storing your paths to the images that you are rolling on your background. All right. Now this is the architecture. Now a user, when he'll be accessing the website, is actually accessing Elastic Beanstalk. Now on the Elastic Beanstalk, you have your code. Your code is interacting with the file system and your RDS service. All right. So this is the architecture, guys. Any doubt in how the interaction is happening? Okay, so Jason says no question. John says no questions. Atul says all clear. Mayank is clear as well. Okay, so let's move ahead then. So let's see what all steps we'll be doing when we'll be performing a demo. So first off, we'll be launching our Elastic Beanstalk environment. All right, so Atul again has a question. Are you going to show migration here? Yes, Atul, we'll be showing migration. So basically, I'll be showing my website to you guys on localhost first. So MySQL and my website is hosted on the localhost as of now. So I'll be showing you guys how my website is functioning on localhost. And then I will move that data from my MySQL server or my MySQL local client to the RDS. So I'll be transferring my data from the MySQL instance to the RDS server on AWS. So basically we are migrating our data, all right? And then also we are migrating our website from a local host to the Elastic Beanstalk environment. So yes, kind of we are doing migration here. Okay. So first we'll be launching an Elastic Beanstalk environment. So once we have launched Elastic Beanstalk environment, then we'll launch the MySQL instance in the RDS service. Then we'll be creating the required bucket in S3. So bucket is basically the folder wherein our images will be stored. So I have specified a bucket or I have specified a particular name in my code wherein it will be interacting for storing my images. All right, so we'll be putting in that name in S3 and then we'll be uploading our code to Elastic Beanstalk. So these are the steps that we're going to do. So let's go to step 1 first, which is launching an Elastic Beanstalk environment. So let us go to our AWS management console. So it is aws.amazon.com. When you reach this page, click on sign into the console. Now under the compute section, you will find Elastic Beanstalk. Now since we want to create a new application, we'll click on create new application. Now you have to give an application name. So let's give it the name as website-background. All right. And then click on next. Now since ours is a web server, we'll be clicking on create a web server. Now like I told you, we'll be asked to select a platform. So our website is in PHP, so we'll be selecting the PHP platform. And since we want our website to be highly available and scalable, we have to have the auto scaling and load balancing enabled. What is auto scaling? What is load balancing? Don't worry, we'll be covering in our further modules. For now, let's just understand for getting a website to be highly available and scalable, we have to select auto scaling and load balancing. All right. Once you have selected all of this, we'll click on next. Now it is asking me select a source for your application version. So this is where you'll be uploading your code, but we can do that later as well. So let it be at sample application as of now. Then this is the deployment preferences. This is related to AWS. Don't worry about anything. Just change this to 100 and click on next. Now this will be the URL to your website. All right, so it has a default one as of now. So let us use the default one and first check its availability. So yes, if it's green, it means it is available. So my website URL is available. So let me block this URL. So that URL is now registered to me. Now I want my Elastic Beanstalk to interact with the database, right? So since we wanted to interact with the database, which will be there in AWS as well, we have to create our application inside a VPC, all right? If you don't understand what a VPC is a virtual private cloud. A virtual private cloud is used when you want two AWS services to interact with each other. If you don't understand even now as well, don't worry. In further modules, we have a whole module on VPC, all right? So any doubts of yours will be clear over there. For now, just click on create this environment inside a VPC and click on next. Now we have to click on t2.micro, which is the free tier instance, right? If you select t2.micro, you will not be charged JSON, but if you select some other instance, you will be charged, all right? Don't blame me afterwards. I told you it should be t2.micro. Then everything else has to be kept on default. Don't touch anything. Click on next. The environment tags are not to be touched. Click on next. Now we'll be selecting the VPC, all right? So now remember guys, your VPC that you're selecting here and the VPC that will be associated with your RDS should be the same, all right? So remember the VPC that you're selecting In my case, I'm selecting the VPC, which is 82A7. So I remember this while launching my RDS service. Now the subnets, when it comes to the subnets, select all the subnets. And then the security group is 91191BB. Okay. Click on next. No need to change anything over here. Click on next. Now you'll be prompted with the screen wherein you'll be reviewing all the information which you just entered. All right. So everything seems fine to me. Let's click on launch. Now this will take some time to deploy. All right. So until it is deploying, let us go back to our screen and see what is step 2. Alright guys, so first step 1 is complete launching an Elastic Beanstalk environment. Step 2 is launch a MySQL instance in RDS. So let us do that. Let us come back to our management console and launch an RDS service. So this is RDS. Click on RDS. So we'll click on get started now. You'll be prompted with this screen. So RDS, like I told you guys, it is a management service. So it manages all these databases. You have Microsoft SQL Server, you have Oracle, you have PostgreSQL, you have MariaDB, you have MySQL, and like Atul pointed out, we have Amazon Aurora as well. All right. For our use case, we will be using MySQL. So as you can see, it is free tier eligible. We'll click on select. And yes, Atul, one more reason why we are using MySQL is because it is in free tier. So JSON would have a problem if we don't use the free tier. So MySQL free tier, hence we're using it. Click on select. Then we have an option between selecting the prod environment and the test environment. Since it's a demo, choose the test environment and click on next step. Now over here you have to select the instance class. So the instance class is t2.micro. This is again free tier eligible. Select that. Don't select any other service or any other instance. Now multi-AZ deployment, click on no. This is basically used when you want replication to be done, but since it's our demo, we don't want that. Click on multi-AZ deployment as no. And then just everything, leave it at default. And let's come to the settings now. So what do you want your instance to be called? Let us name it as Edureka demo. All right. We want our username to be Edureka. Let us fit in the password. Okay, so everything is done. Let's click on the next step. Okay, so we are now prompted with the VPC. So like I told you guys, you have to select the same VPC as was in your Elastic Beanstalk. So our VPC over there was 82A7. We'll select this. All right, and then select the security group. In your case, it will be only one. In my case, I have 2 deployed. So I'll select this one. Give the database name. So my database name is Edureka. Then the parameter groups. Okay. Nothing to be changed here. Nothing to be changed here as well. Okay. Now I'm done with all the settings. So I click on launch DB instance. Okay. So it says my DB instance is being created. It will again take a while. So we'll click on view your DB instances. And as I can see, this is my instance which is being created. So I named it as Edureka demo. So it's showing me that. Now it says status is creating. So let's leave it for some while and go back to our slide and see what is step 3. So our step 3 is creating a bucket in S3. So it is actually the bucket that we want to be named it. We want it to be named a specific name because we have coded it in such a way. All right, so let's go back to S3. We'll go to the AWS Management Console. Go under storage. Yes, storage is here. Click on S3. All right, so this is our S3 Management Console. Now we have to create a bucket here which will be called Edureka demo. So let's do that. We'll right click here and click on create bucket. Now the bucket name should be Edureka-demo, and then we'll click on create. So a bucket has been successfully been created. So this is it, nothing else to be configured here. Let's go back to our slide. Let's see what is step 4. So our step 4 is to upload the code in Elastic Beanstalk. Let's go back. Let's check what is the status of our instances. So our Elastic Beanstalk is ready. Our RDS is still not ready, so let us give it time. And our S3 is ready. So let me show you guys the website that we'll be deploying. So guys, this is our website. Now this is the default image. If you don't have any image in your bucket, you will be prompted with this image. But as soon as you enter an image, say suppose I want tulips to be there, I click on open and click on upload image, and it will prompt me with this screen which says S3 upload complete, and my image will come in the background. It is a heavy image, hence it is taking time to load. So while it is loading, let me go back to my management console, and now whatever image I uploaded over here should be visible in this bucket, which is the Edureka demo. So let's check. So yes, there's a file. Let's click on this file and see if it's the file that we uploaded. Right. Meanwhile, my image is loaded over here. So as you can see, my tulips file has been uploaded in the background. But since it's only one image as of now, that is why we are not seeing a slideshow. I'll upload one more image, and then you can see the backgrounds change. I've set it to 3 seconds, so it'll change in every 3 seconds. All right, so our image is now complete. Okay, so this is the image that is there in S3 bucket, and this is the image that we uploaded, right? So my website is working as of now. So let's upload one more image. So let us upload penguins. Click on open, click on upload image. Okay, so it says S3 upload complete again. So my background has been updated, and as you can see, a slideshow is happening. Penguins is taking time to load because it's again heavy and my net is slow. But then as you can see, the website is working all fine. So meanwhile, while it is loading, I'll show you the bucket. We'll refresh the Edureka demo bucket, and you will be able to see that now there are 2 files over there. So as you can see, there are now 2 images over here, and these 2 images are actually the backgrounds which are being changed over here. So it's tulips and then it's penguins. So as and when you upload more images, you'll have more images in the slideshow. So this is my website, guys, so it is working fine. Now the task is to upload this website and deploy it in AWS. So as of now, my images are hosted in S3. Now the paths to these images are actually going into my localhost MySQL, which is over here. So I will show you. So my database name is Edureka, and my table name is image. So as you can see, there are 2 entries. So these 2 entries are actually the image names which have been uploaded in S3. So let us check. The first name is 14886318081. So it's 14886318081, right? This matches with this. Our next image is 148863090. 148863090. All right, so these 2 names match, and this is where the path is fetched from. The link is fixed. So basically what we are doing in our code is we are appending this name to the link of the file system, and hence the website is fetching the images in the background. All right, so this is how it is happening. Now the task is to first deploy or migrate this database to RDS, right? And then migrating this website to AWS. So let us do that. Okay, to connect to your RDS, you will be copying this endpoint. So you click on copy, and then you will go to your command prompt. And now you have to go to the bin directory of your MySQL installation, which is, for me, my installation directory is in BAM64. So I will be going over there. So it's cd c bam64 -bin, right? Then I'll cd MySQL. Alright, so my MySQL installation is over here. So now the command is MySQL-h followed by the endpoint. So h is basically the host name, -P, which is the port number. So you'll be deleting the port number from the endpoint that you have entered in your MySQL, right? Enter the endpoint, delete the port number, enter the port number separately, and before that you have to enter the tag as -P, then -U, which is the username, which is Edureka, and then -P, which is the password. Click and enter. It will be ask you for the enter password line, and then you will enter your password. Okay, so you have successfully connected to your MySQL instance. So let us see what all databases are there. So we'll see show databases. So as you can see, there's a database called Edureka. Now this is the database that I'll be using. So as of now, there are no tables in this database. Let me show you guys. So show tables, it says an empty set, right? So now I have to migrate my database from a local host to this RDS instance, right? So for now, let's do exit from RDS, and then we'll be creating a file for our database. So we'll be dumping a file. So the command is mysql dump -h localhost -u, which is the root, -p, hit enter. Alright, it's a spelling error. Let me do it again. -p, and then which database do you want to export? So it's Edureka. And what is the file that you want it to be exported to? So let us call it Edureka demo, right? Edureka-demo.sql. So .sql is the extension to the database file. Hit enter. It'll take around 2-3 seconds, and then your export will be completed. So my database in localhost, which was Edureka, has now been transferred to edureka-demo.sql. All right. So now let me migrate this file to RDS. So for that, you will go with the same command, which is mysql -h followed by the host name, which is the endpoint, -p3306, port number, -u Edureka username, -p, that is the password. Now what is the database name over there, which is Edureka. I want the file to be imported, so it's the less than sign. And then the file name that I want to export is Edureka demo-demo.sql. Hit enter. It'll ask you for the password. Enter the password and then hit enter. It'll take around 4-5 seconds for your file to be uploaded to the RDS servers. Once it's done, your database will be successfully migrated to the RDS infrastructure. Alright, so since there are no errors, I got prompted with a blank line. Now my database is uploaded, so let's check. Let's connect to our RDS again. Enter password. It's Edureka123. Alright, I got into my RDS. Let's use the database, which is use Edureka. Let's see if there are any tables here. Show tables. So yes, I have a table called image. Let's check if there is data in this table. So yes, I have the 2 entries which were there in my MySQL localhost. So this is my localhost window. This is my RDS window. So in my localhost window, as you can see, there are 2 records. I migrated this database, and as you can see in my RDS, there are 2 records. So they are the same records. So my RDS is now ready with all the records which were there in my localhost MySQL. Alright, so let us exit RDS and now configure our code to interact with RDS. Well, let me open my code. So it's index file. So this is my index file. Now I have to change the host name here from localhost to this. So I'll open the code. Change the host name from localhost to my RDS service. Username is Edureka and the password is Edureka123. Right? Again, over here I'm using alright, everything's set. My index file is ready. So let's check if my website on localhost is interacting with the database from RDS. So we'll refresh this. And if you can see the images in the background, that means the paths are being fetched from RDS. So it'll take a while and it executed successfully. So that means my RDS is working fine now. So this is basically the index file in test 1. As you can see, It's test1 slash index.php, and this is test1. So basically your index file is fetched if you're directing it to the folder, but to be double sure, I'll enter the address, hit and refresh, and I get prompted with the same screen, and my images are changing. That means I'm getting the file's path is being fetched from RDS. All right. So the only thing left now is uploading this website on Elastic Beanstalk. So let's do that. So this is Elastic Beanstalk console. All right. We have to upload our code here. Now, how do you upload your code to Elastic Beanstalk? So it is like this. You go to the file, right? You zip everything. So before zipping, guys, since ours is Windows, so we have the path different, right? So there are some APIs which will be required in this code. So I'll be putting on the documentation, but when you're uploading your code to a different operating system, so since in our Elastic Beanstalk environment, the Amazon Linux is running, right? So you have a different paths to the files, or the different paths to the way your files will be accessed. Like for example, in our Windows, if I have to go to images 6, so I have a default image that it was going to, right? So it is in the folder, or it is in the root directory images slash 6.jpg. Now for going to the root directory in Linux, the way is like this. So it's var slash app slash current and slash. So this is the path to the root directory, and hence this should be used when you are uploading your code to the Linux environment. All right. Now let us enter the same address in our other files as well. So I require APIs, right? So my APIs are here. So this is the PHP code that I'm calling. So basically, when you have to connect to S3, you have to include some APIs. Don't worry, you don't have to worry about all these things. This all is covered in the documentation. So we'll be entering this address, saving it, and that is it. Nothing else is required. Save it, and now our code is ready to be uploaded. So now our index file has been updated. So we'll zip all these files and we'll name it something. So let's name it as edureka-demo, right? So this is the file that now you'll be uploading to your Elastic Beanstalk. So we will copy this file and store it to a location which is maybe easier to access. So we'll store it in C, right? So it's in C, Edureka demo. So we'll go to our AWS Management Console, go to Elastic Beanstalk dashboard, and then click on upload and deploy. Choose file, go to computer, go to C, Edureka demo, click on open. Okay, so now my code can be deployed. So let's click on deploy. Alright, so my Elastic Beanstalk says green now, so it is green, it is ready to be accessed. My code has been uploaded, which is a Edureka demo. So let me click on the URL and check if my website is working. So yes, my website is working and my backgrounds are changing as well. Awesome, so my website has now been successfully deployed on AWS Elastic Beanstalk as well. So let us check and upload an image and see if everything is working fine. So let's go to pictures and upload the lighthouse picture and click on open, click on upload image. So it says S3 upload complete. Let us see if it is reflected in my background as well. All right, it is still loading. So as you can see, I can see the lighthouse image in the background. That means my code is working fine. My images have now been uploaded to RDS. So according to this, there should be 3 records in my RDS, right? So let us check if I can see there are 3 images in my RDS. So it's CMD. Alright, I'm in my RDS. So let's use Edureka. Select star from image. So now we should have 3 records. So yes, we have 3 records in RDS. Let's check if my localhost dependency is gone. Obviously it should be gone, but let's be double sure. Hit enter. So it should have 2 records. So see, there are no records being updated in my localhost MySQL. So this database is not being used now. My RDS database is now being used. So my website has been successfully migrated from my localhost database to the RDS server, and from my localhost server, my website has now been deployed in the Elastic Beanstalk environment, right? So this was the demo, guys. We have done the demo. The code will be there in your LMS. You can play around with that code and come up with something even more interesting. Let's go back to today's session now. So we first deployed an Elastic Beanstalk environment. Then we launched the RDS instance. We created the bucket in S3, and then we upload the code to Elastic Beanstalk, and everything is working fine. All right. So this was the demo, guys. Let's move to the next section of today's session, which is AWS certifications. All right. Now, there are many kind of certifications offered by AWS, namely the AWS Certified Solutions Architect Associate, which is the role that you guys have applied for. Then we have the Certified Developer, we have the Certified SysOps Administrator, the Certified Solutions Architect Professional, which is the next level to the associate certifications. And then we have the Certified DevOps Engineer Professional certification as well. So our focus today is the AWS Certified Solutions Architect Associate. So let's keep our focus on that and move ahead. So our Association Solutions Architect Associate certification is all about architecture. It's about architecting solutions to problems. So basically your users will come up to you and say, we have this use case. So you have to come up with a solution in terms of AWS and serve them. All right. So let's see what all requirements are there when you have to crack the exam or when you want to become a solution architect. So guys, this is the exam blueprint. So our exam overview is like this. So you will have MCQs and you will have 80 minutes to complete your exam, and your exam will be available in English, Japanese, Korean and Portuguese, and your practice examination fee is $20 and your registration fee is $150. So if you have to practice your exam, you can do that. That practice exam will come from AWS and will be charged at $20 for you. And if you want to register for the exam and you want to give the main exam, that main exam is for $150. All right. Now these are the 4 domains that you have to prepare in. So first of all, you should be able to design highly scalable, cost-efficient, fault-tolerant, and scalable systems. So as a solution architect, you are expected to create highly available, cost-efficient, fault-tolerant, and scalable system. And that is the reason 60% of your exam will be based on this domain. The next domain is implementation and deployment. So basically what all you have architected, you have to implement it in terms of AWS services, and you have to deploy it on the AWS infrastructure. Like we just deployed a website on AWS infrastructure, right? So in the same way, you also have to deploy it. And so that section of the exam is 10%. Then we have the data security domain. So the data security domain is 20%. So all the security related features, the best practices, everything will come under this domain, and it covers 20% of your exam. And then comes the troubleshooting part. So you'll have problems related to troubleshooting. You'll be presented with some scenarios that you have to troubleshoot, and that will comprise of 10% of your exam, right? So that, guys, this is the blueprint, and this has been taken from the official AWS website. And this is the official blueprint that is there on the AWS website. All right. Now let's discuss these domains in detail. So the first domain, like I said, it's creating highly available, cost-efficient, fault-tolerant, and scalable systems. So it comprises of monitor and logging, how to design cloud services, planning and designing, best practices, developing to client specifications, scalability, trade-off decisions. So trade-off decisions would be to use MySQL instance on the same server as your website server or to use it separately, right? So these decisions you have to take. So if you are creating a website which has to be highly scalable, it is better to have the database separated with the website server, right? Then we have hybrid IT architectures, which includes connecting your private data center to the AWS infrastructure. So these architectures are called hybrid IT architecture. So how to create all of those, and question on these, all of this will be asked in this domain, which is designing highly available, cost efficient, fault tolerant, and scalable systems. The next domain is implementation and deployment. So you'll be asked questions on configuring an AMI, operate and extend service management, configure IAM, launching service in AWS infrastructure. So implementation is, like I said, launching services. You should be able to launch services in AWS. So your questions will be around how you can launch services, or which part of your service or which part of your setting up the instance will comprise of the VPC, the storage part, everything else, right? So this will include your launch services in the AWS infrastructure. Then configuring services to support compliance requirements. So if there's an application and it has certain requirements, you have to configure your instance according to that, right? So you should be able to do that as well. Now you have to identify various techniques and methods that can be used to solve your use case using various services. Now these services would include, like over here we have pointed out, EC2, S3, Elastic Beanstalk, CloudFormation, Opsworks, VPC, and IAM. So these are all the important services that you should be focusing on when you are preparing for your exam, right? The next domain is the data security domain, which would include the CloudWatch logs. So it's a cloud monitoring tool. So when it monitors, it also generates logs, so, right? So when it comes to data security, you should be able to implement these logs because these come under data security. So basically you have to follow all the best practices for security, right? Then you have AWS CloudTrail, which is nothing but a logging service, right? So all the API calls that you make to your services can be all logged, and these logs are actually created by AWS CloudTrail. Then you have to follow the shared responsibility model. You should also have the denial of service mitigation tactics. You should be aware of those. Then you should have encryption solutions. Trusted Advisor is a service by AWS, which is basically like a personal assistant to you in the AWS world. You should be familiar with VPC, IAM, and all these services, right? So this all is included in the data security module. Next up in the data security module, you should be also able to create disaster recovery techniques. So for that, you have services like Storage Gateway, you have Snowball, Route 53, and data recovery methods. Now, data recovery, disaster recovery could include recovery time objective, recovery point objective, and elastic block store. So you should be aware of all of these 3 points. Then comes troubleshooting. So troubleshooting is basically when you're prompted with problems, you should be able to solve them, all right? So how you can do them? You can do that when you have an in-depth knowledge of all these services, and that can only be gained when you're familiar with the hands-on part for that service, all right? So troubleshooting can include from if your EC2 or the Elastic Beanstalk is not able to connect to your RDS, right? So what could be the problems? So basically here the problem could be that your VPC is not configured in a way so that these services can interact, or that your security group is not configured in a way that your services can interact. So all of this just comes not by reading the book, not by attending the sessions, but by actually practicing it, all right? So this is the troubleshooting part. Then, so this was the blueprint, guys. Then comes the required skills. So what all skills you require if you want to become a solutions architect? So basically, if you want to become a solutions architect, you should have one or more hands-on experience designing available and cost-efficient fault-tolerant systems on AWS. So don't worry, guys, this is the requirements that AWS expects from you. So AWS expects that you'd be able to learn AWS when you have hands-on experience. But since you are attending this training session, we'll be briefing you up quickly, and we'll be giving you live projects that you'll be doing, and it'll be equivalent to you having 1 or 2 years of experience on AWS, all right? Then comes in-depth knowledge of one high-level programming language. This again is not required, but then learning a programming language is not that tough. Your job would be to implement and deploy services. Your job would be to design highly scalable environments. So even if you are not familiar with programming languages, it is okay. Then you should be able to identify and define requirements for an AWS based application. So if there's an application which has come in from a user, so you should be able to identify it in terms of AWS services. Also, it is a plus point if you have experience with deploying hybrid systems. It is again okay if you don't have that. You can always learn it, all right? And we will be covering it on training sessions as well. And then the capability to provide best practices. So yes, like I said, I'm telling you guys again and again, I'm speaking it again and again. Best practices are very important because that is what distinguishes you from some other solution architect, right? So if there are two solution architects, they have all passed the exam, they all know the services. But who is following the best practices is what differentiates you from the other guy, right? So you have to know the best practices and you have to follow the best practices if you want to become a better solution architect than others, all right? Let's talk about the job trends now. So does it make sense for you to become a solution architect, all right? So as you can see, from 2012 to 2017, now today, the job trends or the job has been growing, and this data has been actually taken from indeed.com, right? So as you can see, the graph is going up and it will continue to grow up as in the near future as well, because the cloud industry is expanding. And as you know that AWS is the leader among the cloud providers. So the AWS market will grow as well. And if the AWS market grows, the requirement for your solution architect will grow as well. All right. So this graph will go up in the near future as well. So Mayank has a question. He's asking me what is IAM. Sorry, Mayank, I ignored your question. Maybe I can see it. So IAM basically is identification and authentication management. So using this service, you can manage the employees who are using your AWS account. So basically, if you are running a business, right, and you have hired some people who are working in AWS, and you don't want to give them the root access. If, for example, you want one employee to just maybe able to review the instances that are already launched. You don't want them to be able to edit the instances or delete instances or launch new instances. So basically, you are giving them rights, right? So you can do that using the IAM tool. So you can authenticate them and to a certain level of permissions, and they'll be limited to those permissions. They cannot exceed that, right? So this is what IAM is all about. But don't worry, IAM is a topic which we'll be covering in a module which has a separate module for it. But then this is what IAM is. There are further details that we'll be learning later. So Mayank, are you clear? Okay, let's move ahead. So let's talk about the structured training part now. So like I said, you have to follow a structured training because the syllabus is huge, right? But then you have to know what exactly to study if you want to crack the exam. You cannot study everything and become, maybe spend 2 or 3 years to become a solution architect. People do that in months. People do that in 3 or 4 months, right? And for that, you have to follow a structured training. So in our company, for example, we give the following training. We first give an introduction with AWS. So this is basically the introduction that we just gave you guys. And then we move on to the specific services. So we move on to EC2 first. So we'll just talk about EC2 and then we'll see the different scenarios in which you will be using EC2 and not other services. Then we'll move on to the storage services and the AWS CLI, which is our third module. Our fourth module will talk about the virtual private cloud and direct connect. So these are networking services. Our fifth module will include the database services. So it will include services like RDS, which we just discussed today. It will include services like DynamoDB. It will include services like Amazon Aurora, which is actually a database. So we'll be talking about all of that in the database module. Then comes the ELB and the order scaling module. So this ELB and order scaling is basically the high availability and a highly scalable part, right? So there's a whole module for that. So we'll be teaching you guys ELB and order scaling in detail. Then comes Route 53 and management tools. So Route 53 is basically a domain name system. A domain name system is used when you want to redirect your traffic from a website name to this particular server where your website is hosted, right? So this redirection happens with Route 53. And then you have management tools as well. So that includes CloudTrail, then you have the cloud monitoring tool, which is CloudWatch. So all of that is included in this. Then you have application services, which is Lambda and Elastic Beanstalk. So we use Elastic Beanstalk today, which, like I told you guys, is an advanced version to Amazon EC2, right? Then there's one more service called Lambda, which we'll be discussing in this module, which is the 8th module. In the 9th module, we'll come on to services like OpsWorks and the security domain, which is there in AWS. So OpsWorks is a configuration management tool. So we'll be discussing that in detail in the 9th module. And the 10th module talks about the mock tests and the doubt clearing sessions. It will also include the AWS white papers and the best practices. So all of that will be taught to you in the 10th module. And any kind of doubts that you have or anything that you didn't understand can be asked in this module. And once you are cleared with everything, you're confident enough, we'll give you a mock test which you can attempt and you'll be awarded marks. And whatever marks you get, guys, you can estimate that it can be plus minus 10 or 20%. It cannot be below or above that. All right, so that is what you'll be getting in your AWS exam as well. So this is the structured training that we'll be following in our training sessions. Okay, guys, so any questions related to whatever we have covered so far? So this brings us to the end of our today's session. Any questions are welcome. Any part you didn't understand, guys? Okay, Jason says no questions. Mayank says all well. Okay, since you guys have no questions, I'm moving ahead. So let's recap what all we studied today. So first off, we discussed what is AWS, and then we discussed whether we should follow the theoretical approach or the practical approach towards AWS. Then I taught you guys how to create an AWS account, and followed by a demo wherein we launched a website which using AWS services like Elastic Beanstalk, RDS, and the S3, which is a file system service. Then we discussed the AWS solution architect role, what all requirements are there, what is the exam blueprint, and in the end we discussed the exam blueprint wherein we discussed what all topics you should be studying if you want to crack the exam, and the structured training that Edureka follows that will be followed in the further sessions as well, right? So guys, this is what in gist what we studied today. Any questions related to any of the topics that we did so far in this session? So any topic that you want me to repeat, I can repeat it. No hard feelings. Any questions, guys? Okay, so you guys are giving me a go. You're welcome. Okay, so this brings us to the end of today's session. So thank you guys for attending the session today. You guys were a wonderful audience. So see you in the next session. I'll be handing out the assignments in the LMS. So please be sure to do all your assignments and come back in the next session. Also, the code to whatever demo we have done today will be uploaded in the LMS along with the documentation. So you guys have to execute it and come back in the next class, right? Next thing, if you have any problems when you're doing the demo, you always have our support team. Like I say, always. So you can contact our support team and they'll be happy to help you. Okay, guys. So thank you for attending today's session. See you later. See you in the next session, guys. Have a good day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!